Hi everyone and welcome to this 8-hour DevSecOps course, which is for both beginners and advanced. Here you'll learn some core DevSecOps tools such as Kubernetes and Docker, and I will show you how to secure them. As you can imagine, we're going to cover plenty of topics. I will show you how you can use the Docker Content Trust to protect your Docker daemon and hosts. We will apply the Apparmor and the Seccomp security profiles. We will implement the KubeBench Security to audit your Docker host. After that, we will analyze vulnerabilities in Docker images. For that, we're going to use Clair, Qauy and Anchore, and also the CVE databases. We'll talk about how you can manage Docker secrets, networks, and port mapping. At that point, you're going to become more advanced in DevSecOps, so we're going to also explore more advanced tools, such as cAdvisor, Dive, Falco, and administration tools such as Portainer, Rancher, and OpenShift. Finally, we're going to focus on Kubernetes security practices, and I will show you how to use KubeBench and the Kubernetes dashboard to enhance your Kubernetes security. I will teach you how to use very popular tools in the industry such as Prometheus and Grafana to monitor and observe Kubernetes clusters and vulnerabilities. Now that's everything, let's jump straight into the course. I hope you enjoy it, and let me know down in the comments if you would like me to create courses on other topics that you're interested in. Also, if you want to see more of my courses and more courses like this one, you can definitely subscribe to keep up with my content. In this section, we're going to talk about the DevOps architecture for the enterprise. So before learning the DevSecOps, it is going to be quite beneficial for you, firstly, to learn the DevOps architecture, which is what you're going to be doing in this section, and then moving to everything related to DevSecOps. So in this section, we're going to cover a brief introduction to the DevOps in IT Delivery, creating reference architecture, introducing DevOps to the companies, and working with the voice model. But let's start with the introduction. So since this course is going to be focused on implementing DevOps on large-scale companies, so we cover all the cases. And so before we go to the specific challenges for the DevOps and DevSecOps, we need to first have a common understanding for what DevOps is. So basically, DevOps is the development and operation stages working as one team, and this team builds a product and then runs it. It is that simple. So the DevOps has gained a lot of momentum over the past decade, essentially in enterprises. But actually implementing the DevOps is the difficult part. The reason for this is that enterprises are not organized in a structure that works for DevOps. This is because in the last century, most enterprises outsourced a lot of their IT. And for that reason, DevOps becomes way more difficult when development is done in-house while the operations are outsourced. So by bringing the teams together into development and operations environment, the enterprise can speed up the delivery and release new products and services. And in that way, less handovers are needed between the development and the operations. In that way, the quality of the product will improve since DevOps already includes quality assurance, testing, and security. So here I bring in front of you some of the key benefits for DevOps. The first one is that DevOps brings the business, the development, and the operations together into one properly working system. On the other hand, enterprises having DevOps can respond faster to demands from the market because they're absorbing continuous feedback from their work. In the same way, products are continuously improved and upgraded with new features, instead of planning major next releases and wasting a ton of time to create a complete new project and outsource it. And finally, through the automation and the DevOps pipelines, enterprises can really reduce the costs in terms of both development and operations, and at the same time improve the quality of their products. And when building DevOps, the first and the main starting point is the enterprise architecture. This is where the business goals are set and we define how those goals are met. So the IT delivery is key to meeting those goals. So in large companies, the architecture also defines the IT delivery process, and we will specifically look at the IT delivery and its processes in more detail. So as I already mentioned, the enterprises typically have operating model that is based on outsourcing. This makes implementing DevOps more complicated. Normally, the enterprise architect will have to have a very clear view of the connection between the different processes and who is responsible for fulfilling those processes. Basically, who is responsible for what, when, and why. And the next question would be how this can be converted to DevOps. So before that, we first need to understand what are the main processes in IT delivery. And I actually bring here in front of you all of those processes, and let's talk a little bit about them. So first, let's start with the business demand. This pretty much covers what are the business needs and understanding on what the requirements are for the product that's been developed. Those requirements are normally set up by the people that are going to use the product or the clients. So customers will demand product that meets specific functionality and quality. So the architecture must focus on the delivery and the end-to-end product to satisfy the requirements that were defined initially. So in DevOps, an assigned product owner makes sure that the product meets those requirements. The product owner will have to work closely with the software designer. And then we move to the next process, which is the business planning. So once the demand is clear, the product needs to be scoped. In DevOps, the product teams typically start with the minimum viable product. So the first iteration of the product that does meet the requirements of the customers is actually called the minimum viable product. So when designing this product, the processes need to be able to support the development and the operation of the product. So the business planning involves the quality management and testing that are two of the major components on the IT delivery. Then it comes the development process. And in DevOps, the product team will work with user stories. A team must break down the product into components that can be defined as deliverables. To do this, we should have clear definition of the user story. And so the user story always have the same format. So any user story need to have an acceptance criteria or the definition of done or DOD. And once the product is developed, then we can talk about deployment. At this stage, the code is tested, validated, and it matches the user stories. And so now it can be deployed into the production state. So the testing and the releasing of the product is normally automated in the pipeline, so that should be easy once set up at once. So before the code is actually pushed to the production, it also needs to be merged with the configuration. You need to think about the security packages that need to be applied to components that can run into production. So at the test and the quality process, the full package consisting of application code and infrastructure components needs to be validated and be ready for production. So the result after the deployment stage, it should be a live product that is ready to use. So when you're performing testing, if bugs or violations to security are discovered, the product needs to be set back to the earlier stage or to the development. And finally, once the product is deployed, then we move to the final process, which is operations. So after deployment, the live product of course needs to be operated. To do this, enterprises work according to the IT service management principles. In fact, the operators are in the same team as developers, but this doesn't mean that the IT service management principles are not valid anymore. For example, when incidents occur, the incident management process should be immediately triggered. So during operations, they could be looking for requirements fulfillment, incident management, problem management, and so on. So with all those delivery components for the IT process, DevOps actually adds the continuous integration and the continuous delivery, or the CI/CD. You might heard about it, and this is one of the most important concepts when talking about DevOps and pipelines. So let's talk about this. Let's first talk about what is continuous integration. So continuous integration, or CI, is built on the principle for shared repository where the code is frequently updated and it is shared across all the teams that work into a cloud environment. The continuous integration allows developers to work together on the same code at the same time. And so changes into that code are directly integrated and ready to be fully tested in different test environments. On the other side, the continuous delivery is the automated transfer of software to test environments. So the ultimate goal of the continuous delivery is to bring software to production in a fully automated way. So all the various of the test cases should be performed automatically. So after development, the developers should immediately receive feedback on the functionality of their code. And so due to that, the CI/CD requires a feedback loop, and this is why we say it to be continuous. It needs feedback about the delivered products and services. And so this is then looped back to the developers, and from there, new interactions are planned to improve the product or the service. So this works quite well if a single enterprise controls the full cycle and no processes are outsourced to another organizations. However, for many big enterprises, this is impossible, so they have to outsource. However, sometimes activities are not perceived as core activity, and some companies decide to be more cost efficient and to delegate that to somebody else. However, in the past decade, all those organizations have been through a massive change. The IT departments have become more and more important, and in some cases, the software development has become a core activity. And a good example for that are actually the banks. So all the banks are actually IT companies in these days. So the output of their IT delivery are the financial products. So due to the customer demands, releases of those products with new features have become more frequent, and they take sometimes several releases a day. So let's talk a little bit about delivery in a sourcing model. And you can see this on the graph in front of you. So sometimes sourcing can be quite complicated, but if we learn to think in terms of sourcing tiers that you can see right here in front of you, it becomes way more comprehensive and easy to understand. So using this model, we can break the IT delivery into three main phases or tiers. The first one is the strategic tier or the strategic level, and this is the tier for the enterprise governance. The enterprise defines strategic business goals that are translated to enterprise architecture. So the overall architecture principles are the outcomes of the enterprise architecture and drive all IT architecture, including the DevOps. Then in tier 2, or the tactical level, is where the IT architecture is developed, including the DevOps. So here is where the service level agreements and the key performance indicators are defined to measure the outcomes of the IT delivery. And finally, the final tier, which is tier 3, it's called operational or services level. At this tier, the components of the architecture are detailed, including the interfaces to various suppliers and service providers. So the agreements that were defined in tier 2 should be adopted at this level so that all work that's been done for the development and operations is done in the same way. So in practice, the service providers are normally acting on tier 2 if they're involved in larger programs spinning on multiple products. So at this tier, the provider is responsible for aligning the different streams in the lower tier or tier 1. So here is how the sourcing models are looking like, guys. This is going to be the end of this video, and in the next one we will talk about creating the reference architecture. Thanks for watching. Hi everyone, and welcome back to the course. In this video we will talk about how you can create a reference architecture integrated with the DevOps. In the previous video we were looking at the different processes of the IT delivery and how it is integrated into the DevOps. So any DevOps architecture will have to address planning, development, integration, deployment, and operations. But we have to keep in mind why we're doing DevOps. And this is to achieve the business goals in a faster, more agile way and to continuously improve products. The DevOps architecture doesn't stand on its own. It has to be linked to an enterprise architecture. To do that, we're normally using the Open Group architecture framework designed with architecture development method to draft architecture. And this is what you can see in front of you. In the figure right here, you can see the architecture development method. So just like the DevOps, the architecture development method is a cycle, except in the very first phase, which is where the need for architecture is formed. This has to be done in tier 1 in the sourcing model that we discussed in the previous video, and the core of the architecture development methodology is a sequence of architecture design which is business first and setting the principles and the requirements for the actual solution. Those principles drive the architecture data usage, the applications, and finally the technology that will be used. This is important because architecture is not about technology in the first place. Technology is purely the ability to achieve business goals in the enterprise level. So the architecture developing method assumes that the architecture is not static. It changes as soon as the business requirements change too. If the business demands change, there will likely be a need to adapt to the architecture in the future solutions. So, as we discussed in the previous video, there were 3 tiers, and in tier 1 is where the goals are set for the entire enterprise. In the next level, in tier 2, is where the DevOps teams will translate the goals into product features and start developing the product. DevOps teams will have to work according a set of principles. So let's take a closer look at those principles. So in fact, there are actually 6 DevOps Agile skills principles, and those are very first the customer-centric action, which is to develop an application with the customer in mind, what they need and what does the customer expect in terms of functionality. There is also the goal of another concept, domain-driven design, which contains good practices and ideas. Then, when you build a project, you always need to have the end result in mind, or how will the product look when it is completely finished. With the end-to-end product in mind, it comes the end-to-end responsibility. And here the teams need to be motivated and enabled to take responsibility from the start to the finish of the product lifecycle. Principles such as you build it, you run it, you break it, and you fix it is one of the key principles for taking responsibility. Then we need a cross-functional automation teams. They need to be able to make decisions themselves in the development process. Then, as we talked in the previous video, a continuous improvement is quite important for every project, and we need to continuously improve our product. And finally, in order for our project to be very efficient, the goal of the teams should be to always automate as much as possible. The only way to regain speed in delivering and deploying is by automating as much as possible. Automation also limits the occurrence of failures and bugs in your code. So, based on these principles, they're leading to some architecture statements that are the core of the DevOps. Those principles are automation, which is basically responsible for automating everything. With automation, the amount of time between testing and deployment will be significantly reduced, enabling a faster release process. But on the other hand, automation will also lead to way less manual interaction and therefore less errors. The next architecture statement is collaboration. So you remember 2 of the 6 principles are cross-functional automation and end-to-end responsibility. This can be only achieved by a very good collaboration. Development and operations will have to work very closely together to speed up the delivery and the releases. Although this is also a cultural change, collaboration requires common toolset that supplies that collaboration. So automation also requires a clear portfolio that contains building blocks that can be automated easily. These building blocks are called artifacts in the ADM cycle. and they represent packages of functionality that can be used to fulfill requirements. Some of the most famous tools for keeping artifacts are, for example, Artifactory. The building block is reusable and replaceable, and therefore it must be clearly specified and defined. So the configuration of the building blocks needs to be well documented and brought under control of the configuration management. If this is done well, those building blocks will also have clear interfaces so that they can be fully automated. And finally, let's talk about integration, which is where the development and the operations come together. In DevOps, we integrate the business demands and the IT delivery user stories. Code is normally integrated with new functionality that is coming out of the business demand. The demand is changing faster those days, so development needs to keep in mind the continuous integration. This will lead to changes that adopt new development at some very good speed. So the final step to merge the DevOps principles into one model for our reference architecture is to build the reference architecture model. So the model contains two main cycles, and as you can see from the figure, there is outer cycle, which is right here, and also there is an inner cycle. So the outer cycle is the product cycle, while the inner cycle represents the operational activities. And so as a logical consequence, the outer cycle is governed by the enterprise itself. The inner cycle, it's about actually delivering the product using DevOps. And as you can see, there are interfaces between the outer and the inner cycles. And those are collaboration, automation, integration, configuration management, and the interface layer. So in the outer cycle, the business goals are translated into architecture. From the architecture, a portfolio is created with business blocks to create products and services. Products are released to the market and adopted, but due to changing demands, there will be requests for changes. So those changes will drive new enterprise planning and some change into the business goals. So in that way, the business will continuously absorb the change in demands. So the plans and the actual builds are expected to be executed into the inner circle, as you can see here. In this circle, the product is broken down into product backlog items that will be developed and eventually operated by the DevOps teams. These teams do not operate by themselves, but they are triggered from the outer cycle. So this is why we need the interface layer. This is the interface between the business and the execution teams doing the IT delivery. So there is a collaboration between the architecture and development. And as we mentioned before, the releases should be automated as much as possible. And so requests and changes should be integrated with the planning on the backlog of the DevOps teams. And so the builds are pushed to production, and those ones that are actually pushed, they need to be monitored and brought under control from the configuration management. So let's see how this would actually work in practice by the next figure. So here you have some people within the model that you saw in the previous slide. And this is basically the DevOps workflow for enterprises. So you can see that from the enterprise, we're getting the business plan, and then this is passed to the business unit. From there, it goes to the product owner, which distributes the work to the different teams. On the other hand, the enterprise architect works with a security officer to build the enterprise architecture that translates into portfolio that builds a roadmap. From there, we can actually trigger the DevOps cycle where we create a product, architecture and backlog, and we're running continuously everything on pipeline in order to implement every new change and have a continuous development and integration. So I hope that from this video, guys, you really got a good introduction on how DevOps is implemented into IT delivery. That's it. Thank you very much for watching. And in the next video, we'll talk about the DevOps components. Hi everyone, and welcome back to the course. So far, we learned how to start defining the architecture, looking at the architectural principles of the DevOps, and drafting the reference architecture model. So the next step is to look at the different components within the DevOps. So in this video, we'll learn what components must be included into the DevOps architecture. And this is actually the tier tree from our tiers figure of the target enterprise model. And this is the level where all activities should be executed. So here in front of you, you can see the agile infrastructure, and the reason that this looks as infinite loop is because feedback from the live product that is managed by operations will continuously be looked back to develop and improve the product. And this is from where the DevOps comes. Dev from development and Ops from operations. So as you can see here, the different components are planning, creating, testing or verification, then preparing, releasing, configuring, and finally monitoring. And from the monitoring, if we see that we need certain improvement, then we jump back to the plan station. So remember that at large enterprises, you will likely work with several service providers that are fulfilling parts of the IT delivery process. So when we want all of these components to work together in a DevOps way, we need to make sure that the process and the tools are aligned. And so the next thing is to have common understanding for the various activities that are executed as part of these principles. And so all DevOps components must be defined and implemented in a consistent way. Every developer and operator should work accordingly to the same definition and within the same components. And so from here you might have the question, at what stage the DevOps should be developed? And the answer to that question is as early as possible. The operations play a key role in defining new products and bringing them to life. They should set the requirements and the acceptance criteria before the product go to life. And so if developer builds something that cannot be managed by ops, the product will fail and the business demands will not be met. So typically the enterprises conduct SLA or KPIs to fulfill their processes so that these are enabled into the business goals. If one of the processes fails, the product will be impacted as an ultimate consequence, and so the business will not achieve its goals. So understanding SLA and the KPI is important for any architect. This is why it is included into the surrounding model that we will also discuss. So the service level agreements are positioned between the tactical process of DevOps and the strategic level at the enterprise level where the goals are set. So the SLA and the KPIs should support those goals and guide the DevOps process. So you can see here in front of you 6 of the most important matrices that should be included into the SLA for DevOps. And those should be frequency in development, and this refers to that the DevOps teams usually work in sprints. This is a short period of time in which the team works on a number of backlog items as part of the next release of a product. The KPI measures how often new features are launched on a regular basis. And here keep in mind that the new features can be scheduled on a monthly, weekly, or daily basis. Then the development time is usually the time between the code being released after the test phase. Then the deployment failure rate on the other side refers to the rate of failures that occur after deployment. Ideally, this number should be 0, but this is not realistic. Deployments, especially when the change rate is high, will fail every now and then. Obviously here, we should aim that this number is as low as possible. Then we have the matrix that is called deployment failure detection time, and this is due to the fact that KPI strongly relies on the previous one. So failures will occur, but then the question is how fast are those failures detected and when we will be able to fix them. So this type of KPI is also referred as mean time for recovery, and usually this is the most important KPI on the DevOps cycles. And then we have the change lead time, which is the time that is between the last release and the next change to occur. Subsequently, it is measured in terms of how long the team will need to address a change. Shorter lead times indicate that the team works quite efficiently. And finally, we have the full scale time. I know that there are a lot of times here, but as you can see, the definition of time during DevOps is quite important. So the full scale time is the total time that is between the different iterations for each development. So this is the main list that I wanted to share with you. This list is of course not executive, and so the enterprises can think of a lot of different metrics and KPIs that they want to implement. But I would always advise you to keep the things simple. Keep in mind that every matrix that is included in any contract needs to be monitored and reported. And this could become quite expensive and time consuming. So let's talk a little bit about the team value on the project, and this is usually implemented with the voice model. So the DevOps teams need to deliver value to the end customer. This is their main goal. So the voice model is specifically defined to address this. As you can see from the graph, the voice model includes value, objectives, indicators, confidence, and experience. Voice. The idea behind the model is that any IT delivery should deliver value to someone, typically the end customer of the business. Value sets the objectives of the IT delivery, and those objectives are measured using indicators. So indicators measure whether the pursued value is achieved. Then confidence is all about the indicators and if they contain relevant information to confirm that the IT delivery actually results in the targeted value. And lastly, the experience basically tells us if the delivered system is fulfilling the business demands and which improvements will lead to more business value. And then the circle starts again from value. So since the voice model also involves looping feedback back to the beginning of the cycle with the aim of improving products and adding more value to business, the model can be used for any DevOps project. So thank you for watching this video and this section, guys. I hope you learned a lot about the DevOps, and in the next video we will continue our introductory sections with the DevSecOps, so we're going to add the security level there. Thanks for watching, and I will see you in our next section. Hi everyone, and welcome to this section in which we're going to introduce ourselves to DevSecOps ecosystem. So as everything into the IT world, the DevSecOps requires architectural foundation. So in this section, we will learn how to compose a reference architecture for the DevSecOps, and there's some practices to design the pipelines with the DevSecOps. We will also discuss the best DevSecOps practices for the major public cloud providers such as AWS, Azure, and Google Cloud. So in the previous section, we were discussing the principles of the DevOps, and so we concluded that security should be at the heart of every setup in the development lifecycle, from the moment where the code is pulled from the repository to the actual code being committed and pushed to the production. So the DevSecOps consists of three main layers. The first one is the culture, and this is not a technical layer, but it is quite often forgotten that DevOps is much more than applying tools and creating CI/CD pipelines. Obviously, the same applies for the DevSecOps. Within the DevSecOps, every team member feels responsible for security and acts accordingly, taking ownership of it. This doesn't mean that the security specialists have become obsolete though. It's good practice to have security engineer or professional in your team, sometimes referred as a security champion. This person should lead out the processes in the team for applying security standards and policies to ensure compliance. The next layer is the security by design. So the security is embedded at every layer of the system. This typically means that the enterprise has a detailed architecture that covers every aspect of security and enforcing security postures into systems, such as authentication, authorization, confidentiality, data integrity, and more. Software developers do not need to think of security every time they design and build new applications or features. And the final layer is the automation, because in DevOps we want to automate as much as possible, and the same accounts for the DevSecOps, because this also includes security. So by automating the security, we can easily prevent human error, and we can create automation tools to scan for possible vulnerabilities or non-compliant components such as unlicensed code. Automation also implies automated audits and collection of evidence in case of attack. So the automation process makes sure that security metrics are collected and sent back for feedback in the DevSecOps practice. For example, when you scan vulnerability in the code, an evidence from that scan will be collected and will be sent for feedback. So to manage those three layers, the DevSecOps relies on four main components, and those are harnessing responsibilities, application security, cloud platform security, and vulnerability assessments and testing. And so the DevSecOps should not be mixed with the security as a service. The security as a service can be compliant with the DevSecOps practice, but the concept of the security as a service is mainly about shifting security as responsibility to a service provider. This is a sourcing model that allows enterprises to get cybersecurity delivered from a service provider on subscription base. There are good reasons for implementing the security as a service, and one of them is that a provider is responsible for all security updates based on the latest insights. Enterprises can define security level agreements for incident response times and the timely application of security practices. So, before we discuss the reference architecture of the DevSecOps, we need to understand what the role of the DevOps is and how the security fits to it. So, DevOps is about the software development lifecycle. An important note is that we have to make sure that we know the fact that the developers increasingly use open source tools. This makes sense since provides great flexibility when developing new code. Open source is community driven, so developers can contribute to each other's code and speed up the process. Projects can be shared at open source platforms such as Git and GitHub repositories, but they can also be shared internally within the enterprises. So the inner source type projects are a good example of projects that are held internally. So inner source uses open source best practices for software development within the boundaries of the organization. In fact, we need security from the start of the DevOps process. In practice, this means that we start scanning for security issues from the moment the code is put from the repositories. The repositories are part of the software development lifecycle as well, so they should be protected from unauthorized access. And so this calls for role-based access, and identity and access management are quite important for the repositories. They're called RBAC and IAM. So you should keep in mind that we can create reference architecture for DevSecOps within those four components. The first one is a repository access within the role-based access control, the static application security testing, which will detect errors in the source code, the software composition analysis, which will detect dependencies in the source code, and finally the dynamic security testing, which will dynamically scan the code every single time. Those components are embedded into the DevSecOps pipeline and are quite important. So that's it. Thank you very much for watching, guys, this video, and in the next one we will talk about how we can compose the DevSecOps pipeline. Thanks for watching. Hi everyone, and welcome back to the course. In this video, we will talk about the concept for building DevSecOps Pipeline. So right here in front of you, you can see two pictures, and here on the top, you can see the DevOps pipeline first, and then in the bottom, you can see the DevSecOps pipeline. So let's first talk about this graph here on the top. So you can see that here we're having 4 steps, which are pull code from the repository, then build that code, then test it, and finally once the code is tested, then we need to deploy it. So you might think, what else do we actually need to add to this pipeline? It looks perfect. Well, the main thing that this pipeline is missing is security. So this is the main thing that we're adding to the DevSecOps pipeline. Using DevSecOps, we're actually integrating the security standards and principles as part of the pipeline. So security is a layer that's applied to every step in the pipeline, but it does actually include several steps. And you can see them right here on the figure below. So you can see that pretty much most of the steps are the same, and we have the pull code from the repository, build it, test it, but here we're adding this security scan test before the deployment. And you can actually see that the security scan is composing of 5 more items. So let's talk first about the dependency check. So the first vulnerability that exposes the code to a risk is the fact that the code actually relies on different pieces of code in order to run, and there are differences in the code dependencies. So developers can have controlled and uncontrolled dependencies. As a common practice, we don't want dependencies in our code. The risk is that if the code that the dependency relies on is breached, the entire application might fail. Alternatively, malware that's injected in certain piece of code but has a dependency with other code will infect the entire code stack. For that reason, the main rule here is to eliminate the dependencies, which is one of the basic principles for zero trust. So you might know the most common tools to manage your packages, such as the pipe in Python and the npm in the Node.js. So commands such as pipe env check and npm audit will actually show you the dependencies. And we're going to try and test each of those commands into the next sections, which are more practical ones. Then there are the static analysis, and those are checking the bad coding practices, such as the bad configurations. There are quite a few open source tools for almost every coding language. Then in the scanning section, developers will likely use continuous usage of containers and container images to build and package their applications. These images need to be scanned for vulnerabilities in the libraries that they are used. The scanning is done with some basic lists of known vulnerabilities. You are basically checking some known vulnerabilities and execute commands in order to see if they exist in your code. The scanning can be built by industries such as the NIST cybersecurity framework or from other software providers. And finally, there the dynamic analysis are basically automated web applications that are continuously scanning to check bad handlers or missing tokens on your application. So those tokens prevent typing unauthorized commands that might come from untrusted user, or it can simply be a function on a different website. So following the diagram, now we're having a security embedded CI/CD pipeline that will automatically cover the most common vulnerabilities recognized in the code. There is one specific item that we didn't touch in this section, and this is the use of containers and how they can secure our applications. So let's talk about them next. So most developers will use containers to wrap and deploy their code. Typically, those are the Docker containers. Docker is a very famous application that is used particularly for this reason. There are some best practices when it comes to using security containers. To keep containers consistent and secure, they should be scanned regularly, even when the application has reached a steady state and updates are done less frequently, or the active development has stopped. If the application still runs with its underlying containers hosting the different application components, those containers must be scanned, since there is always a possibility that the dependency is creating a new vulnerability. Applications consisting of containers are normally defined by the Docker files. You can use linting, which is analyzing the codes for errors or bad syntax, and that can be used in the Docker files to make sure that those files remain secure. A popular linting tool to use for that purpose is the headulint tool. So this tool is available as a Docker image and can easily be executed with the command that you can see in front of you. So what you simply need to do is to write docker run rm-i headulint/headulint, and we'll explore these options once we start installing and organizing our Docker images into the next sections. Docker also recommends some best practices for keeping containers secure. So Docker already takes care for the namespaces and the network stacks to provide isolation so that the containers can't obtain privileged access to other containers, unless this is specifically specified in the configuration. So some specific things to consider is that Docker always uses Docker domain. This domain requires root access, which implies security risks. The first thing is that only trusted users should be allowed to set controls on the domain. You also need to take action to limit the attack surface of the domain by setting access rights to the Docker host and the guest containers, especially when working with containers provided through API web server. So if we follow up the recommendations for Docker, we will have trusted, immutable images that we can use to deploy containers on Kubernetes, for instance. And Kubernetes, for which we'll really talk in detail in our next sections, will actually use the trusted image repository and take care of the provisioning, scaling, and load balancing for the different containers. The security features of Kubernetes is the support for rolling updates. If an image repository is updated with patches and enhancements, Kubernetes will deploy new versions and destroy the previous ones. So in that way, developers will always be sure that only the latest versions of images are used. So database credentials, API keys, certifications, and access tokens must be stored in a safe place at all times. The use of CI/CD and containers doesn't change that. It is strongly recommended to use a vault outside repositories that the pipelines assess for CI/CD. So the best practices for secret management you can see right here in front of you. They're account to 3, and the first one is encryption with AES 256 encryption keys. The second best practices is that secrets such as keys must never be stored on Git or GitHub repositories. They should be stored in some local space. It's also advised that secrets are injected into application using secure string as an environment variable. So for example, if you have a project, it is not recommended to just type this key as a string into your code, but instead you can create an environmental variable, assign to that variable the key, and then simply pass it to your code. So for example, HashiCorp offers Vault as an open source solution for security assessing secrets. The service allows to easily rotate, manage, and retrieve database credentials, API keys, and other secrets throughout the lifecycle. Even more robust solution can be provided by a service called CyberArk, which is a platform independent on secrets management solution specifically created for securing containers and microservices. So these tools or these security tools could be integrated to Azure and AWS, and so you can use, for example, Azure Key Vault or AWS Secret Management. So this is actually something that we will talk in the next video, and there I will explain you how you can secure your AWS, Azure, and Google Cloud platform using DevSecOps. Thanks for watching. Hi everyone, and welcome back to the course. As I promised, in this video we will talk about how to use DevSecOps with AWS, Azure, and Google Cloud. So let's get started. So in the previous videos, we discussed the DevSecOps principles and how the pipeline is built with embedded security. So in this video, we'll look at the best practices for applying DevSecOps in the major public cloud platforms such as AWS, Azure, and Google Cloud. So let's first talk about how we can implement DevSecOps on AWS code pipeline. So before starting to explain the DevSecOps in AWS, we need to understand that deployments in AWS should be based on the principles of the Cloud Adoption Framework. The framework covers specific security tasks and responsibilities grouped into 4 categories, and those are prevention, detection, correlation, and direction. So as you can see on the figure in front of you, AWS offers native solutions to provide controls for managing security postures for CI/CD pipelines. So here on the pipeline, you can see the different steps organized. So an important artifact here are the security groups. As you can see, those could be bins where the security posture of all of the components that are developed and deployed in the pipeline are defined. It contains templates and policies that have to be applied to those components. So you can see that the code is going from the Git repository to S3 bucket, which basically is something like a drive in which we can place any type of data, mainly used for images. Then we put the code to the code pipeline, and then it goes to the different security groups. So the static code analysis are performed on the code that is pulled from the S3 bucket right here. So once we pull the code from the S3 bucket, we're creating a stack of containers that contains virtual private cloud in AWS to run tests. So those tests are used to run the code on the stack and validate the build. AWS calls this stack validation, and then certain Lambda functions validate the stack against each and every security group. Okay, so everything that has to be defined into the security, we need to meet in those security groups. So this is the second station, which is a test. And so after that, we're running into the production. So in the production, after the successful stack is validated, a Lambda function is triggered to prepare the stack for production using the CloudFormation templates. So examples of items that are checked against security groups can be validated using access and permissions, access controls to the S3 bucket, and policies to create instances using, for example, EC2 compute resources. So Microsoft Azure actually uses a different approach from AWS when implementing DevSecOps. This solution leverages the scan possibilities of GitHub. It also leverages the features of the Azure Kubernetes services next to the Azure pipelines. And you can see it right here. So here in this diagram, you can see high-level architecture for a security embedded CI/CD pipeline using GitHub and Azure services. You can also see certain numbers in the diagram, like right here is 1, then 2, 3, and 4. Okay, so those numbers represent the order in which each step is taken when working on the cloud. As soon as the containers are pushed to the Azure cloud repository, they're scanned against the policies that are stored in the Azure policies, right here that you can see. So first we push the containers, and after that, in the next step, we're validating against the Azure policy. So after that, the appropriate security keys right here are fetched to authenticate the containers to the Azure Kubernetes service. Only when all checks have passed successfully, the code will be then pushed to the application gateway. So if we look a little bit more in detail, we can see that the Azure cloud is quite secure, and the solution starts with the code analysis in GitHub, which involves using code QL to detect vulnerabilities in the source code and dependencies respectively. Then once the code has been validated, it's packed to Docker container and deployed to a test environment using the Azure dev spaces. This is done through the Azure pipelines. So the Azure dev spaces will build an isolated test environment for the Azure Kubernetes service. Then when we scan our code, containers are stored into the Azure Container Registry where they are scanned against the security protocols. To do this, Azure uses the Azure Security Center, which is a huge library that holds all security policies for the environments enrolled in Azure. And finally, when we reach our production stage, the scanned containers are pushed to Kubernetes cluster using the Azure Kubernetes service. Azure policies are used to validate the compliance of the provisioned clusters and containers. So just like the AWS, Azure uses several different solutions to provide end-to-end solution that embeds security roles, policies, and postures throughout the whole CI/CD process. However, all those solutions start with repository where those security guidelines and guidances are stored and managed. Security groups that are managed through AWS Security Hub are located into the Azure Security Center. So let's see how the DevSecOps are actually implemented on Google Cloud. Well, this is normally done using the Anthos and the JFrog methodologies. So the Google Cloud involves interesting best practice solutions for implementing the DevSecOps pipelines using JFrog. So it doesn't only provide cloud native pipeline, but also a solution for developing and deploying hybrid environments using the Google Cloud and the on-permission systems. This is quite interesting for enterprises since a lot of enterprises will not move their IT systems completely to public clouds. Most enterprises are expected to move more and more systems to the cloud, but some of their system will remain private in the stack. So CI/CD pipelines that are suitable for both cloud and on-permission solutions are quite favorable, and with Kubernetes they're quite easy to set up. So you can see the architecture here in front of you using JFrog right here and Kubernetes. So there are two major solutions, and the Google Cloud advocates for using JFrog Artifactory and JFrog X-Ray. So JFrog Artifactory takes care of storing artifacts that are used when building applications. So we already saw how pipeline starts by pulling code from the source repositories. Developers need to be able to rely on the tooling that stores and other artifacts, code building blocks, in a comprehensive and safe way so that software delivery to the pipelines can be automated. And I've been actually using and still use Artifactory for my current projects in the company I work for. The JFrog X-Ray scans the artifacts and the code building blocks through Artifactory against known vulnerabilities and license compliance. X-Ray uses the shift left mentality by already scanning the source artifacts. And you can see the complete diagram right here in front of you. So JFrog is basically using X-Ray as the main security solution that is embedded to the pipeline. Builds are taken and then pushed to the production using the Kubernetes Google Cloud Platform and on a platform called Anthos. So Anthos ensures a consistent layer of deploying and managing Kubernetes clusters across the native cloud of the Google Kubernetes engine and on permissions. This solution is only feasible with Google Cloud, but can be also used on the VMware stacks as well as on the AWS as well. So this is how DevSecOps can be implemented on all of the major cloud service providers. Thanks for watching that video, and in the next one we will talk about how you can plan your development and about the main cybersecurity frameworks. Thanks for watching. Hi everyone and welcome back to the course. In this video we will plan our deployment of the DevSecOps and also we'll talk about the industry security frameworks. So let's get started. Now, so far we discussed the reference architecture of the DevSecOps pipelines and the best practices for AWS, Azure, and Google Cloud. If we have the architecture, the next step would be planning and deploying DevSecOps and the pipelines to our enterprise. There are three major steps that most of the companies will need to implement the DevSecOps. The first one is to assess the enterprise security. So enterprises will likely already have adopted security policies and taken measures to protect their systems. They will also need to adhere security standards and frameworks because of the governmental and industry regulations. So security specialists will have to consider the risk assessments and have to analyze the possible threats. Those specialists should understand and manage the security controls. There is by default a starting point which involves these practices of managing security into the DevOps practice. So DevSecOps should never start without including security policies and standards for developing and deploying new code or a pilot project. So the next step would be to embed security to DevOps. Security policies and standards are integrated into the development process. The DevOps workflows are matched against the security guidelines. This includes vulnerability testing and code scanning. So without processes and tools in place, DevOps can't start developing new code. The risk of increasing the attack surface and causing permanent damage to the enterprise is too big in that case. So companies, both big and small, are under consistent threat of hackers and security threats. And this brings us to the final step. So the DevOps and the DevSecOps are not only about technology, it's a way of working and even thinking. It is basically a culture and people need to be trained in adopting that culture. So staff, developers, and operators need to be trained consistently to do their tasks. Developers, operators, and security engineers need to fully be committed to applying the security controls in their work, and that implies that they should always be aware of the risk for the enterprise or that the enterprise is facing in terms of security. And of course, proper tooling is quite essential in order to achieve that, at least at a minimum. And so tools for testing are quite recommended, and testing is actually one of the critical elements of the DevSecOps. The market provides a massive number of tools for performing tests. The next type of tools that we need to have are the alerting tools. So when security threats are detected, alerts need to be raised and sent out. Then we need to have tools for automated remediation, and those are tools such as StackStorm to help providing remediation as soon as the security issues are detected. And finally, it's always good to have visualization tools because developers and operators need to be able to see what's going on in the systems. So you can use plenty of tools in order to achieve all those goals, and they would be mainly third-party tools that can be integrated into the DevOps tooling for either AWS, Azure, or Google Cloud. Of course, public cloud platforms themselves offer extensive security tooling. So the benefits of the DevSecOps should be clear now. But we should know that with the DevSecOps, we can achieve better collaboration between developers, operators, and security engineers. And with that, we will ensure that security threats and vulnerabilities are detected at an early stage of development so the risks to the enterprise are minimized. So, because the IT becomes more and more complex over the years, the IT security is of a key importance. The level of security that is required will, of course, differ for every industry, but first of all, financial institutions will want to make sure that bank accounts can be compromised and that money are not being illegally transferred. Or on the other side, healthcare institutions will need to protect their patients' personal and health data. And in order to do that, you need to have some common rules that everybody follows, and an organization is certified if it complies with those rules. So, before to learn how the security frameworks impact the CI/CD and the DevOps, we need to understand those frameworks. So, basically, a framework is a set of policies and documentation guidelines on implementing and managing those best practices for different types of organizations. And actually, I have very good courses on NIST cybersecurity and risk management framework that you can definitely take a look because they cover all the security practices that can be applied to DevOps and DevSecOps. So, some of the most famous practices that you should be aware about are firstly the ISEC 27001, which is an international standard for system security controls that emphasizes on controls that detect threats that will have severe impact on the availability and the integrity of the systems. Then you have the NIST cybersecurity framework that doesn't specify controls, but it does provide 5 functions to enhance security. And those are to identify, protect, detect, respond, and recover from a risk. Those functions will allow organizations to set controls to manage data breach risks. Controls should include access controls, measures to protect data, and also awareness among staff. Then we have the CIS framework, or the Center of Internet Security Framework, which offers extensive frameworks with specific controls for platforms, operating systems, and databases, even containers. Some of the CIS frameworks are embedded into the platforms such as Azure or AWS, and the CIS benchmarks could be assessed easily through Azure Security Center and AWS Security Hub. And finally, there is the COBIT framework, and COBIT stays for Information System Audit and Control Association. So COBIT was about identifying and mitigating technical risks in the IT systems, but it also covers the business risks and the release of those risks that are related to IT. So those control frameworks, guys, could have additions that cover specific industry requirements, but typically industries have to incorporate their own standards or be fully compliant with the existing ones. This is important when industries are audited. So that's it. Thank you very much for watching that video, and actually this will be the end of this introductory section for the DevSecOps. I hope it was helpful, guys, and in the next sections we will start with more practical exercises using Docker and Kubernetes. Thanks for watching. Hi everyone, and welcome back to the course. In this video I will show you how you can install Docker from the command line into your Linux machine. So I'm using a basic Linux distribution which is Ubuntu made, but this installation will work pretty much on any type of Ubuntu. So firstly, make sure that you're logged in as a root user and you're into your terminal. So you can be sure that you're logged in as a root user by writing who am I, and you can see that you're root, and if you're not, you can simply do sudo su, and this will give you the root privileges. So after you do that, let's make sure that you have removed all Docker distributions from your device if you previously have installed it. So let's do sudo apt get remove docker and then docker engine docker.io contained run c. So it is okay if the apt-get reports that none of the packages are installed. This is completely normal, especially if you don't have previously installed Docker. So then go to docker.com engine install Ubuntu, and let's copy the rest of the lines so you can save some time. So you can copy the sudo apt-get installed for all of those certifications. So let's go back and simply paste it. Okay, paste. So that will upgrade all the apt-get certifications. Then let's make a new directory called key writes. So let's do that. Then copy the next line. Okay, and just paste it. So this is pretty simple. Simply copying and pasting what you get from docker.com. Select yes here. Okay. Then let's set up the repository with the command below. So let's copy that, paste it as well. Okay, and finally you can install the Docker engine. So let's copy this command here, and this will pretty much install the command line tool for Docker. So let's do that. And as you can see now, guys, Docker is successfully installed into your device. And if you write docker -- version, you can see that Docker is installed with version 20.10.18. So this is how you can install Docker for Linux. And if you do, for example, images, you can actually Docker images. You can see that I have installed a few images. For you, this will be empty. But once we start installing images, then you will be able to see something here. And also you will be able to create containers from the command line. That's it. Thank you very much for watching. This is how you can install Docker in Ubuntu. The guide is pretty straightforward, and please enjoy the rest of the course. So let's now go to the terminal, guys, and here let's see how you can use the audit tools. You can do that by a command called auditctl. Okay, and you can see that I currently have this command installed, but if you don't have that set up, you can simply write apt get install auditd. Okay, and this will pretty much install the tool. As I already have it installed, my installation is quite quick, but for you it could take about 1 minute or less. So in order to indicate to the audit framework which directory or file we want to observe by using the path. For example, if you want to check out the etc passwords, we can simply do auditctl-a, always -f path equals /etc/password. Okay, and then you can do -f perm equals to wa. And so when I hit enter here, also make sure that there is no space between the comma and the always. So when I hit enter, you can see that for me this rule already exists, but for you, since you write the command for the first time, the rule will be created. So let's now go to the rules file, and you can do that by doing cd etc/audit and then rules. Okay, let's go there. Let's do ls, and here you can see that there is a file called audit.rules. Okay, and after that, let's open this file. So just use your favorite editor, and I will use vim audit.rules, and you can see that here we are having a few arguments. So here you can see the different rules, and those are the rules that enable you to audit certain directories. So you can copy and paste those rules right here. Okay, I will attach those in the description of that video, or actually into the description of the whole section, so you can use them and write them right here. So let's save this file. Okay, and then simply write sudo service auditd restart. So now logs will be generated, and if I write cd, okay, here I'm in audit. So if we go now to cd var, okay, then go to log audit, okay, you will see there that we have a file that is called audit.log, and let's check out this file. So let's do more audit log, and you can see that here we're having a huge log for the audit that has been completed on your Docker system. So you don't actually need to know what is inside this log, and I'm not gonna manipulate the parameters right here and observe them, but the whole idea of that lesson is that you know how you can export log for a particular system by adding the rules and also knowing the location of the log that is generated. So this is how, guys, you can audit the entire files using the audit CTL tool. Thanks for watching this video, and in the next one we'll talk about the Apparmor, which is a quite useful tool for assigning each running process on your system to a secure profile. And we'll observe things like file system access, network capabilities, and execution rules. That's it. Thank you very much for watching, and I will see you in our next video. Hi everyone, and welcome back to the course. In this section, I'll review the main containers or container platforms that provide infrastructure for both developers and operation teams. And the main ones that we will cover are the Docker and the Kubernetes. I will also review some alternatives like Podman and other platforms. So the containers are one thing that are very important, and they're helping to streamline the process of moving applications through development, testing, production, and so on. Docker and Kubernetes are really helping to reinvent the way applications are built and deployed as collections of microservices rather than previous monotonic approaches. So DevOps aims to improve the quality of the new software versions and accelerate the development, delivery, and implementation because of its effective cooperation with the continued automation. So automated DevOps tasks include automated build processes, static and dynamic code analysis, and performance testing. The core spine of the DevOps is still reflecting the continuous integration and continuous delivery of the automatic deployment of applications. So, of course, Docker must offer options for consolidating CI/CD tools like Jenkins and allows you to automatically load your images from the Docker Hub repository or version control repositories like GitHub or Bitbucket. This is how the container platforms represent the base of the DevOps workflows. And in those, developers can create new components for application in common and run them into any testing environment. So let's talk a little more about Docker. So Docker is a container platform to quickly develop, deploy, and manage applications, and its main task is to package software into serialized units called containers that include everything necessary for the software to run, including libraries, tools, or code. So with Docker, you can deploy and quickly adjust the scale of applications in any environment and be sure that your code will run the same. You can do that in production environment or in cloud or local location. You can always access the hub.docker.com, which is a repository where Docker users can share images that they have created with others. So for Linux or Mac or even Windows, it is quite easy to download and install those containers or applications into the Docker package manager. So let's try to make a difference between containers and virtual machines. Now, you can see in front of you a diagram that is defined by Docker in which applications run inside completely independent containers. So we will compare the Docker application containers with other type of environments such as the virtual machines. So as you can see, containers have multi-level abstraction above the hardware abstraction. Virtual machines allow the abstraction of physical hardware, while the hypervisor allows multiple virtual machines to run at the single computer. Each virtual machine includes a full copy of the operating system applications and the required libraries. However, with the use of containers, resources can be isolated and services can be restricted. In that case, processes are given the ability to have an almost completely private vision of the operating system with its own process space identified. So as you can see, multiple containers share the same core, but each container can be restricted to using defined amount of resources such as the CPU, memory, or input-output resources. So because of this container structure, Docker takes better advantage of the hardware and only needs a minimum system files for its services to work. It doesn't need multiple versions of the same operating system installed in virtual machines. So the containers in Docker are self-managed, so they don't need anything more than an image of the container for the services to work. A Docker image can be understood as an operating system with dependencies for supporting installed applications, and so the container is created from a particular image and it always works. Docker's images are also portable between different platforms, with the only requirement being that Docker is installed and the service is running on the host system. You can also use repository of images such as GitHub or Bitbucket code repositories, and this service is called Docker Hub Registry. So let's talk about the Docker architecture. So you can see on the graph in front of you the complete Docker architecture. So because of its architecture, Docker offers a great portability because all the containers are portable, so we can take them to any other Docker device without having to reconfigure anything. And so Docker allows you to run your applications locally on any operating system and on any cloud server such as Google Cloud or AWS. You're getting great performance because all the containers are based on Linux containers which runs directly on the kernel of the host machine, avoiding traditional visualization layer that is common for other platforms. And the best thing is that Docker is responsible for everything. So all the containers will have everything necessary for the application to work, and you will see that in our next videos actually, where I will show you how to install Docker and run Docker containers. So as you can see on the figure, Docker uses client-server architecture where the client port communicates with the server port right here and the daemon, so that is in charge of building, executing and distributing containers. Client and server are able to run both on the same host and on different platforms as well, since the communication between them is performed using the RESTful API services. So let's talk about the different components in this diagram. Now, firstly, the Docker engine or the daemon, which is basically the main core of Docker, is a process that runs on every Linux distribution and exposes itself to external API for management of the images and containers. This process is responsible for creating images, uploading and downloading Docker registry, and executing and managing containers. Then we have the Docker client right here, which allows you to manage the Docker engine and can be configured to work with a local or remote Docker engine. It allows us to manage both local development environment and production environment. So this is connected to the Docker image, which is simply the template that is used to create container for the application that we want to deploy. And then we have finally the container right here, and those have the folders with everything necessary so that the application can be executed. The Docker tool offers the ability to package and run an application in an isolated environment that is actually called container. So to use the Docker, you can use the command line interface, communicate between the servers and the client, and to do that, the REST API is used. The Docker daemon process is responsible for creating and managing objects like images, containers, networks, and volumes. So actually the components that make the basic architecture of the Docker engine are actually the API, the command line interface or the client, and the REST service. The name daemon process means that the server works in the background of the host system and allows central control of the Docker engine. The REST API specifies a series of interfaces that allows other applications to interact with the Docker daemon. And finally, the command line interface uses the terminal, and this is the commands that you're writing from your terminal because you're the client, and interacts with the daemon using the REST API. It is pretty simple. Hi everyone, and welcome back to this course. In this video, we have a hands-on tutorial on how you can install Docker and run containers. So let's get started. So here I am in Google, and you can simply write Docker download, and this will help you to find the first page from which you can download Docker for your distribution. So let's hit on it, and depending on your operating system, you can download Docker from here. Since I'm using Mac OS, I will download Docker for Mac, and depending on whether you use Intel chip or Apple M1 chip, you can choose either download. I'm using an Apple chip, so I'll hit Mac with Apple chip. Okay, and you can see that the Docker image starts downloading inside my device. So once downloaded, just click on it and you will see this window right here. So just take it and drag it to your applications. And after a very small amount of time in which your application will actually start installing, you have Docker installed in your device, and you will be able to run all the commands related to Docker. Okay, so the installation is completed now. I will close the window and I will search for Docker. Okay, so now the application will run into your device and you will see a graphical interface. Click OK here, and then you can see the Docker application in your device that is starting right now. So as you can see, because I've never actually run anything into Docker so far, we have no containers whatsoever. So let's open the terminal and actually run some basic containers here. So write terminal, okay, and I will actually increase the size of the terminal so you can see better. And so here, let's first write Docker, okay, just to make sure that you have it installed. So if you see those commands, this means that Docker has successfully been installed in your device. Then do Docker -- version to see the version of Docker and make sure it is the last one. Now, since we have that, let's create a container, a basic one. Let's run the hello world container. So you can do Docker run hello world. Okay, so you can see that this run properly and actually something happened on the back. And here it is. We have our new container that is called hello world. Okay, let's create another container, and you can do Docker run -d -p 8080 Docker / getting started. Okay, so let's run that command, and this will create another container called getting started. You can see here, and this container will actually run. Okay, so you can see that this one is active and the other one is exited. And you can play with the containers from the graphical interface, so you can stop it from here or you can start it. And you can either use the graphical interface here, or you can simply copy the name. So I'll copy this name and go to your terminal and write Docker start, and then you can write the name of the container, and you can see that once I run this, the container actually is running now. And if you do, for example, stop instead of start, so let's do Docker stop, okay, you can see that our container has stopped, and you can also see the port. So for example, the other container will not be able to run it because we didn't define port while creating it, so that's normal. But of course, if you have multiple containers, you wouldn't want to activate them just from the graphical user interface, but I would prefer, of course, to activate it from the terminal. So as we said, the Docker client uses remote API of the Docker engine and can be configured to talk with the remote Docker engine. This allows us to manage both local development environments and production servers. So in order to check all the commands available for Docker, you could simply write Docker and then you will see all of them. But the most common ones, I would say, are, for example, the Docker images, which will show you all the images that have been used or you have available on your device. You can also do Docker info, and this will give you info for the current Docker client server, such as CPU cores, memory, and so on and so on. You can pull images, for example, from a Git repository by Docker pull, or you can push them by Docker push. You can delete image, for example, with Docker RMI, or you can run images with Docker run. You can also just check, for example, the processes with Docker PS, and so on and so on. There are actually a lot of commands, so I'm really advising you to explore all the commands of Docker. And of course, throughout this course, we're going to cover plenty of those commands because Docker is a key part of the DevSecOps. So let's now, just for fun, try the pull command, which will help you to download a container from external repository that is not in your device. So let's do docker pull, okay, and let's do ng inx, and this will hopefully download the ng-inx container and install it. So let's do that. Okay, so you can see that this has downloaded the image, right? And so now once the image is downloaded, let's actually check. So let's do docker images, okay, and you can see we have the ng-inx. So once we have it, we can actually run it. So let's do docker run -i -t ng-inx bin bash. Okay, so let's run that, and you can see that another container appeared, and this is the ng-inx container which we downloaded and then run into our device. So now this is running for about 12 seconds, and so let's stop it so it doesn't run on the background. So let's actually run back this container again. So I will do docker run -i-t ng-inx, and actually here when we're writing bash bin, this is because so we can access the console of the ng-inx container. So let's run that, and you can actually see that here this changes, and the reason is that when you write bin bash, imagine the container as another device. So if you would like to write commands in this container, then you can write bin bash and you access the console of the particular container that you're running. So for example, if I do here ls-l, okay, you will actually see all the content of this container with all the file system. And so if you would like to exit, for example, you can simply do exit and you exit the container console. And you can see even here that this is exited. So let's close both of those runs, and this will be everything, guys, for this video. Thanks for watching, and in the next one we will talk about how to manage your containers, and I will show you the Podman tool. Thanks for watching. Hi everyone, and welcome back to the course. In this video we'll talk about Podman and how to manage your containers with Docker. So before moving to the practical exercises, let's first talk about Podman. Podman is a native open source tool that doesn't use daemons or background processes. It's designed to facilitate the search, execution, construction, sharing, and deployment of applications using open continuous initiative. The key feature of Podman is that it doesn't need daemon process for controlling the instances of each container. This provides opportunity to access various visualization applications without root privileges. So Podman is a container engine that allows us to lift containers in a similar way to Docker, but with some key differences that you can see here in front of you. The first one is, as I mentioned, it is rootless. So it doesn't need root privileges in order for us to execute containers. So thanks to the Podman modular architecture, it is not necessary to execute our containers as a root, which is quite a big advantage, as we can execute our containers with different users who have different privileges. This happens without the risk for someone who has access to container to execute the container as root user. The second main advantage is that it is daemonless. It doesn't need to raise a single daemon for many services to work. So Podman is quite similar to microservices architecture and executes the necessary services for each container. Then you have the pods. So Podman has pods, which is actually a term that also comes from Kubernetes. So we could lift pods from one or more containers and isolate them from their pods. As you know, pods are small deployable units of computing that you can create and manage. Pods are usually a group of one or more containers with shared storage and network resources. And finally, Podman has a command line tool, quite similar to the one of Docker as well. So there are not much differences there. So if you started on Docker and you wanna move to Podman, then you don't need to actually learn as many new things. So in addition to the fact that you don't use domains, as we mentioned, one of the key features of Podman are the pods. So pods allow us to fuse multiple containers in a common Linux namespace that shares specific resources. You can also apply a wide variety of visualization in the same way. So in that way you can run multiple containers as a user without root privileges. So the main idea when using Podman is to have a main container that has inside one or more side containers running in the same pod of the main container. In this way, containers within the same pod cooperate with each other to execute a particular service. So here I bring you some of the most interesting characteristics that Podman actually has. The first one is that it has a syntax that is quite similar to Docker, so you don't need to learn new set of instructions to manage your images into the containers. And yes, Podman actually manages the entire container ecosystem, including the pods, containers, images, volumes, and this is done by using the libpod library. And so if you see this GitHub web page, you can see that you can mount Podman Compose and you can use it as a Docker Compose from here. But let's leave that page for now and let's check out what are the Podman commands. So I will open here a terminal and I will get a little bit closer so you can see. And first of all, if you want to check out all Podman commands, you can simply go to docs.podman.io, and here you can see the different commands related to Podman. As I said, they're quite similar to Docker, so it shouldn't be that much of a learning curve there. So guys, in order to install Podman into your device, you can go to podman.io, getting started installation, and you can simply write brew install podman for macOS. For Windows, you can click on the separate guide, or if you have Linux, you can check your Linux distribution from here and then write the appropriate command. Since I'm using macOS, I would just need to do brew install podman. Brew is actually another service that if you don't have it, make sure that you install it. So go to brew.sh, copy this command right here, okay, and you can install brew, which is the installation tool. So I already have it installed, but I will just paste that here and run it. It is a root privileges command, so write your password, okay, and then brew will start installing inside your device if you don't have it installed yet. So once this is installed, then you can install Podman by simply copying brew install Podman, okay, click enter, and then since I already have it installed, I will see this message that Podman is already installed and up to date. But for you, since you don't have it installed, it will take you about 5 to 10 minutes until the installation is completed. So if you want to check all the commands that are available for Podman, you can simply do podman --help, okay, and you get all the commands that, as I said, are quite similar to the ones of Docker. So in order to use Podman, firstly you need to do podman machine init, and once you write this command, then a CentOS image will start downloading into your device. And this is because Podman uses a Linux system to operate. So you can start now the machine by writing podman machine start. So let's do that. Okay. And now your virtual machine for Podman will actually start. So now your machine has started successfully, as you can see in the background. And if I write PS, you can see that there are also some processes in the background as well. So let's get our Docker container with this command podman pull docker.io library httpd, okay, and you can see that now we're pulling our docker.io into Podman. So this is completed. So then let's do podman images, and here you can see the list of all the images that you currently have, and obviously we have only the docker.io image that we just downloaded. So now let's run it in the same way that we were running containers in Docker. So here we use the same command actually, which is the run command. So let's do podman run -dt -p, then specify the ports, the protocol, and finally the image. Let's run that. Okay, and now here you can see the process which you have running into your background. But how you can find your process? So if you do Podman ps, okay, you can see that you have one process in the background that is currently running, and this is your Docker image, as you can see. So now if you do curl HTTP localhost and the same port that we stated for our Docker container, you can see that we're getting something, which means that this works. Okay, so this is the output message here. And so let's inspect the container that we just created by firstly writing podman ps, and you can see here the name of the container, or the ID actually, and you can simply write podman inspect and then just copy and paste the ID. Okay, so you can see now the configuration of all containers in our device. So here is the ID, and we only have this Docker container that we downloaded. And so if you need anything related to its configuration, you can definitely check it from here. Now, another cool feature of Podman is that you can actually search for images. So let's do Podman search Python. Okay, and you can see here all the images related to Python that you can actually download in your device, and you can download them by using the pull command in the same way as we did with the Docker image. So now let's actually close our container and exit Podman, and you can do this quite easily by doing Podman stop, and then let's place the ID of the container. And this command will actually stop our container, okay? And you can also do podman rm and then the ID of the container. And you can see that now, since we get this ID back, our container is removed. So if I write podman ps, you will see that there are no processes running. Or if I do curl, you will see that there's absolutely nothing. So we failed to connect to the port because the port 8080 is no longer connected to our container. So I know that Podman might not be as intuitive as Docker, since Podman doesn't have a graphical user interface, but trust me, it is quite a powerful tool that you can definitely use. So you should know that using those tools managing containers have completely changed the way people think about software development, deployment, and maintenance. Containers are so light and flexible that they've given rise for new architectures and applications. This new approach consists of packaging the different services that are part of application into separate containers and then deploying those containers within a cluster of physical or virtual machines. When developing a simple code, the administration of that code doesn't require large resources. So the need for container orchestration starts appearing into the project. So container orchestration is a tool that automates the implementation, administration, scaling, the creation of networks, and the availability of application based on this technology. So nowadays, applications are quite complex and tend to appear towards microservices, meaning that we should have at least one container for the front end and one or more service interfaces and another for database. So all of these things give the need for the container orchestration, that is having a tool or system that automates the development, management, scaling, interconnecting, and availability of container-based applications. The container orchestration is basically responsible for the development and deployment for automatic container-based services, for the self-scaling and the load balancing of the system, and to control the health of each container. So to do that in Docker, you can actually use the Docker Compose. So Docker Compose, as you can see here, we are on the front page of Docker Compose, and it basically allows you to connect several containers and execute them with a single command. It is implemented in Python, and it uses a file called YAML based on the YAML makeup language. So the Docker Compose allows you to define a series of containers and the relationship between them at a level of a YAML file that is very intuitive in its format. So as you can see, This can be done in a few steps by creating a dictionary of the project, for example with Flask, creating a Docker file, and compose file, which is actually our YAML file. This file includes all the dependencies and their interrelations. This allows the management of multi-container applications, and to manage that, the techniques that you need to use don't actually differ from the standard techniques that we use with a single container. With the docker compose command, the corresponding subcoming commands actually manage the entire life cycle of the application. And right now, we will not actually go into too much detail on how to do that. I just wanted to show you the front page so you're aware of this, but we will definitely explore this more and apply it to our application. So we will definitely have projects where we will create a Docker file, YAML file, and so on. The YAML file basically has all the libraries, volumes, ports, and other important information for each of the containers that we have. So that's it. Thank you very much for watching this video, guys. And in the next video, we'll talk about Kubernetes. So I can get you started there, and then in the next sections, we'll explore how Docker and Kubernetes are basically one of the key components for building the DevSecOps. Thanks for watching. Hi everyone and welcome back to the course. In this video, we'll talk about Kubernetes. So the advantage of using containers to run a group of software applications is already established using Docker. However, in a production environment, managing and running containers is important to minimize the downtime of the service. And this is where we're using Kubernetes. Kubernetes is used to automatically start a new container if a container fails. So Kubernetes follows master-slave architecture, and it is also known as K8s. This is the most popular container orchestration engine on the market. It is open source for applications executing in software containers, automating the deployment, scalability, and management of the distributed applications. So Kubernetes groups the containers into logical groups called pods, which represent the basic unit of the manager that can be distributed in the cluster by the Kubernetes process. One pod can have a set of containers that share the same storage and a single IP address. So the Kubernetes, as I mentioned, has a master-slave architecture, and so the master container, as you can see on the figure right here, control and schedules all the activities of the container, while the workers right here, as you can see, are actually the nodes. And here is where the containers are executed. You can have multiple nodes for one Kubernetes master. So the ability to have multiple nodes or orchestrated containers makes Kubernetes a perfect addition to the microservices-based applications. So the master container right here acts as a central control level in the cluster, and it's composed of 4 basic elements that allow coordination within the cluster and to distribute tasks. So those are the IP server, which is responsible for launching all automations in API server by using RESTful API services. The server acts as a central management point in the cluster. Then we have the etcd, which is an open source key value store and can be considered a Kubernetes cluster memory. It's been developed especially for distributed systems to store configuration data. Then you have the scheduler, which distributes the pods in the cluster, so it finds out how many resources a pod needs and basically adjusts them within the resources available for each node in the cluster. And finally, we have the controller manager right here, which is a service of the Kubernetes master that manages the status of the cluster and executes the routine tasks directing the orchestration. So the main function is to ensure that the cluster state corresponds to the state that was previously defined as an objective. So while the master is responsible for the orchestration, the distributed pods in the cluster are running different nodes called workers. To do this, each node needs to run a container engine compatible with the container tool like Docker or Podman. So you can imagine that basically Kubernetes runs the master and have multiple containers as Docker, or actually a container tools as Docker, which contain multiple containers. So one Kubernetes could have a few Dockers or Podmans or any other such tool. And so let's talk about what each Kubernetes node includes. So the first one is a kubelet, and this is used to direct and manage the node. This process maintains the communication and ensures that the information is sent to the worker nodes. The agent receives the requests and supervises their execution in each node. Then you have here the kube proxy, which is a proxy service that is executed in each Kubernetes node to serve the requests that come from worker nodes and provide services to the users of the container application such as Docker. And as you can see, these proxies, they go directly to the users right here, and this is how the services are provided. So in order to understand Kubernetes better, let's talk about some of the key terms using Kubernetes. So the advantages of using containers to run in a group software application are quite a lot, and Kubernetes extends that by creating the ability for us to have multiple container application tools that consist of multiple containers. And here I bring you some of the key capabilities that Kubernetes can provide. The first one is the service discovery and the load balancing. And this is quite important point. Kubernetes can expose a container using its own domain name and IP address. It is also capable for balancing the workload and distributing the traffic in a way that the deployment is quite stable. The next key point is that Kubernetes provides storage orchestration. It allows you to automatically mount a storage system of your choice, such as local storages, public cloud, and any other type of computing providers. It allows you to describe the desired state of your payload containers, and you can change the current state of your containers to desired state. For example, you can automate Kubernetes to create new containers for deployment, remove existing containers, and adopt all of its resources into a new container. Also, Kubernetes can actually restart the containers that fail and is replacing the containers that are not responding within the cluster. Then you have the resource management. As you can see, Kubernetes is actually all about management and allows you to specify how much CPU and memory or RAM each of the container needs. So Kubernetes can actually take better decisions than the developers to manage container resources when containers have specified resource requests. It can also provide secret and configuration management. It allows you to store and manage information related to the configuration of the containers, as well as the most sensitive information like password, keys, and tokens. This sensitive information and the configuration parameters can be updated without the need to reconstruct the container images and without the need to open the sensitive information. So there are also some additional terms that you need to understand in order to get better understanding of Kubernetes. So firstly, we already talked about cluster, and cluster is a physical or virtual resource and storage resources used by Kubernetes where pods are deployed, managed, and replaced. So cluster is basically a storage location. Then you have the pods that are a smaller unit that can include one or more containers. In many cases, a pod is composed of single container, but its ability to accumulate several containers very close to each other is quite powerful feature. Then you have the replication controller, which is a Kubernetes mechanism to ensure that a pod has raised a certain number of replicas. For example, the replication container raises more replicas if you need more and kills them if we need less. It raises new replicas to keep the number defined if any of them fails or dies. Then the services define how to access a group of pods and allows access to containers with a unique domain name server and IP address. And finally, the labels are used to organize and select a group of objects in pairs of key and values. So a pod can contain one or more containers running at the same time, and it is basically the unit that the Kubernetes manages. So there are several advantages that Kubernetes brings to the management of containers as pods. So before starting with the Kubernetes configuration, you should understand that there are four key concepts that you need to know. Those are the Kubernetes driver, which acts as a node from which pods, replica controllers, and services of the Kubernetes environment are deployed and managed. And later on, I will show you how you can create a Kubernetes driver. Then the Kubernetes nodes provide environment in which containers can be executed. Later, we'll run the command kubeproxy in order to start all the containers within a node. Then we have the kubectl command, which is used to do the Kubernetes management into the master node. So with the kubectl, we can create, obtain, describe, or eliminate any resources that Kubernetes manages, such as pods, replica controllers, and services. And finally, the resource files YAML and JSON are used to manage and create pod. You can install and deploy Kubernetes from kubernetes.io, but that we will do in the next sections where we will talk specifically about Kubernetes. So that will be everything for now, guys. Thank you very much for watching, and in the next section I will teach you how to manage your containers and Docker images in Docker. Hi everyone, and welcome back to the course. In this section, we'll talk about how you can manage containers and Docker images. So the Docker images are simply a read-only templates that can be used as basis for launching containers. This means that everything that we're doing in the container has only effect inside it. So we don't make any modifications to the image that creates the container. So we should create a custom image for our future containers if you want to have one. So as you know, and I will here open a terminal, we can actually get Docker images by writing docker pull. This will download the image and save it to our device. So for example, if I want to pull Ubuntu, which is an Linux image, you can simply do docker pull Ubuntu. And if you click later, you can see that the image is up to date since I already have it in my device. But if you don't, it will of course start downloading. So you can easily save your image by writing docker save ubuntu-o, and then let's write ubuntu.tar. Okay, so that will save your image, or it will actually pack it and generate a tar file with a desired name from you. So if you want to also create a backup for your image, you can do docker save ubuntu > and then backup _ ubuntu.tar. Okay, and this will create a backup for your image. So if I hit here and check the Docker images by Docker images, you see multiple different images, and one of them is Ubuntu, as you can see here. And so all those images are a set of directories and files with specific structure. So each folder refers to one of the layers in the image. So within each layer, there are some files to reference that layer and a compressed file within the file system that will form the image. So when the image is extracted and constructed so that it can be usable, we can unzip the content for each layer in order to form the final image which corresponds to the base image. This will generate a file system that has content that is built and modified by layer. So you can look at the images as a permanently stored instance of container. So if the image is the class, then the container is the object. Or you can create multiple containers from a single image. So if you want to run and create a new container from an image, for example, if I want to create an Ubuntu container, you can simply do, so you see how easy it is to create a container just by writing docker create, and then for example, let's take one of the containers, let's say this one, okay, run it, and you will see that here we have a new container. And you can run it, you can stop it, you can basically do whatever you like with it. Okay, so you can also unpack the tar container that you have. For example, let's say if you use Ubuntu, if you remember, we created a tar file with it. So what you can do is to write tar tvf, okay, and then ubuntu.tar, okay, and this will unpack the file. So let's run that. And you can see that now our file is completely unpacked. So if you want to check the containers that are currently working, for example, you can simply do docker ps, and this will show you that right now we have only one container that is currently working. This is the one that we just created, that is from the image ng-inx, okay? So you can see that from one image we can actually create multiple containers, and I will create one more just to prove you that. So let's do again docker create ng-inx, which will create another one and then another one. So right now, if I want to check docker ps, you see that we have again only one running, but if I activate the other instances of the containers that we just created and I write docker ps again, you see that now we're having 3 containers that have been created from the same image. So you can see how easy it is to create instances of any type of application and build container with it using Docker. So of course I will stop those containers that we just created so we can have a clear start for the next commands. So if you go back to the terminal, we can try some more things. So Docker layers are very much like Git configurations and store the difference between the previous and the current version of a particular image. So the layers use space, and the more layers you have, the thicker the final image would be. And Git repositories are similar to this. Git, for example, stores all changes between commits. So the size of your repository also increases with the number of layers. So when you request an image from a repository, it downloads only the layers that you don't have to download to your machine locally. So for that reason, the Docker images use the same structure. We can see the layers of an image by simply writing docker image history and then the image name. So for example, if I do Ubuntu column latest, then you will see all the layers of that image. And you can do this for your other images too. For example, if I write here ng-inx and I hit that, you see how many layers we have here for that particular image. So another thing that I want to mention here are the image tags. They allow you to identify the versions of the images because the different versions are of course associated with their tags. So you can see here in this page, for example, the tags that are available for Ubuntu. So in that way you can download a specific tag image using the docker pull command. So for example, if you want to download the 14, the 18.4 version, you can simply go back to the terminal and write docker image pull and then the specific tag. So if I write Ubuntu 18.04, you will download specifically that version and specifically that layer of Ubuntu. And if I do now docker images, you will see that you have 2 Ubuntu versions. One of them is the latest, while the other one is the specific layer that we wanted to get. So this is why I'm keep repeating that images are pretty much layers that are mounted on the top of the previous layer of an image. So the latest is the highest layer. All layers in an image are read-only when a new container is created from that image, and we need to copy it in order to create container. So the original layered organization and copy on write strategy promote two major best practices for creating Docker images. And so there are two best practices, which are the aim of Docker to have minimalist images. And this is because Docker images get benefits from stability, security, and loading time when they are smaller. You can always install tools and containers if you need to solve problems related to development. On the other side, the base image can contain many layers and add many capacities. You can find official images for many distributions, programming languages, databases on the Docker Hub repository. You can simply type hub.docker.com. So this will be everything for this video, guys. Thanks for watching, and in the next one we'll talk about a quite important topic, which is how to build and manage the Docker file. Thanks for watching. Hi everyone, and welcome back to the course. In this video, we'll talk about the Docker file, what it is, how to build it, how to manage it, and how to write commands related to it. So one of the great things about containers is when we're building them automatically is that the Docker Hub will show you the Docker file used to build the container, which provides some level of transparency over what you're downloading. So for example, you can see the Docker file that is using Ubuntu base image right here on this address, and here the images are created using a series of commands that are called instructions. The instructions are placed in the Docker file, which is basically, as you can see, a text file that contains a collection of changes in the root file system and the corresponding execution parameters within the container. So the result of that file will be the final image. So each instruction creates a new layer in the image, which then becomes the parent layer for creating the next iteration of images. So basically the Docker file is a text document that contains all the commands we want to execute the command line to build images. The image can be built by writing docker build command, and that will follow all the instructions within the file. So once run, the Docker file will be executed by the Docker engine. So a layer will be created for each instruction that allows them to be reused if they are cached, which will significantly speed up the construction process. For example, an instruction that requires an image of the registry in the cloud will suppose a great workload if you need to download this in each execution. So cache data is used for this, so the image will be used directly if it has been downloaded in the previous run. Each time the cache data is used, a text is displayed to the console so that the user knows about it. So as you can see on the figure in front of you, you can see the process for using the Docker file, and so the Docker build command builds an image following the instruction of the Docker file. And you can see that from here, and this square represents the Docker file that is building the current image. So it's important to note that the Docker build sends the entire context. So for that reason, it's a good practice to put the Docker file in a clean directory and add the necessary files to that directory if necessary. So if you go to the terminal, you can simply write docker build --help, and this will give you all the commands for building image from a Docker file. Normally, when you want to build this, you simply need to write docker build, then pass the options, and then the Docker file path. Okay, so you need to have both in order to build an image. And so you can see in front of you that the most commonly used options are -t to create an image with a specific name. You can use no cache to do not use a cache while building the image, and this is because by default Docker will actually check if there are cached files and build from them. And the final option is the pull option right here. So the pull option is used for Docker to download the image specified from expression. We can use this option to force the download of a new version of an image. So the build command that we write can always be executed from the same directory with a Docker file, or if it's not in the same directory, if the Docker file is located properly. So you need to follow the path of the file, as you can see here in the description. So the build command can run from the same directory where the Docker file is located, and we can also assign labels to images to have them located by using the tag command. And you can see an example in front of you. So this is the final syntax for building an image using a Docker file path, and this command ensures that the image created from the Docker file will be built in independent path, and it will have a specific name given by the repository tag. So here on the Docker web page, you can see that a Docker file always starts with those cap commands. And for example, you will do something like from, and you select the image, which allows to establish a base image and initialize the construction of the new image. You can have the copy command, which allows you to copy files and directories to the file system of the container. And somewhere in the end, you would have the run command. The run allows you to execute the command that you want to use in the context of the image. So if you have one run command, this means one layer. If you have multiple, this could mean multiple layers. So if you look at the run command, sometimes you can even have multiple run commands on the same line just to save space. So for example, in the following instructions here, firstly we're using the from command, so from Ubuntu, to set the base image for the instructions, and the image can be any local or public image. If the image is not found locally, the Docker compilation command will try to download the image from a public record, and then the run instructions will execute the command in a new layer at the top of the current image, and it will confirm the image as well. The generated image will be used for the next instruction for the Docker file. And you see that in practice here as well. So the run instruction is only interpreted and used when the Docker build command is used to create an image. The purpose of the run instructions is to execute the command that modify the image in the same way. So let's see how can we create a completely new image from a Docker file. To do that, I'll create a new folder on my desktop. So new folder, and let's call it Docker1. And there I will create an empty text file, okay, and I will name it Dockerfile, okay. Make sure that the file is not .txt, but is simply called Dockerfile of a type document. So in this file, let's write some commands in order to create a local image in the way that we like, using Ubuntu as a base. So what you can do is write from with caps, okay, then Ubuntu, then you can specify the version of the Ubuntu that you would like to use. So let's say 18.04. Then let's write run apt-get update and backslash. Then let's do apt-get install -y -redis -server. Okay, then end backslash. Finally, let's write apt-get clean. And finally, let's write expose, okay, and then 6379, which is basically going to be our port, okay. And then I'll write cmd, which means command, and this will basically allow us to establish the command that the container will understand and execute. So I will write here redis -server, okay, and let's write columns here, okay, comma --protected -mode space no, okay. And so those are going to be the commands that our container will understand. Okay, let's add some space here, okay. So let's save now the Docker file, and if you go back to the terminal and go to the Docker3 directory that we just created, so if I go to Docker1 and if I do ls, you can see that we have our Docker file here, so we're in the right directory. Now the next thing you need to do in order to create your new image is to write docker build -t my redis, which is going to be the name of our image, and then dot would mean that we want to execute all the files. So let's hit return here, and now your new image will be created. Okay, so for me this worked for 1 second because we already have that cached and I ran this command before. So now since you have this image, you can easily create a container from that image. And if I do docker images, okay, you can see that I have my Redis and I also created my Redis one right here, and those were created, those were new images created from my Docker file. So in that way, you can easily create images and then you can run them like any other image. You can combine applications as you wish and then create containers from those. So this was everything, guys, I wanted to share with you in this video. Thank you very much for watching, and in the next one we will talk about how you can manage your Docker containers. Thanks for watching. Hi everyone, and welcome back to the course. In this video I will teach you how to manage your Docker containers, and we'll elaborate more on some of the key Docker commands that will help you manage your containers. So here I have opened a terminal and Docker with a few ng-inx containers from the previous videos. You can open those by simply typing docker create ng-inx. So we already learned that Docker Hub can provide you a new organization with a good host and deliver images to you. You can configure Docker Hub repositories in two ways: repositories, which allow you to upload and update the images, and this will allow you to configure GitHub or Bitbucket account that triggers reconstruction of image when any changes have been made to the repository. But when getting packages, you always want to keep the things simple. So for example, if you would like to create a new container from image that you don't have, let's say that you want to create a new container that will run the Python engine. So what you can do is simply writing docker search Python. Okay, and actually let me make our terminal a bit bigger so you can see. Here you'll be able to see all images that are somehow related to Python. Another way in which you can search for images is from the Docker Hub, and you can simply type here Python, and then you will find Python images right here. And so from here you can simply download the Python image and then run it. There is another actually very simple way to get the images that you like, and you actually don't need to download them necessarily. You can simply type docker run -t-i, where -t means that you're creating a terminal device, while -i flag specifies that the terminal session would be interactive. Then you can type the image that you want to run, Python, and then write bin bash in order to access the Python shell. So obviously, as I said, we don't have currently installed in our device the Python image, so running it would normally make no sense, right? However, when you execute this command, Docker automatically finds that you don't have the Python image locally, so it will download it for you and run the container. So let's do that. So as you can see, we got a message that we're unable to find Python locally, and now we're downloading all the commits, all the last commits of Python. So some of them would take not much time, some files are a little higher. As you can see, this one is 189 megabytes, so it will take some time until it downloads. But once this is done, you see that I will open the Docker graphical user interface and you have the container there. So you can see that here, now we're running Python. So with one command, we not only downloaded the Python image, but we also run an instance of that image into the container. So I will leave this container running and I will exit it from here, from the terminal. So when we do exit, as you can see, now this is exited. And there's also another way to create a container, and this is when we're using the -d command or the detach command. This allows you to execute the container in background mode. The detach option allows you to indicate that it runs in the background as a daemon process. So if I write docker run dash dash detach, alternatively you can also type dash d dash ti dash dash name. So we're gonna name this one Python 2, and then let's define the image. So Python latest dash bin dash bash, so we activate the shell. So let's run that and see what happens. And you can see that here we created a process. We didn't go directly into the shell because now our process runs in the background, but you simply got the process ID right here. So now, as you can see, you have one container that is running, and I'll also activate the other Python version that we have, and I will also activate one of the ng-inx containers. Okay, so now we have three microservice applications that are currently running. Now, if I go back to the terminal and I want to check that images or that containers actually that are running, firstly you can do docker, okay, inspect, and then you need to find the image. So in order to get the ID of the image, you can do docker images, and then let's do docker inspect, and then let's check our Python image, okay. And you can basically see all the dependencies. Actually, from the previous video, you should already be aware how to use the inspect options. So you can inspect the containers and the images by ID, as you just saw. And so this command is quite useful. We can also check the packages that are installed in the Docker container. For example, we can use the dpkg command to check the packages installed in the Docker container. We first need to find the ID of the containers that we're running. So for example, if I do docker exec, and then let's find the ID or the container name. For example, let's copy the ID of this container, Python 2. Okay, let's paste it here, and then let's do dpkg -1. Okay. Actually, we need to write -l instead of -1. So let's do that. And yes, we got it, guys. So here what you can see are all the packages involved in creating our Python container. So if you need to check the different packages that are building a particular container, you can see there are quite a lot when building Python. You can definitely use this command in order to check all the libraries, dependencies, and so on and so on. So this is the easiest way, guys, to manage your packages and to check the information related to them. Thanks for watching, and in the next video we will talk about how you can optimize your Docker images. Hi everyone, and welcome back to this video where we'll talk about how you can optimize your Docker images. So to optimize space and reduce container size, you need to use a simple range of commands and planning, but that would be essential for creating efficient container environments. If you think that Docker is designed to be able to mount a big number of containers, both space and speed are key factors in developing environment and production. So one way to optimize images is to create as few layers as possible. For example, if you can see the set of instructions in front of you that is normally assigned to a Docker file right here, you can see 4 run layers, even 5 of them. During construction, Docker tends to reuse the layer of an image of a previous construction whenever it's possible, ignoring a step that could be quite costly. So how you can do that is firstly placing the Dockerfile instructions that could change the final part of the file. So in that way, Docker can reuse the previous layers. You can also group instruction in the same layers, just like you can see in the last instruction right here. We can group together similar instructions, for example, the apt-get command, which usually requires an update of repositories and previous backups. So the same command can be executed with one run instruction, and so we can generate right here only one layer instead of few of those. So the construction of Docker image from the Docker file can be quite an expensive process, since it can involve installation of large number of libraries. At the same time, it is a repetitive process because the successive builds of the same Docker file are quite similar to each other. This is why Docker introduces the concept of caching to optimize the image building process. Each time an image is reconstructed from a Docker file, Docker checks if the current installation have been executed correctly, and so it might already have the instructions available in the cache. If the results are correct and are cached, Docker will use the instructions cache data by default and reuse it in the new compilation. So starting with base image that is already cached, all the instructions in that case are compared with the derived images from the base image to see if one of them is created using the extract instructions. And in that way the cache is validated or invalidated. So for add and copy instructions, the content of files in the image are examined and a checksum is calculated for the file. During each cache search, the checksum is compared against the checksum of the images already checked. And so in that way the cache is unvalidated if something changes. So here I bring you some of the key aspects of the Docker cache that you need to bear in your mind, so you have them as reference. So the Docker cache is always local, so this means that all the Docker file instructions will be completely executed if you are running this particular Docker file for the first time. And this will be even if the image has already been built in the Docker registry. The cache will also be invalidated if an instruction has changed and you cannot use the cache. So in that case, the Dockerfile instructions will be used without the cache. Also, the behavior of the add and copy instructions is different in terms of behavior of the cache. Although those instructions do not change, they would invalidate the cache if the content of the files being copied has been modified. So as you can see, in order to use cache, it is quite important for pretty much everything to be the same. Of course, you can also disable the cache by writing no cache equals to true, and this flag will simply invalidate the cache automatically. So let's now create a new folder on our desktop, because I can show you how you can create a very easy to use image that will be a JavaScript app. Okay, so I'll create a new folder and let's call it the JS app. Okay, so let's enter this app. So let's enter the folder JS app and let's create a few files. So let's do vim Dockerfile. Okay, and this will be our Docker file. So you can basically use whatever text app that you like in order to edit your Docker file, but in that case I will simply use vim because I'm already in the console. So you can write here the instructions. So let's do from node latest. Okay, then let's do expose 3000. This will be the port. Then let's do work dir app. Okay, so this will be the directory. Then let's do copy package dot json index dot js dot backslash, and actually we'll create those files. So we'll create the JSON file and the index.js files, and those files will basically be packed from the Docker file, and we will be able to create a Docker image from a complete scratch. Okay, then let's do run npm install, and then let's do cmd for commands, and then let's do npm comma start. Actually, let's do it like this, start. Okay, and then let's close the bracket. Okay, so let's save that. With vim you can do this by right quit and exclamation mark, and now you will be able to see that we have a new Docker file right here. And if I open it with any text editor, for example, let's open with text edit, you can see that we're having a new file which has the exact instructions that we just wrote. Okay, and the only mistake that I think I did was that I actually wrote a single quote instead of double quote right here, but that's fine. I just fixed it. So let's save the Docker file and we're done. So this is our Docker file with the instructions. Now the next thing that we need to do is to create a JavaScript and JSON file. So you can simply create it as a text file and do .js, or you can use any type of editor that you would like. For example, I have Sublime Text and I will use that editor. So here we're going to have a new file, and let's create a hello world command and connect it as an app. So let's do const express equals to require express. And before continuing, let's save this file. I will call it actually index.js. So this will basically be a web page, right? So let's save it. Actually, I want to save it in our current folder. So what I will do is simply go to the desktop and from there to JS app. Okay, and I just saved it there. As you can see, index.js. So this is a JavaScript file, and you can see as long as I saved it as a JS file, then you are getting some interesting colors here that are little help when you want to see the different keywords in JavaScript. So let's do now const app equals to express, okay, and then let's do app dot get, and you can do here a backslash, comma, and then let's do req and res, okay, and then let's point that to res.send, and we will send here hello world. Let's do some exclamation mark, and let's close this bracket, okay, and I will delete this one. That's good. And after that, let's do app.listen, and here we will define the port. So I will do port 3000, comma, brackets, okay, and this will point to, okay, and then let's log some message here. So I will do console.log, and let's write some message. Let's say app is listening on port 3000, okay. So let's save that, and this is our JavaScript file. And so once you're done with this, let's create another file, which will be a JSON file responsible to run the app. So let's save that. Let's create a new file, and let's save that file into our JS app. So I'll call this file package.json, okay, and we're done here. So let's create now the file, and the idea here, guys, is simply to create the dependencies and the name of the app. So let's do name and then hello world app, okay, so this will be the name. Then let's choose the main file of this app, so you can do main index.js, okay, then let's do scripts, okay, and here we'll start the app. So I will do start, okay, and then let's do node, and then the name of the file index.js, okay. So let's save that, and this is our JSON file, guys. So I saved it, and if you go back to our directory, you will see quite well that we have now 3 files: one JSON file, one JavaScript file, which will basically run our page, and finally we have the Docker file with the instructions for Docker. So now we're completely ready to create our image. So I'm here into our folder, and let's do docker build -t, and then let's name our app node app, okay. So once I run that, actually I also need to do dot here so it gathers all the files. So once I run that, you can see that we're starting to get all the dependencies to create the image, and our image is created. So if I do now docker images, okay, you can see that we have our node app, and this was created manually by us, okay. So also make sure that you actually install one of the dependencies that I didn't talk about, and this is the express dependency. So you can do npm install express, okay, and make sure that you install it before running your app, because otherwise you might get some errors. And so if I now write, for example, docker history node app, okay, you will see the different layers within the docker history command for our app right here. Now, since we already have the app, you can see that we have our image. It is about 941 megabytes. And let's try to reduce that size by editing the Docker file. So let's open it in Sublime Text. So I will just open with Sublime Text. Okay. So since this video is about improving and optimizing your Docker images, let's see how we can actually reduce the size of our image. Now, currently, if I write Docker images, you can see that our image is actually 941 megabytes. So one very good way to do that is by using the Alpine Linux. And I will show how this is done. So we need to modify our Docker file, which has the instructions. Always the instructions are the most important for the way that we are creating our image. So firstly, here in the from, let's do node, and instead of latest, we'll do 15 as build. Okay, let's put the worker up above. Then let's do copy package JSON and index.js. Okay, that's good. Then let's do run. Actually, I will use the same stage, so run np install. Okay, and I'll leave also those two lines. So far we just move the expose to the second line from the bottom. But if you add this step, so if you do from node 15 slash or dash alpine, okay, this will add an extra layer. So the Alpine Linux-based images have the capacity to produce the smallest images to run application within minimal resources at the memory of the disk. So at this point, images based on distribution are much faster to download and configure. So this should really reduce the size of our image. So let's save that and let's go back to our application. And what I want to do now is to write Docker. So we'll create another image, build dash t, and then let's do node slash or dash alpine. Okay, so we'll simply create a new image called node alpine, and this time we'll use the updated Docker file that we just created. So let's run that, and then let's place dot after that so it collects all the files. Okay, so here we have an error, and let's see if there is some issue in the instructions. Yeah, so I can see here that I actually missed one line. So under the from, you also of course need to copy it. So let's do copy dash dash from equals build slash app slash. Okay, so this will basically connect the Alpine to our build image right here. Okay, because we define it as build. Okay, and also let's change here this to Alpine because I misspelled it. Okay, so let's run the command again, and you can see that now we are building the package successfully. Okay, so it took quite a few seconds. Since I run this again in the past and I also have a cache, for me it's faster, but for you it might take a couple of minutes. So let's now write Docker images. Okay, and you can see that our new image, when we built the application with Alpine, it actually took about 9 times less resources comparing to our previous installation. So you can see how significantly different are the instructions and how important they are, and can really build you images that are of way smaller size. And the final thing I want to talk about are the distroless images. They contain only the application and its dependencies at runtime. They do not contain, for example, package management applications or programs that you can find in the standard Linux distribution. And so you can see the size difference of the same package when it's run into distroless mode or not. So if I do now docker pull python, okay, and at the same time if I do docker pull gcr.io distroless python 3, okay, so now this is installing, and you can see once it is installed, let's check the packages. So let's simply do docker images, okay, and here's the Python package, which is 868 megabytes, while the GCR distroless Python 3 is only 50 megabytes. So you can really see the difference between the official Python image and the other based Python distroless image. So this really saves us disk space and network traffic, and it can also improve our security. So not having libraries and services that we don't actually need reduces the security risks and the uncertainty alerts from image scanners and obsolete or vulnerable versions. So those are few ways in which you can reduce drastically the image size. And finally, to end this video, I will show you how you can actually remove images that you don't need. So you can simply do docker image remove, and you can either specify the name or the ID of the particular image. So for example, if I want to remove the distroless image, I can simply copy and paste the ID, okay? And now you can see that this image doesn't exist anymore in our system. So if you want to try and run those applications that we just installed, you can simply do run node alpine, for example, actually docker run, okay? And you can see that our application started, and you got in the console that the app is listening on port 3000. So you can play with the containers, guys, and with the images. You can create multiple containers, check if they work properly. I'm sure that you will have a lot of fun. Thanks for watching this video. This is the last video of this section. So you learned quite a lot of things here on how to work with Docker, manage the Dockerfile, and optimize your images. Thanks for watching, and in the next video we will finally start talking about security and how to improve and manage the security in Docker. Thanks for watching. Hi everyone. This section will cover the best security practices and Docker capabilities from which the containers can be provided with more features. While Docker provides central registry to store public images, you might not want your images to be accessible from the world. So in this section, I will teach you how to use a private registry, and I will review the Docker Content Trust and Docker Registry, which will provide you with a secure way to upload your images in Docker Hub. So from the security point of view, Docker containers use the resources of the host machine, but at the same time they have their own runtime environment. This means a Linux container cannot access other containers or underlying operating systems. And so the only way to communicate with other networks and containers would be with a specific network configuration. The most significant advantage of container-based virtualization is that applications with different requirements can run isolated from each other without having to assume the overhead of the separate guest systems. So, as you can see here, the container technology takes advantage of two basic functions from the Linux kernel. Those are the namespaces and the control groups. So, on one side, the namespaces will provide isolation for the processes and mount points, so the processes that run in a container cannot impact with each other or see processes that run into other container. So the isolation of the mounting points implies that they cannot interact with the mounting points of other containers. And on the other side, the control groups or the C groups are a feature of Linux kernel that supports the limitation of use of resources at the level of CPU and memory that a container can use. This ensures that every container will get only the resources that it needs. So the development team behind Docker is also aware of security problems, considering them an obsolete for the consolidation of the technology in the production system. So one of the key isolation techniques that Docker Engine supports are firstly the Apparmor, which allows you to regulate the permissions and the access of containers and file systems. Then you have the SE Linux, which provides a system of rules that allows you to implement access controls to the kernel resources. And finally, you have the secure computing mode or the Seccomp, which monitors the kernel system calls. So while Docker facilitates virtualization work, sometimes we might forget the security implications of the execution of Docker containers. We must always keep in mind that Docker requires root privileges for working in normal conditions. And you should always keep that from a security point of view. So the Docker daemon is responsible for creating and managing containers, which includes creating file systems, assigning IP addresses, routing packets, process management, and tasks that require administrator privileges. So for that reason, it is quite important, as I mentioned, to start all the daemons as administrator. So starting new containers, stopping, reconfiguring, or running them, some of the main actions we can perform on the containers. So one of the Docker ultimate goals is to be able to run even the daemon as a non-root user without affecting the functionality or delegating operations that require root privileges. So let's see some of the best practices when talking about Docker security. So you can see that one of the first and the most important practices are the fact that you should always run the Docker processes on a dedicated server isolated from other virtual machines. It is always very important to take special care to link certain Docker host directories as volumes because a container can gain full read and write access and perform critical operations to those directories. So, from the point of view of security communications, the best option is to use SSL based authentication. And you can definitely check on the web what the SSL protocol is. It is pretty much the most popular security control out there. Also, you should always avoid running processes with root privileges inside the containers. We will also talk in the next videos for how you can enable, and this is one of the key principles, how you can enable specific security profiles. And those are the Apparmor, the SE Linux on the Docker host. So you should always keep in mind that all of your containers are actually sharing the Docker kernel. So it is quite important to have the kernel updated with the latest security patches. So since this course is covering the complete DevSecOps features, let's talk about some key principles for improving the container security. So you should always use only one application per container that is using microservice oriented approach. You should never run containers as root, and you should also make sure to disable the set UID permissions so nobody can interfere with that. You can also use, and I will actually talk about this in the next videos, so you can use the cap drop and the cap add flags to remove and add capabilities of your container. It is also advisable not to use environmental variables or run containers in privileged mode if you are going to share secrets. You should also have Docker updated to the latest version to ensure that all security issues have been solved, and at the same time you have the latest features that Docker is incorporating in its core. And also, you should always bear in mind that kernel is one of the most vulnerable components of the container management because it is shared between all containers. So you should always take a special care to keep the Linux kernel with the latest update as well. So let's go guys to your terminal, and hopefully you should already have Docker installed and Docker opened right here. You don't need all of those containers that I currently have installed because we will update with new containers as well. You don't need that in order to execute the commands in the video. So let's go to our terminal, and the first thing I want to cover is that all the containers are actually defaulted as having root by a default user. Okay, so every time you create a container, you will immediately be assigned to the root. So for example, if I want to create a new Ubuntu machine without any user specifications in the creation, here's what I will get. So you can type docker run -v bin host bin, then let's do it --rm ubuntu sh. Okay, so when I run that, we just created an Ubuntu machine, and you can see it right here in the bottom. It is currently running because we selected the run command. So now we're here in that machine, and you can see we're right now in the host shell. So let's type who am I, okay? And you can see that by default you're already the root user. And if you do ID, you will get that all the IDs that you currently have are the root user ID. So you can see that containers are executed by default with the root user. So root privileges will be available within the container. However, from the security point of view, it is important to configure the namespaces to limit access to the container as user. So while container engine must be run with the root privileges, it is not a good practice for the containers to do the same thing. So the container engine in that case is the Docker. However, the containers are just entities into the container engine. So for that reason, it is quite necessary to create a user for each running container. So the best way to do that is to indicate the user who wants to be able to execute the creation of the image in the Docker file. You can add users inside the Docker file, and I will show you how this is done. It is quite simple. So I'm going to create a new folder on our desktop since it is the most convenient for me. And this folder right here, I'll name it 3_root user. Okay, so the name actually doesn't matter, but what's inside actually matters. So in that folder, I'll create a new file with the Sublime text. So let's do Sublime text, and let's create a new file. I'll save it, and let's name it Dockerfile. And this file will be used for us to create a new image which will have different sort of privileges. So let's see how this is done. I write here from Python latest. So this means that we will create a new image from the Python image. Let's do run user add -s, and then let's do bin bash unix user. Okay, and then let's do user unix underscore user, and finally I will do entry point. Okay, and here I will write bin/bash. Okay, so let's save that file, and now let's go in the terminal, and from there I will go into this folder. So let's exit our container, okay, and just close the container. So I will do cd, and then I will go to our folder. You can see that our Docker file is right here. So you can build the new image with the following command: docker image build -t, and then the name would be Python image. Okay, so this will create a new image from our Python image, and it will use a Docker file to customize this image. So let's run this. And yes, you need to place dot in the end. I always forget about this in order to get all the files. So let's run that. And you can see that now a new image is created. And if now I write docker images, you can see that here we're having a Python image that is currently created. Okay, so if you want to run this particular image, you can write docker run -ti, and then let's write Python image. Okay, so let's run that. And if I go back here, you can see that we're having our Python image, and it is currently running. So this is the exact same image that we just created. And you can even see from the name that we are already a Unix user. So if you write who am I, okay, you see that you're a Unix user, but you're not root anymore. So only with this simple thing, when creating images, you can make sure that the user that is using your image is not a root user. And if I add ID here, you can see that absolutely everything, the user ID, the Git, and the groups, you're all there as Unix user. And so you can see that now the user is added inside the container by inspecting actually the file etc/password. And you can actually check the content of this file but by simply writing more etc/password. And if I search here for the users, you will find out that first of all, this is our root, and also if you go down here, at some point you will find your Unix user. So you can see that he's right here in the bottom since we last created it. And this is where it is, right? It's a bin bash user. Okay, so this is how, guys, you can pretty much automatically create your root user without any issues. So another quite good practice that is recommended for Linux systems to have minimum privileges. So flags such as read only can be applied to the existing container. So limiting the use of the file system can really prevent potential attacker writing and executing scripts inside your container. So we can use, in that case, the docker run command with a read-only flag for this. So how do we do that? Let's first exit our container, okay, and you can see that there is nothing running into our Docker application. So you can do docker run it -- read only, okay, Python sh. Okay, so let's run that, and you can see that here in Docker we actually run a Python version. So for example, if you want to touch some of the files, you see that we have only read only permissions. So if I write, as you can see, touch file, we're getting an error, so we cannot touch a file because we have read only file system. So this is quite a good practice, but it also has disadvantages. And the main disadvantage of using read-only option is that the most applications need to write files and dependencies, such as the ones in the /tmp folder. And this will not work in read-only environment. In those cases, you can use folders and files in which the application needs write access to use volumes to mount only those files. So that type of volume can be provided to make persistent changes into the container if the container needs that and needs to write a file into the file system. So it is recommended, if you're using Docker, to use Docker volumes only in case of temporary files. So a volume, as you can see here, is actually a directory that is separate from the root file system of the container. It is managed directly by the Docker daemon process and can be shared between containers. So for example, you can create a MySQL container, configure it as read-only, with exception of some of the folders in which you would want to write files, and we'll try that. So for example, if I want to create a MySQL container, since this container needs a lot of dependencies, it will be hard to create it without volumes in a way that it will have read-only permissions. So let's see what would happen if we try to do that. So let's do docker run name MySQL read only, okay, and then do MySQL. So this should create a container called MySQL from the MySQL image, right? And this container should have read-only permissions. Let's try to do that. And you can see that we have some logs here in front of us. So we started the container, and so far so good. However, at some point, when we tried to create the Docker entry point sh, we had to write this file. So since we're a read-only file system, we cannot write this file. And for that reason, if I go here to MySQL, and I try to run the container constantly, you can see that it doesn't work. It never wants to run. And this is because this container is dependent on overwriting files. And you can even see that from the log. So if I go to view more details right here, you see that we read-only file system. So for that reason, we couldn't add the dependencies. So how do we fix that? Well, so firstly, I can see that here we need access to this folder. So what I will do is, before specifying which image I want to use, I will do -v, which will create a volume, and I will create this folder here. So we'll do user local bin. Okay, so I'll copy that and paste it right here. And I will also create other volumes. So let's create a volume to the MySQL library where we'll have another dependencies. So I will do here var lib MySQL. Let's do another volume of the tmp folder and another volume on the var run MySQL ID. So let's try to run this command as it is, and you will see we will get one specific error that I want to talk about. So let's run that. First, of course, make sure that you remove the previous MySQL container so you can create another one with the same name. So let's run that. And you can see that here we got another error which says database uninitialized and password option is not specified. So always when you add volumes you will need to specify password. And to do that you can see that you have a few options here, and I will use one of those actually. So I will do -d -e, and here we will create a password. So let's create my SQL root password. Okay, and this password, let's be equal to password. Okay, because we don't care. But if you create it for your file system, you would want to choose something more complicated, of course. So let's run that. Yeah, so and we need to first remove the previous container. Okay, so let's try to run it again. So before running it, I will actually remove one of our volumes. I will remove the user local bin because this is covered by one of the other volumes that I currently created, so this shouldn't give any problems. So this will be the final command that I will use. One typo that I noticed is that here I wrote MySQL ID, but in fact the right folder is MySQLD. Okay, so fix that, and then you can run the command as it is. So again, what we're creating here is simply creating the container with read-only permissions, but we're creating certain volumes in which you can read and write in order for us to be able to instantiate all the dependencies for MySQL and read and write in those volumes. And then we got required to create a password when we were creating a read-only container. So let's run that, okay? And you can see that there is a process that has been created. So let's go back and check if we have something running into our Docker Hub. So if I go here, you will see that now MySQL is running. So we successfully created it. And if I go to the logs, you will see that we have no errors here. So this is how you can start a container and mount a volume in a read-only mode. And so the final security feature that I want to share with you is how to disable the set UID and set git or GID, because if you can set those, then this user would have permissions that will access the directories and the files of the operating systems. Okay, so if you don't disable those, even users without root permissions can actually edit those files, which means that they can edit your operating system, which is something that from security point of view is definitely not optimal. So the best practice would be, in the first place, to disable the set UID permissions and to actually disable them from the Docker file. So there are two ways in which you can disable those, and one way is from the Docker file. So for example, if I open our Docker file from our previous project, okay, here where the run statement is, you can simply write run find /dash perm plus 6000 dash type f dash exec chmod a-s curly brackets semicolon and then two pipes. This command performs a search for executables and withdraws any set UID or set GID permissions from the user. So if that sounds a little bit complex for you, of course you can use that command while creating the image, but you can also disable the set UID and set GID from the creation of the container. So maybe you have an image that don't have those disabled, but if you want your particular container to have those disabled, you can do docker run -d cap drop, okay, and then let's do set GID and then cap drop set UID and then the container name that you want to run. So let's do Python, for example. So what this will do is simply create a Python container and it will drop. So we have here cap drop, and we'll talk about cap drops in more detail in the next videos, but this will simply drop some of the functionalities. So it will drop the set GID and it will drop setting the UID. So if I now hit enter, this would create a new container, which will be a Python container that will have those options. So that's it. Thank you very much for watching this video, guys. And in the next one, we will talk about the Docker Content Trust. Thanks for watching. Hi guys, and welcome back to the course. In this video, we will talk about the Docker capabilities. The Docker capabilities allow us to manage the permissions that a process can use to access the kernel and segregate root user privileges to limit actions that can be accessed with those privileges. So we already talked about that when we execute a Docker container, it runs as a root user. So as we talked, this practice is actually not a good idea, especially for services that receive requests from users or other sources. So it is quite important to note that in a container doesn't have some of the root privileges of Docker in the same way as a Docker host, even if you run this container as root. This is because Docker containers run with limited number of capabilities by default. And so here I decided to show you some of the key capabilities that the Docker container have. So the first one is the cap syslock, which is responsible for modifying the behavior of the kernel lock. Then we have the capnet admin, which is used to modify the network configuration. Then we have the capsys module for managing the kernel modules. We have the capsys row IO, which is for modifying the kernel memory. Then we have the capsys nice for modifying the properties of the processes. We have the capsys time for modifying the system clock. We have the capsys TTY config for configuring the TTY devices. And finally, we have the cap audit control for configuring the audit subsystem. So because of its granularity, the capabilities are quite useful method to execute privileged tasks with minimum permissions. This way, the capabilities are used into virtualization environments like Linux or Docker containers, where they play a fundamental role in the management of the security context. The main advantage is to avoid granting a process elevated privileges when you actually need only certain permissions for specific operation. So here you can see the commands incorporated by the libcap packages for listing and managing your capabilities. So you saw the capabilities already, but there are certain commands that can manage them. So the first one is the get cap, and this allows you to list the capabilities for a particular file. Then you have the set cap, which allows you to assign and delete capabilities of a file. Then you have the get pcaps, which allows you to get the processes for particular capability. And then you have the cap sh, which is providing you with command line interface for testing and exploring the capabilities. You can check all the capabilities by starting a container, connecting to a shell, and listing those capabilities. So let's see how we can do that. So if we go back to our terminal, let's try to create an Ubuntu image and we'll install the libcap package. So let's do run, actually docker run it and then Ubuntu. Okay, so let's do update. Okay, so let's run that, and this will give us all the backups and update our system. So after that, so let's do apt install -y and then let's do libcap to -bin. Okay, let's run that, and you can see that everything is installed successfully, and we have the newest version. So if we now do grep, which is used for searching cap into the proc, then bash pid /status. You can see all the different capabilities that are activated into the Docker container. So let's exit of this container, and the next thing I want to cover is how Docker provides commands to install or remove Linux permissions to different containers. So you can apply those by cap add and cap drop capabilities. Obviously, if you do cap-add, you're going to add a capability, and if you do cap-drop, you drop a capability. It makes sense, right? So let's try to create an image and see how we can add and drop some capabilities. So if I do docker run -cap add equals to O, and then if I do -cap -drop equals to chown-ti ubuntu sh. Okay, so let's run that, and this will create an Ubuntu container. So if I check our Docker containers, you will see that now we just run an Ubuntu container. So here in this Ubuntu container, you can do user add test, okay, and you'll see that once you do that, you cannot add user, and there is failure while writing changes in the shadow file. And this is because we simply remove that capability. However, if I do, for example, chown test, and let's say user share, okay, you're actually getting a response that this operation is not permitted, simply because we dropped the chown capability from our VM or container. So when executing this command, we can see that the action of changing the ownership or chown of the particular file share fails immediately. And you can see that we're having that the operation is not permitted. So obviously we don't have this permission to change the owner of the file even as a root user. And this is simply because that when we created the container, we strictly disabled the ownership capability. So all the Docker containers start with a little reduced capacity set, but still you can have quite a few very nice capabilities immediately when you create a Docker container. So you can use the following capabilities: changing ownerships, override, sys, netrow, netbind service, and so on. So you can really play with those capabilities and either enable or disable all of them. You can, of course, remove all those capabilities by simply writing cap-drop and remove each and every of those, and you can try it yourself too. I also recommend you to always try to remove the set UID and set GID capabilities as we did in the previous video, so you can be sure that no editing of the user IDs can be done. So if we go back to the terminal and try, let's say, to disable the set GID and UID, we can do it in the following way. You can do desktop or docker run it cap drop set GID cap drop set UID python sh. Okay, so this will simply create a new Python container in Docker, and it will disable the set GID and set UID functionalities. So let's run that, and you can see that now we're in the shell, and we also have our Python container running, and you can check whether you have permissions to enable UID and GID by writing cat proc self status. Okay, and here if I move to the top of this file, you can see that you don't have any permissions to change UID or GID, which is exactly what we aimed. So this is a very good way to manage your capabilities using the cap drop and the cap add flags. This will really improve your security and will give better control to you on the containers that you're creating in Docker. So that was everything I wanted to share with you guys in this video. Thank you for watching, and in the next one we will finally start with the Docker Content Trust. Hi everyone, and welcome back to the course. Here we will talk about the Docker Content Trust and public registry. So of course we will start by talking about what Docker Content Trust is. So the DCT or the Docker Content Trust is a mechanism that allows the developers to sign their content for a reliable distribution mechanism. So when a user downloads an image from a repository, which is an external entity, this mechanism allows you to check the image signature, receiving a certificate that includes the public key that lets you verify the image origin. So this option is disabled by default, and you will normally need to define the Docker Content Trust environment variable in order to run the Docker engine trust capability. We will do that by simply use the export command in Linux, and you just need to set it to 1. So the content trust actually protects against some very specific attacks that include protection of malicious code in the images. So for example, this mechanism protects you if a possible attacker wants to make a modification in an official image to add some code that might bug your computer. This will also help you to protect yourself versus repeated attacks. The security mechanism of the Docker Content Trust allows you to maintain the integrity of the image through the use of timestamps. And finally, the protection against key commitments will create a new key if a key is compromised, and we can create a new image or actually a new version of the image with this new key. So we can verify a Docker image normally by using the Docker Trust command, and let's see how this will be done from the terminal. So here I am in my local terminal of my local device. So the first thing you can do is to enable the Docker Content Trust by simply creating this parameter. So let's do export Docker Content Trust equals to 1. Okay. And so this is how you can enable it. And if you want to disable it, you simply set this export parameter to 0. So now I want to show you how you can actually verify image signatures. And for that, I will use a Python image that we have. So let's first do Docker images to see all the images that are installed in your device. And you can see that we're having right here our Python image, which is the latest. So if you want to verify the signature of that image, you can do Docker Trust inspect, and then we can do pretty, and then Python latest. Okay, so let's hit return here, and you can see all the signature for Python latest. And so you might see some things that make no sense to you, but actually when an image is downloaded, Docker client will return a string that is representing the image hash. And hash is something that is a commit ID or the last commit for that image, right? So using this tag, you can directly refer to the particular version that you have. So this hash is the one with which the image will be validated when performing the pull of the image from the repository. So for example, if you have this hash here, but you actually download image or you add the image and it has another hash, then you would get a checksum error because the two hashes will not be verified. So by enabling the Docker Content Trust, what your system will simply do is when you're trying to download images, it will compare this hash and will deny any images that when you compare this hash with the external one, there is no match. So let's check a tool that allows you to securely publish and manage images. So some notary objectives are to improve confidence in images that we download, either from public or private repositories, and to delegate trust between users. So here I will show you how you can download this application that has a server and a client parts. And so the client part is installed on the local machine and handles the storage of the keys locally. At the same time, it handles the communication with the notary server. So let's see how this application can be installed and work in our devices. So let's download the zip file, and I will unzip that file on my desktop. So here we have it. Double click and this will automatically unzip. And now, as you can see, you have here notary master folder. So here you can see a few files, but the one that is doing the whole execution is the Docker Compose YAML file. So if I open it, here you will see the way that the server is built and the signer, which is our client. Both of them have specific Docker file so they can load their images. Okay, so let's run this file and the application should start. So if I go back to the terminal and I go to the notary master, okay, you can see that we have all the files here. And so let's do docker dash compose build, okay, and when I select that, this will actually build our image. So that's done. It might take about 2 to 5 minutes, and after that you can do docker dash compose, then let's do build, actually let's do up dash d, okay, and this will basically run our server and client. Okay, so everything is created and run. So if I go now to the Docker, you can see that we have our notary master application that is currently running, and you can check the logs from here. Okay, and you can see here on the side, even though this is one container, it actually includes 3 containers right here. So we have the master server, the signed server, and a MySQL database. So this is a complete application that has server, client, and database that can store information. So if you do export docker connect trust equals to 1, this will create the connect trust variable, which will verify the signatures. And then if you do export docker connect trust underscore server, here you can assign the particular server that you're going to use. So you can do https /notary server, and let's do it on port 4443. Okay, so the first environment variable allows you to enable and disable the Docker content trust verification. And so if enabled, as we did, the integrity of the image will be verified relying on the Docker notary server indication in the second environment variable that we created. So that allows you to define the URL specifically where the notary server is located and check if this section is completed properly. So this is how, guys, you can set and manage the content trust of a real-time application. Thanks for watching, and in the next video we'll talk about the Docker Registry. Hi everyone, and welcome to this lesson where we will talk about the Docker Registry. So the Docker Registry pretty much provides a software distribution mechanism, and this is specifically known as the Docker Registry. This registry facilitates the discovery and distribution of Docker images. The concept of registry is fundamental, and it provides the complete set of utilities to package, send, store, and discover new images for Docker. So I already showed you the most famous registry for Docker, the Docker Hub. And registry is one of the key pieces when creating our Docker environments immediately after we start creating our own images. So having images on a registry saves us a lot of bandwidth and gives us better access and download time to the images that we want to get. So the idea of the Docker registry is that developers can extract images from the registry to create containers and deploy them either in a public or organization private cloud. So the Docker registry works almost like Git. Every image, also known as repository, is the base of the layers. So every time we build our image locally, the Docker registry only stores the difference from the previous version, but not the entire images. So this makes the creation and distribution process way more efficient. As I said, and I've shown you before, Docker registry is actually the most famous registry for Docker. And if we search here, let's say Python, you can easily find images for Python and related packages. However, the main problem with the official Docker Hub image repository is that it has some limitations regarding the number of images that we can upload and download, which means that the number of pulls and pushes is limited to a certain number for a period of time. So to avoid this problem, of course, you can set your own Docker registry for your organization, and this option is pretty logical, especially since the users are doing builds consistently and have some CI/CD system that depends on a registry for downloading images. There are of course other registries such as QA or Harbor, and those allow you to open an account and bring images as a registered user. Another option is by using the GitLab, especially if you manage your images directly from Git. Of course, you can use other registries such as Amazon AWS and so on. So the idea of this video is to teach you how to actually create a Docker registry and manage it. And this is possible because since the Docker registry is an open source project, it can be installed to any server to create your own registry with uploads, so you're able to upload your images privately. This project aims to have a tracking function on images hosted on your own server. So you can deploy a Docker registry on your own server in several ways and distribute your own Docker images. For example, for Linux distributions that include Docker registration package, you can install the package and start a service. So if we go back to our terminal, let's see how you can create a fully functional registry. So firstly, you will need to open a registry container that will be listening on a particular port. So let's do docker run -d -p, and here's where we will define our ports. So let's do 5001 on 5000, then let's do restart equals to always --name will be registry, and finally I will do registry 2. Okay, so when we run this command, our registry container should be created. So I'll hit enter here and you'll see a new process was added, and if you go here and check on Docker, you can see that we have the registry container that is listening on port 501. So now let's take or pull an image from the Docker Hub as we discussed and push it to our own registry. So I decided to pull Ubuntu 16.04, and you can do docker pull Ubuntu column 16.04, okay, and this will get you the image. Now if you don't have it already installed, it will take some more time, but since I already have it, it just updates it, okay? So once you're done with that, the next second step would be to tag the image. This creates an additional tag for the existing image, so when the first port of the tag is a host name and then a port, Docker will interpret this as a location of the registry. And for that reason, you will do docker push actually tag, and then let's do Ubuntu 16.04 and then local host, and then we're gonna pass the port 5001/my Ubuntu. Okay, so this will create the new tag as you can see, and actually if I do now docker images, you will see that here we will find on port 5001 my Ubuntu image. Okay, and I created this just now. So once you created the tag, now we can actually push the image into our local registry. So you can do docker push localhost 5001 my Ubuntu. Okay, let's click enter here, and this is actually pushing the image into our local registry that I created here. Okay, so now once this is done, we can actually remove all the locally cached images of the Ubuntu because they are already into our registry. So if you do docker image remove Ubuntu and then 16.04, okay, this will actually remove our image. And after that, let's also remove the registry as well that you saw right here. Okay, so how we can do that is by docker image remove, and then let's do, actually I will just copy it so we don't waste too much time. So go here, copy the image, we display those images by Docker images, and then simply paste it here. Okay, so now this is done, and you will see that if I do Docker images, this image no longer exists into our image database. So now our image is stored into our registry, and the best way to access it is by simply writing docker pool localhost 5001 and then do my Ubuntu. Okay, so when you click enter, you can see that we're actually pulling our image from the registry, and now it is going to be installed into our device. So if I do now docker images, you can see that we again have our image here, and we downloaded it from our local registry. So it is exactly the same way, guys, if you want to push your files into either local or public registry. Okay, the only difference it will be that you will not actually do a local host here, but actually you will do the host of the actual application. So it is really simple. So finally, once we pulled our image from our local registry, let's now delete the registry. But before that, let's first stop it. So simply do docker container stop registry. Okay, in that way you can pretty much stop any container. So now this container is stopped, and if you see here, the registry is no longer running. And then let's do docker container stop registry in case it is not stopped properly, and docker container rm-v registry. Okay, and this completely removed our container, as you can see, guys. So we no longer have our registry. So this is the complete life cycle for creating a registry, passing an image there. You can also pass multiple images if you wish, and then deleting the registry. And as I said, it's exactly the same way if you want to do either public or private registry. With the only difference that with the public registry, it's already there, so you don't need to create it. So that's it, guys. Thank you very much for watching that video. This is the last video of the Docker security section. So in the next one, we will dig a little bit deeper and we will talk about the Docker host security. Thanks for watching. Hello, everyone. In this video, we will talk about Daemon Security. So analyzing the security on the Docker host is very important because most of the attacks take advantage of the kernel vulnerability or could occur because some package haven't been updated. So here I review some tools for auditing the security of the Docker host. Now here we're going to actually cover topics like the Docker daemon and the Apparmor and the Seccomp profiles, which provide kernel enhancement features to limit the system calls. Also, we'll talk about tools like the Docker branch security with Lin, which follows the best security practices in the Docker environment. I will also share with you some of the most important recommendations that can be followed during auditing and Docker deployment in a production environment. So probably the most important element of the Docker architecture is a Docker daemon. The process guarantees communication between containers and the traffic, and it is protected by the HTTPS protocol, which is an HTTP plus a security protocol. So Docker works primarily as a client that communicates with a daemon process called Docker. The process has root privileges and is socket located into the docker.sock file. So it's important to note that Docker socket exposure can result a privilege escalation. So you should always check the access permissions by the users that are using the Docker file. So only the root user has to write permissions, while the rest of the users should not be able to compromise the container. So let's go to the terminal and let's try to create a container inside another container on the Docker host. We'll be using the docker.sock process and we will mount it as a volume. So you can simply do docker run -it-v for a volume, and the volume will be created into the var run docker docker.sock, and then let's do var run docker.sock, then let's do debian bin/bash. Okay, let's remove that space here and let's run the command. So once we run that, a new container has been created and now we're inside it. If I go to the Docker application, you can see that we created a Debian container and it is currently working and running properly. So once we are into the directory, we can simply write who am I, and you can see that we are root. And if we go to the bin bash and we do again who am I, you can still see that we are root. So that way we can see that the Docker container starts a new mount point in the host container. The second container connects to the host and you can check how effectively it is using the root user. So in that way, we checked that we have a root access to the host from the process. So if I exit this container, okay, and then do clear, so we can run another command. So let's say docker run -it -v, and here I'm going to create a volume around the host. So I will do host, okay, and then let's do debian and then bin bash, okay. So now if I do ch root /host, you can see that we're actually going into the second container, which is into the first one, okay. So this is our host container, and if I do again here bin bash, you can see that we're going back to the previous container. Let's do now who am I, and you can see that we're root in both containers. So as you saw, the Docker daemon runs the root permissions, so it is important to limit the users who have control over the Docker daemon. I can give you a series of recommendations on how you should configure the access to the directories and the files to the Docker daemon. So in front of you, you can see a table with a list of default permissions of each file that is part of the Docker daemon. So obviously here we're having R for read, W for write. So if you're not familiar with the permissions and how they're selected, definitely check them out. They are an important part of every Linux distribution. So what you can simply see here is that the group that has access to those files here or those volumes are the root users, and they have those permissions there, right? So you can see that the permissions are actually quite limited. So at this point, we have reviewed the Docker Daemon Security and the default permissions for each service that this process is using. So those files, they represent the different services. And if you ever think to work with them, you can definitely use this table as a reference to what permissions you can gain. So let's talk about how we can audit files and directories on the Docker daemon. So the Docker daemon runs with root privileges, so all directories and files should be consistently audited to know all the activities and operations that are running. We can use Linux Audit Daemon framework to audit all events that take place on the Docker host. So the daemon framework has some very nice features such as the audit process and the file modification. You can monitor dynamically the system calls, you can detect intrusions, and also register commands by user. So the Linux Audit Daemon is a framework that allows you to audit events on Linux systems, and it is normally configured using just two simple files: the audit config and the audit results. So the daemon itself is the audit config, and this file configures the Linux audit daemon and specifies on where and how events should be traced. It also defines how to behave when, for example, the disk is full, or how many logs to keep at the same time. You wouldn't necessarily need to modify this file because the standard settings are normally appropriate for most of the systems. The audit results on the other side is the file that configures which events should be selected. So let's now go to the terminal, guys, and here let's see how you can use the audit tools. You can do that by a command called auditctl, okay, and you can see that I currently have this command installed. But if you don't have that set up, you can simply write apt get install audit d, okay, and this will pretty much install the tool. As I already have it installed, my installation is quite quick, but for you it could take about 1 minute or less. So in order to indicate to the audit framework which directory or file we want to observe by using the path. For example, if you want to check out the etc passwords, we can simply do audit ctl -a exit, comma, always -f path equals /etc /password, okay, and then you can do -f perm equals to WA. And so when I hit enter here, also make sure that there is no space between the comma and the always. So when I hit enter, you can see that for me this error, this rule already exists, but for you, since you write the command for the first time, the rule will be created. So let's now go to the rules file, and you can do that by doing cd etc /audit and then rules, okay. Let's go there. Let's do ls. And here you can see that there is a file called audit.rules. Okay. And after that, let's open this file. So just use your favorite editor. And I will use vim audit.rules. And you can see that here we are having a few arguments. So here you can see the different rules. And those are the rules that enable you to audit certain directories. So you can copy and paste those rules right here. Okay, I will attach those in the description of that video, or actually into the description of the whole section, so you can use them and write them right here. So let's save this file, okay, and then simply write sudo service audit-d restart. So if we go now to cd-var, okay, then go to log audit, okay, you'll see there that we have a file that is called audit.log, and let's check out this file. So let's do more audit log, and you can see that here we're having a huge log for the audit that has been completed on your Docker system. So you don't actually need to know what is inside this log, and I'm not gonna manipulate the parameters right here and observe them, but the whole idea of that lesson is that you know how you can export log for a particular system by adding the rules and also knowing the location of the log that is generated. So this is how, guys, you can audit the entire files using the audit CTL tool. Thanks for watching this video, and in the next one we'll talk about the Apparmor, which is a quite useful tool for assigning each running process on your system to a secure profile, and we'll observe things like file system access, network capabilities, and execution rules. That's it. Thank you very much for watching, and I will see you in our next video. Hi everyone, and welcome back to the course. In this video, we'll talk about the Apparmor and the Seccomp profiles. Both of those profiles, both Apparmor and Seccomp, are responsible to provide kernel enhancement features to limit system calls. So let's first talk about the Apparmor, which is the profile with which we're going to work mostly in that section. So Apparmor enables the administrator to assign each running process to secure profile and define file system, assess network capabilities, and specific execution rules. So it basically provides protection for external and internal threats, enabling the system administrator to associate secure profile with a specific application with the goal to restrict some specific application capabilities depending on the use case. So normally the Apparmor is enabled by default for Debian-based distributions. And let's go now to the terminal and check if we have it already installed. So here I'm on my Linux VM and I have a terminal opened. And the first thing I will do is I will actually make sure that I'm a root user, because right now I'm with my username. So just write sudo su, then write your password and go to the main directory. So if now you write who am I, your root. Okay, and let's get all the information for Docker that we have. You can do that by writing Docker info. Okay, so you can see that now we're going to get some information about Docker. Okay, and right here, if I go down and look for security options, okay, you can see that we're currently having installed the Apparmor and the Seccomp options. Okay, so let's do Docker info, then let's do pipe, and let's search. So let's do grep Apparmor, okay, with A. Okay, so you can see that here we're having the Apparmor, which is one of your security options. And if you want to find the directory of the Apparmor, this is the etc apparmor.d. Okay, and if I write os, you can see all the files related to the Apparmor distribution. So if you want to install the different Apparmor profile packages, you can simply write, let's actually first go back to our root repository, and you can write sudo apt get install apparmor dash profiles. Okay, and this will pretty much get you all the profiles and packages related to Apparmor for Linux. So there are few main files that you should and directories that you should pay attention for. So the first one is the etc Apparmor, okay, and this folder contains all the files to configure the daemon. Then you would have the apparmor.d, which is a folder that contains the rule set files that limit an application access to the rest of the system. So you can of course reconfigure the Apparmor, but for the purpose of this video, the default configuration will be completely fine. So from the security point of view, Apparmor proactively protects the operating system and applications against external and internal threats by applying specific set of rules for each specific application. So when you install Docker, it normally generates and loads a default profile for containers called the Docker default. And so Docker, with simple words, generates this profile and loads it to the Linux kernel. So basically, when you create a container, it will use the Docker default policy unless you override it with a specific security option. So for example, if I write docker run --rm -it, and then if you write security-op and then apparmor equals to docker default, and then we run the application hello world, okay, this will create the hello world application with Apparmor as a security option. You can check the status of the Apparmor in the Docker host and determine whether Docker containers are running Apparmor profile or not. So you can do that by writing Apparmor status, okay, and you can see right here that we're currently having 82 profiles that are loaded, and we have 62 profiles that are in enforce mode. And if you scroll down here, you can see that we're also having this profile Docker default, which is basically assigning the security options for our Docker containers. So keep in mind that the default Docker option is now displayed in application mode as well. So as you can see, by simply running the Docker default, you're already adding valuable security options for your containers, and you pretty much don't need to configure absolutely anything. You can just use the security option right here and define the Apparmor Docker default, which is pretty simple. And if you want to apply Apparmor to your containers, you can definitely use this option in order to add some level of protection. So this is how you can configure Apparmor. Don't forget to use the Apparmor status command in order to always be able to check the status and the profiles of your processes. So in this video, I just also want to give you a brief introduction on the Seccomp profile, which is a different profile related to security. So each of the processes that we are executing on operating system have the option of interacting with the kernel through system calls. So the process could ask the kernel to perform some task, such as modifying a file, creating a new process, changing permissions to a directory, or using API by which the kernel gives access to the services. Many of the system calls are accessible to absolutely every process of the user area, but a very big part are not used for the entire life of the process. At this point, the Seccomp is a tool that allows you to limit the exposure of the kernel to the system calls for a specific application. So when you combine the Seccomp with other tools like namespaces, we can design a relatively secure application. So the Seccomp is pretty much a sandbox facility for the Linux kernel that acts like a firewall for the system calls or the syscalls. It uses Berkeley packet filter rules to filter the syscalls and to control how they are handled. So those filters limit the container access to the Docker host Linux kernel, especially for simple containers applications. So this option is normally automatically enabled on your Docker applications, and we saw it when we were checking the terminal. That was also one of the available options alongside with the Apparmor. So since it is enabled automatically in most cases, you can be sure that Seccomp is applied to your project, and even though you don't need to interact with it, it is good to know that it is there and it is protecting your containers. That's it. Thank you very much for watching this video, and I will see you in the next one, where we're going to talk about the Docker Bench Security. Thanks for watching. Docker Bench Security is a very useful tool to test the security in your Docker containers. So the main purpose of the bench security is to perform Docker check against a container and generate a report that tells you if your container is potentially insecure. So the Docker bench security mainly focuses on the best practices in areas like file permissions and registry settings. So the Docker bench security is basically a shell script that looks for common best practice patterns around implementing Docker containers in production. It is pretty much a set of bash scripts which must be run as a root user on any machine where Docker is installed. And so the tool will produce reports for every system that is checked while it is installed on that system. So from Docker host and Docker daemon point of view, this is the best tool you can use to check those best practices. So here I will bring you some components which this tool tests. So using the bench security, we will test the host configuration, the daemon Docker configuration, the configuration files of the daemon, the image container and the compilation files, the runtime container, and the Docker security options. So you can see how many things you can check just with this single tool. So to run the Docker bench security, you first need to go to Docker bench security repository. So to clone it, you can simply do git clone and then https github.com/docker/docker bench security.git. Okay, so run that and this will copy the whole repository. So now once you have it, if I do ls, you can see that we're having the Docker bench security right here. So you can do cd Docker bench security and then run the execute file, which is this one. So you can simply do sudo, or actually since I'm root user I don't need to do sudo, so you can do sh docker bench security sh, and you can see that this will run a complete diagnostics of all your systems. So what we just saw is how the Docker bench security executes a container with high privileges and runs a set of tests against all the containers in the Docker host. So here are some of the configuration checks that the Docker bench security is doing. And the first one is the host configuration. This section checks the security over the Docker host. Then we have the daemon Docker configuration files, and here in this section we'll see information about the configuration files used by the Docker daemon. This ranges from permissions to reports and properties. Sometimes those areas may contain information that you don't want others to know in a plain text format. The next one is the daemon Docker configuration. And here This section shows the information about the Docker daemon configuration and can detect containers that are running on the same Docker host and checking the areas for each other's network traffic. By default, all containers that can run on the same Docker host will have access to each other's network traffic. So if you go back to the terminal and we try to observe what we just got, you will see that right here you're having different sections that are specified with numbers, right? Those look like a section in a book. So the first section right here is the host configuration. And so wherever you have a warning, this should be reviewed at system configuration level. For example, here in the host configuration, we can take a look at ensuring a separate partition for containers that have been created to ensure that auditing has been made in the Docker daemon and also in files and directories. So you can see that here straight away we're getting some advices for what passes and what can get better in your system. So we can see that, for example, here we have many audits that are currently performed and they are passing, but also we have some warnings as well. Then if I scroll down at point 2, you'll see that here we're checking the Docker daemon configuration. So the Docker daemon configuration checks the file permissions related to the Docker daemon, such as the Docker service, the Docker socket, and so on. So it basically verifies that those 3 files can pretty much run only with root privileges. So you can see that here we're having a warning that we should ensure that network traffic is restricted between containers. We should note that the Docker is runnable right now as non-root user, which we actually verified by being signed to my personal account but not to root, so we know that this is true. Here we get some recommendations for namespace support and so on. And here below you can see section 3, which is the Docker daemon configuration files. So you can see here we're having almost actually everything passed, which is great. Actually everything is passed. Okay, and after that in section 4 we're checking the container images and build files. And you can see that for many containers we have no health check found. Okay, so this might be a good suggestion for improving those images right here. Here we will check things such as whether the Docker content trust is enabled on the Docker host or not, which was this parameter that we set up early on, if you remember, the Docker content trust, which is pretty much verifying the images on our devices. And then in section 5 we're checking the container runtime. And you can see here that there are no containers currently running. So if, for example, you run some of your containers, you get some additional suggestions here as well. So normally, if you want to execute the most significant warnings, for example, those ones here, and to solve them, we can execute the container limiting resources at memory CPU levels. We can also add read-only permissions or use non-root user for a particular container. So for example, if I run the Python container, you'll see that right here in the container runtime, we'll have few changes because now we'll have container running. So let's try that. So let's do docker run -i -t ng inx, which is a type of container. Then let's do bin and bash. And here, you know that nginx, we're going to create it as an interactive container, so we will be able to type things inside. Let's hit enter. Okay, and you can see that we run this container and right now we're inside. I will open another terminal right here, okay, and on the other tab I will simply write, first of all, sudo su, so I'm a root user, okay, and then write docker container os, okay, and you can see that we're right now having one Docker container that we're currently running, right? So let's now try to execute the bench security. So let's do os, let's go to Docker bench security, okay, and let's do sh docker bench security.sh, okay, let's run that. And if I move up here on 5, which is container runtime, you can see that now we're having plenty of options here, and this is because we're now running a container. So you can see all the recommendations, and some of them are really related to something that we studied already. So for example, here you can see that we have Apparmor already enabled. You can see the CEU Linux security option is not enabled there, so this is a warning. We also didn't start the container with security options anyways, so that's why we're getting another one, and so on and so on. You can see the different options and pretty much see what you can improve, or maybe you see options that are not enabled but you would like to keep them the same. So let's go to the other tab and write exit to stop this container. And here, if I do docker container EOS, you can see that right now we're having nothing running. So in order to improve those privileges that are not added right here, you can add commands such as read only for the container. Also, you can allocate specific CPU shares by CPU dash shares equal to, let's say, 500. You can also do bits limit equal to 1 when you create a container, and so on. You can also use the detach option. So actually adding those additional things would really help to reduce the number of warnings that you have. And the last, of course, is if you want to add security option, okay, you can add additional security options in order to improve the security of your container. So here is how you can really improve the runtime of the container in 0.5. So another very good option to actually audit your system is with a tool called Linux. Okay, so this is an open source audit tool for evaluating every Linux or Unix based systems. So if I write Linux right here, you can see that I currently have it installed, and I can check out all the commands that I can use. If you don't have it, of course, you can install it using the apt-get install option. So let's try to audit our system. So first I will run one container. Let's do the ng inx, so this will create a new container. And here in the other terminal, I will do linux command actually audit system. Okay, and you can see that now Linux in this first phase is starting to check our system. Okay, so now it executes, and you see that in green you'll be able to see everything that is a positive about your system. So whether you have the right packages installed, the right ports running, and in red you would see things that your system might be missing, and there is a warning there. You can see that it is actually quite long of execution when you run this tool. This is because it is really checking a lot of components of your Linux system. So you can see that the execution of our system is completed, and this will check all the configuration related to the boot, services, and the kernel. It checks also things related to the users, groups, authentication, and finally it will check information related to the shells, the file system, the containers, and the security frameworks. Right here you can see that we're having right now the Apparmor enabled, okay, but for example we don't have those two other frameworks, right? So this is how you can use the links to check the configuration of your Docker host, and I hope with this tool that you have now a good number of software that you can use in order to analyze whether your Docker application, and specifically your Docker host, is properly configured or not. So based on those analyses, so based on the bench security, whether you analyze it with the Docker bench security or with Linux, you can really see clearly what security options might be needed in order to improve your Docker image and container. So that's it. Thank you very much guys for watching this section, and in the next one we'll continue with the Docker image security. Thanks for watching. Now let's talk about the Docker Hub security scanning. So in addition to ensuring that the containers are properly configured from a security point of view, you should also ensure that all image layers are also free of known vulnerabilities. As you know, every image can create multiple containers, so even if you create containers from certain image and your container is secure, you might still have issues if there are some bugs into your image. And in order to inspect the images, you can use certain tools to scan that images in the Docker repositories. So here in this section, we'll review some tools such as Clair and Anchore to discover vulnerabilities in the container images by learning static analysis tools that analyze different layers that compose an image. The result of that will be the ability to be able to detect vulnerabilities in the container applications before uploading them to production. So let's talk about the Docker Hub repository and security scanning. So as you already know, the Docker Hub is a repository of Docker images in which any user can create an image and upload and share its images with the community. So there are two main types within that repository: official images that are normally maintained by official suppliers such as Apache, Nginx, MongoDB, Ubuntu, and so on. All the famous providers that are professional, and you heard about them. On the other hand, we can find images that are created from users. They've been customized and adapted to the specific needs for a specific project. So let's see how we can actually scan those images. So Docker security scanning is service available in the Docker private repositories, and it normally compares the container content which is scheduled by different layers of packages. We're inspecting those binary packages layer by layer against some list of common vulnerabilities and exposures database. So the scanning tools effectiveness depends on two main capabilities: the static analysis, depth and integrity, where the scanner discovers the image inner layers and the nature of those layers, and the vulnerability feeds quality. This indicates the coverage and how much the vulnerability list needs to be updated. So you should always bear in mind that in order to inspect our images for vulnerabilities, we can refer to those lists with known vulnerabilities and sort of automate them and use tools to check those lists and databases with vulnerabilities and see if our images is having those in automatic manner. So this is the whole idea of the image inspection. So let's see how the Docker security scanning process looks like. So the Docker security scanning is a process, and we can actually call it a tool that integrates directly with the official Docker Hub repository and allows us to automatically review images found in the public and in the private repositories. This service is available on Docker Hub public and private repositories in the Docker Cloud, and it is normally paid service in all cases with some free trials. So when a new image is uploaded to the Docker Hub or the Docker Cloud, it launches a process that extracts the image seeds and sends the image to the scanning service that scans the composite layers of packages, analyzing each of those layers with the CVE or the common vulnerabilities exposures. So finally, once the Docker analysis are completed, we're provided with a result with different vulnerabilities that are found and the level of criticality for each vulnerability. So the results report is generated, and there you'll be able to see how severe the issues in your system are. Normally, the level of criticality depends on the score assigned to the CVE code by the Common Vulnerability Score system. And I will show you right now the standard codes of that system. So firstly, you would have the high result, which means that the vulnerability is within the range of 8 and 10. Then you have the medium vulnerability, which has a score between 4 and 7.9. And finally is the lowest impact vulnerability, which is between 0 and 3.9. So this scan process can be easily integrated into containers integration and continuous delivery workflows, so that scanning can be started automatically every time the developer completes a new container. So today most of the DevOps teams only work on discovering new vulnerabilities with high criticality levels that are part of the CVE database. So the main problem here would be that the lower criticality problems could not even be discovered, but can be reached by the potential attackers. So with the Docker ecosystem, the Dockerfile describes the dependencies and what will be installed in the container so that the application can run on it. So when running within a continuous integration environment, it will automatically generate and publish in the Docker registry, including the container software dependencies. So now once we stated the levels of criticality and some of the vulnerable components of Docker, let's now see some tools for vulnerability analysis in Docker. So in the recent days, the attackers are becoming more and more advanced. They have more complex techniques on finding vulnerabilities in the Docker containers and images. So when hackers try to find more sophisticated attacks methods and techniques, the cybersecurity analysts and the researchers should always work to prevent that attacks, and they're looking to prevent the resources in risk. So due to that, DevOps requires the establishment of functional image scanning and validation mechanisms in order to comprehensively protect the image creation and container creation process. So here are some recommendations to guarantee the control of the source code and the deployment of different environments. So to do that, we need to include tools to automate and organize the source code. And that's why the first rule is the source code control. The source code control should be a common practice in the DevOps security to ensure high quality while contributing with unit and integration testing. And you probably know the main tools for doing that. Those are, for example, GitHub, GitLab, or Bitbucket. Also, a project should always have CI/CD tools. This is because the development teams use construction tools that are essential part of their automated compilation process through the CI/CD tools, and the most famous ones are Bamboo and Jenkins. This will really ensure that your code is constantly tested and the versions are up to date. And finally, there is one very nice tool that I'm also using in my current company, and this is the JFrog X-Ray. This is a security tool for container and image analysis. This solution allows you to scan any dependencies for security vulnerabilities and policy compliance. JFrog X-Ray proactively identifies security vulnerabilities that could potentially impact your environment. And the best thing is that it runs natively with the JFrog Artifactory, which is, trust me, one of the most popular artifact tools used by many organizations. So let's look at some tools that can actually perform static vulnerability analysis in the Docker images. Tools like Clair, Dagda, and Anchore. So first, let's talk about Clair security scanning. Now, Clair is an open source project for static vulnerability analysis in container-based applications. Normally, layers can be shared among many containers, so it's important to create a package inventory and compare it with the known issues or the CVEs. So this tool provides vulnerability analysis service that works with API that analyzes each container layer looking for existing vulnerabilities. The tool can actually generate a report, a list of known vulnerabilities that are currently existing in your container. It basically extracts all layers of the image and notifies the user for the vulnerabilities that were found. Another quite useful tool is the Dagda. This is also an open source tool, but in that situation, the developers chose to use Python to perform the static analysis of known vulnerabilities in the Docker images and containers. It also helps you to monitor running Docker containers and to detect anomalies. So Dagda retrieves information about the software installed in your Docker image, such as operating system packages, libraries, dependencies, and modules, and matches them against bigger database which stored all the vulnerabilities. This database
is created from the collecting vulnerability data, and it is normally a database made from MongoDB, ExploitDB, basically a database that stores static data analysis scans performed on the Docker images. You can definitely feel free to check out the project on github.com, and you can see the link below. You can see right here the basic framework or the scheme of Datga. It normally has distributions for Red Hat Linux, CentOS, Debian, Ubuntu, and Alpine, so you can pretty much use it on most of the famous Linux distributions. So Datga internally uses the OWASP dependency check to analyze the packages and the dependencies on many languages such as Java, Python, Node.js, and more. So let's talk a little bit more actually about the OWASP dependency check. Now the OWASP is an analysis tool that pretty much checks the dependencies into the Docker images. It normally performs scans about the POM XML and the manifest files into the Java projects, and in case you're using, for example, JavaScript, it would check the package.json file. So the next vulnerability tool I want to share with you is the Trivy, and it's again an open source tool that focuses on dependencies vulnerabilities in packages at the open source system level. And also it can check dependency files on many different languages. So with Trivy, you can get information for vulnerabilities for metadata such as library, vulnerability ID, or this is a vulnerability identifier, the severity of your vulnerability, and those could be critical between 9 and 10, high between 7 and 8.9, medium between 4 and 6.9, and low between 0.01 and 3.9. You also get the installed version, the fixes version, and finally the vulnerability description. So definitely feel free to check out Trivy and apply it to your images from the repository that you can see below. That said, thank you very much for watching that video, guys. This was our review for the vulnerability tools, and in the next video we will cover Clair and Qauy. Thanks for watching. Extracting other layers from the image can be also quite beneficial with tools such as Clair and Qauy. Clair, for example, provides a JSON API that extracts layers of the image and can be executed as containers created from those images. And you can integrate this with continuous integration and continuous delivery process. And in that way, this would be quite helpful for finding all the vulnerabilities inside your images. So you can check out Qauy into this GitHub repository. You can see the link in front of you. It is an open source with more than 1,500 commits. Another useful tool to provide static image analysis is the Qauy.io. This tool is also used to find obsolete and vulnerable packages and binaries. With this service, we can see information related to the image scan, including packages with vulnerabilities that have been detected in each of the layers. So you can see in front of you a screenshot of the packages and vulnerabilities detected with the Qauy. This is a screenshot from the security scanner, and here you can see the vulnerabilities divided into different levels, from high to low. So for each vulnerability, we can see the CVE number, the level of criticality, and the package that has a specific vulnerability. So with the Qauy, each vulnerability defines a series of matrices that will give a final score and level of criticality that you can see in front of you. Then this will be plotted on a pie chart, so you can get a good visualization of the vulnerability score. So some of the main matrices that were used are the assess complexity, which is a metric that measures the complexity of the attack required to exploit vulnerability once an attacker has assessed the target system. Then we have the authentication, which measures the strength or the complexity of the authentication process. For example, whether the attacker is required to provide credentials before they execute the exploit. So the fewer authentication instances are required, the higher the vulnerability score will be in that case. Then you have your confidentiality impact, which is the ability to limit access to information only to authorized user, as well as preventing access or disclosure to unauthorized users. Increasing the impact of confidentiality increases also the vulnerability score here. And finally, we have the integrity impact, which is a metric that measures the impact on the integrity of a successfully exploited vulnerability. The increase in the impact of the integrity increases also the vulnerability score. So definitely check out the QA.io if you want to get a little bit more information about the QA tool. That would be everything for this video, guys. Thank you very much for watching, and in the next one we'll talk about how you can analyze the Docker images with one very famous tool called Anchore. So let's see how we can analyze images using the Anchore tool. If you are not aware, Anchore is open source tool that inspects, analyzes, and certifies the Docker images. These analyses are done against a priority database such as Postgres that is normally formed by collection of information of vulnerabilities and security problems. Anchore will also collect some information from the logs of the Node.js, NVM, and Ruby. It will use Postgres as a database in order to store all the security problems that are recorded by the providers. So Anchore can pretty much download any image from the registry compatible with the Docker, and it will give you a result of the analysis and generate a report with details for the image and the list of artifacts, for example npm, Python, Java, and so on. It will also give you a list with operating system packages, list of image files, and the different vulnerabilities that were recorded as well. So let's have a look at the different components that the Anchore is built from. So you can implement those components to either a single container or Kubernetes cluster. So the first one is the Anchore engine command line interface, and it is provided for you to be able to rule and control the way the solution is calculated. It is mainly responsible for interpreting and sending commands that are passed to the Anchore engine API. And the engine API is actually the next main component of Anchore. This service allows the users to control the entire solution. It is also used to analyze the images and obtain policy evaluations and govern the solution complexity. Then we have the Anchore policy engine, which is responsible for scanning the vulnerabilities in the artifacts found in the image and provide quick assignment and assess the current policies on that data. And after that, we can activate the Anchore engine analyzer, which is responsible for downloading the images and their analysis. And the final component is the Anchore engine database, which is again built around the Postgres SQL database and contains tables with all necessary services that are communicated through the API calls. So basically, the Anchore engine allows the developers to perform a detailed analysis of images, executing queries, generating reports, defining policies, and so on. The open source tool is highly customizable and reusable for different jobs. It will allow you to extract packages and components from the Docker images and scan images for known vulnerabilities. So this type of engine is provided as a Docker image, and this can be also merged with Kubernetes, Docker Slam, and Rancher. So let's go now to the terminal, and I will show you how you can run the Anchore in your device. It is actually quite straightforward. So normally this engine will start in form of Docker containers. You will have a Postgres database, and you will have other microservices that will generate reports for your images. Actually, this tool will be quite useful for you if you want to analyze your Docker images. Make sure that the Docker is on in the background and is installed in your device. You can make sure that there are no containers running with Docker container LS. Okay, you can see that nothing is running. Okay, and now let's do the quick installation for the Anchore. Now do curl -0 And then we'll go to the anchor.com.io actually docs quick start docker compose YAML. Okay, so what the curl command will do, it will go to this domain and will run the docker compose YAML file to install the Anchor in your device. So let's run that. Okay, and this will pretty much show you the file. So once you verify that this is the correct file, let's actually create this 0 to O, okay, -O, okay, and this will actually open the file. So you can see that you got it now, you download it. And after that, let's do docker -compose up-d, okay, and this will run all the containers related to the Anchor engine. So now you can see all of those containers that were run. So you have the queue, you have the policy engine that we're talking about, you have the database with all the vulnerabilities. So now if you do docker container ls, you can see that now you have containers that are currently running, and those are all the Anchor containers that you just installed inside your Docker machine. And if you want to see them graphically, you can actually open the Docker dashboard, and you see that now here you have a cluster of containers, and you have the database, which is the PostgreSDB. Of course, I'm getting some warnings because my chip is AMD, right? Which is normal. So if you use MacBook with M1 chip, you might get the same thing. But you can see that all the containers are running, which means that the API, the analyzer, the queue, the policy engine, and the database are up and running. Now, once you have that, let's install the Anchor command line interface so you can control the tool from the terminal. So let's do pipe install Anchor CLI, and I misspelled it, so Anchor, okay. And for me, I will get a message that all the requirements are satisfied since I have it already installed. But for you, the installation will actually begin. Now let's clone the command line interface repository. So let's do git clone https github.com/anchor/anchor-cli. Okay, and this will actually clone the repository into the folder that you're currently in. So if I do ls, you can see that we have the Anchor CLI. So let's enter that repository. Okay, ls, let's do git status and git branch. So we're in the master branch, and then let's do python setup.py install. Okay, so this will go to the setup py file that we have right here, and it will install all the dependencies from there. Now, once this is done, you can actually run the command line interface. And with this command line interface, you can pretty much analyze every single image in your device. So let's write docker compose exec API Anchor CLI. Okay, let's run that. And now you can see all the commands that you can actually use in order to analyze your images. Okay, I will show you a few of those, but definitely feel free to explore all of them and use those commands to analyze your images. So for example, if you want to check the status of the Anchor engine, you can simply do docker compose exec API Anchor CLI system status. Okay, and you can see the status of all of your systems that are currently running. So the analyzer, the queue, the policy engine, the catalog, and the API are currently up and are running properly. Since we have all of our containers currently working, you also have the version of the database and the code version as well. So you can also check the synchronization of the Anchor with the following command. So do docker compose exec API Anchor CLI system feeds list. Okay, so here you can pretty much see the Anchor database with all the known vulnerabilities depending on the image type. So you can see here distributions for Ubuntu, Alpine, Debian, Amazon, and so on. So this is a really easy and quick way to check those vulnerabilities. So if you want to check, for example, the commands that are available for analyzing the Docker image, you can just do docker compose exec API Anchor CLI image. Okay, so here you can see how you can add image, delete image, get, import, list all images, and so on. So let's try to add an image for the Anchor to analyze. You can simply use now the add command. So if I do add, actually Anchor CLI image add, and then the name of the image, for example, let's do Ubuntu, you can see that it is unanalyzed. Let's check out what images we currently have installed. So let's, for example, take Redis. So let's do again Anchor CLI image add Redis. Okay, and we'll get here unanalyzed. So in order to start analyzing images, you first need to add them to the engine. So let's do that. You can do docker.io, actually dash compose exec API Anchor CLI image add, and here you can see that we actually need to specify image after that. Okay, so after add, let's actually add an image. So let's do docker.io /library /Debian latest. Okay, so let's run that, and here you can see that the analysis begins automatically after adding this image to the Anchor engine without any user intervention. So let's write now docker compose exec API Anchor CLI image list. Okay, and you can see that now we have one image into our image list and we're currently analyzing it, right? And you can see that this was a Debian image that we just added. So depending on the number of images that we're analyzing, they will be analyzed depending on their size and the complexity on the analysis on them. If you have multiple images, then you would have a queue for analyzing those images. So if you want to return the packages that are installed inside a particular image, you can do docker compose exec API Anchor CLI image content, and then we simply need to specify the same Debian image. Okay, so I will just go up here and I will copy it. So docker io library Debian latest. Okay, and I will paste it here. So you can see that after some time you can really see all the packages into that library. You can see the OS files, Python, Java binary, Go, and so on. If you want to get, for example, the metadata, you can do docker compose exec API Anchor CLI image metadata. Okay, and then we can again paste the image that we're currently analyzing. So if I do that, you can see the manifest, the Docker history, and the Docker file, and to make sure that all of those components are currently available. So if I want to do a similar thing, but let's try actually something else, let's try to do evaluate check. So let's, instead of image, let's do evaluate check. Okay, and you can see here the image digest. Okay, you can see the status that is passed and pretty much some general information about the image and the result, which is successful in this case with a status pass. This implies that the image has passed the evaluation of Anchor default policy. Sometimes you also get additional information if there are some things to improve into the image. Right now in our image there is absolutely nothing that Anchor is suggesting us to improve, but sometimes under this policy ID you might see some additional information for something that is not found, doesn't exist, or need to be changed. So except that, Anchor can also evaluate image based on user-defined policies. A policy, as you probably can imagine, is pretty much a set of rules to evaluate the container image, and these rules of course include security vulnerabilities checks, image black and white list checks, configuration file content, and so on. And usually Anchor is evaluating those images based on separate units, or those units as packages. So every package can have some number of policies that can be executed specific for that particular package when we're evaluating the whole image. So let's see the Anchor policies by writing docker compose, exec, API, Anchore CLI, policy, list. Okay, and as you can see, there is only one policy that can run at a time, and right now these current policies with this ID are activated, and this policy pretty much corresponds to the default Anchore policy. And you can get more information about this policy. Of course, you might want to know more than the policy ID, so you can do docker compose exec API Anchore CLI policy get, and you can simply place then the ID of that policy. So let's do that. Let's do Control-C, Control-V, and in that way you can see that we can simply get the source, the status, when it was created, and when it was lastly updated. Okay, so if you have a different policy, you can definitely get the information from there. Another way to check information about policy is if you use the option policy describe. So let's do policy describe. Okay, and here in this huge list you can see the different triggers within the policy gate, and they're pretty much the evaluators that will capture the result of the analysis of a rule. So you can see the description right here that, for example, malware checks for malware scan findings in the image. You can see what the metadata is doing and all the rest of other gates or the different rules. So you can extend this command by also writing gate. For example, let's take the gate vulnerabilities. So let's do vulnerabilities. Okay, and here you get additional description specifically for the vulnerabilities gate. You can see that here we're triggering blacklist IDs and all the different functions and techniques that are used during checking for vulnerabilities. So I hope, guys, that this was really useful for you. This is a really good tool, and you can directly apply it to your Docker images and check for vulnerabilities. You can also use it during your work if you're working on Docker installing images and you want to do a simple cybersecurity check on your images, whether they're secure or not. So that's it. Thank you very much for watching, and I will see you in the next section. In this section, we will talk about how you can analyze the vulnerabilities that appear in the Docker containers. And more specifically, let's have a look at the Docker threats and attacks. So from a security point of view, it is quite important to have some knowledge about the Docker container threats and system attacks that can impact the Docker applications. So here I will show you multiple resources from which we will explore the Docker main container threats and main vulnerabilities that you can find in the Docker images and some services and tools that are related to Docker. So if you go to this page, cvdetails.com, and you go to the Docker page, you can see organized tables with all known Docker vulnerabilities by year and see some nice graphs. So nowadays it is critical to ensure that the images you are running are up to date and do not contain software versions with known vulnerabilities. So this page will pretty much help you to find out all known Docker vulnerabilities by year and separated in different categories. So all the categories can be separated into three main most common attack sources that are vulnerable. So first, we can have direct attacks to the kernel, taking advantage of a vulnerability that has not been patched yet. Then you can have a denial of service attacks, and here the main problem is that the container might monopolize the access to certain resources such as the CPU, memory, and that could alternatively result in a denial of service. And finally, you should be very careful not to use Trojanized images. So if an attacker gets an image and Trojanize it with malicious code, both the Docker host and the data exposed within the container are all in risk. So going back to the page with all known Docker attacks, we can see a very comfortable graphs with the vulnerabilities by year, and you can actually see that, for example, for 2022, we had the year with the least vulnerabilities found. However, if you take a look at 2020, this is where actually Docker really took a hit and a lot of vulnerabilities were discovered but later on fixed. You can also see all the vulnerabilities by type. So you can see that the most common vulnerabilities are the ones from the executed code, denial of service, and bypassing. So take a look at this page at your own time, and from there you can really discover in detail all the Docker vulnerabilities that have been found. And also, if you're interested in any other type of tool and want to find out about the vulnerabilities of that tool, definitely feel free to refer to that page. So the containers will always share the same kernel and Docker host, so the container can exploit many vulnerabilities in the kernel interface to compromise the Docker host. So there are some known issues and threats inside the containers that you should be aware about. For example, your container would be under threat if it tries to download additional malware or scan internal systems for vulnerabilities or confidential data. Another way to put your container in risk is if it is forced to use system resources, because that might block another containers. Another threat is called a dirty cow that exploits the Linux kernel and allows root privilege escalation on a host or container. You can also have attacks on insecure containers by MongoDB and Elasticsearch containers. Another very common problem is actually the buffer overflow in specific programming languages libraries, and this will allow the execution of malicious code. For example, vulnerabilities such as buffer overflow can actually give control to the hackers and allow their attacks. And finally, you can also get SQL injection attacks that allows the attackers to take control on the database container in order to steal some data from that database. And especially if you are working for a company providing financial services, this data could be quite valuable for you and for your business. So one of the most critical vulnerabilities in the Docker was discovered in 2019, and this is the CVE 2019-5736. This vulnerability allowed the attackers to overwrite the host runs binary and consequently to open the host with root access. So this vulnerability was actually discovered in the utility to run containers that is called runc, and this made it possible to obtain root permissions on the host machine. This attack was actually not blocked by tools such as Apparmor. However, it was possible to block this vulnerability by enforcing a specific mode and configuration of the namespaces. So you can see here that we have some number, and this is the number according to the Common Vulnerability Scoring System, CVSS, for which we talked about in the previous videos. And this is being used to measure the criticality of the threats. So this score here is pretty much based on factors like attack vendor, complexity of the attack, privileges, user interaction, scope, and so on. So let's see what are the key matrices for obtaining this number here. So for obtaining the criticality of vulnerabilities, we can also use matrices such as the assess vector, for example, and this pretty much refers on how the vulnerability has been exploited. So an exploitable vulnerability means that the vulnerable software is bound with a network stack, and this means that the attacker doesn't require local network access. And such type of vulnerability very often is called exploitable remotely vulnerability. And an example here could be, let's say, a buffer overflow. Another very important metric is the assess complexity, and this metric measures the complexity of the attack required to exploit the vulnerability once the attacker gains access to the targeted system. For example, if we consider the case with a buffer overflow in the internet service, this would be a vulnerability with high access complexity. Another very important metric is the authentication, and this metric analyzes the number of times the attacker that he or her needs to authenticate to exploit certain vulnerability. So according to this metric, we're measuring that an attacker is required to provide credentials before the vulnerability occurs. So in general, the fewer authentications are required, the higher the vulnerability score would be here. because the easier for the attacker would be to assess the system. Then we have the metric that measures the impact of the confidentiality from the information that the attacker gets when exploiting certain vulnerability. So confidentiality refers to limiting access and disclose information to authorized users as well as preventing access from unauthorized users. So here, the greater the impact on confidentiality is, the higher the vulnerability score would be. And finally, the final metric is the integrity impact, and this metric measures the impact on the integrity from a successfully exploited vulnerability. So the greater the impact on the integrity is, the higher the vulnerability score would be. For example, if an attacker can modify any file in the target system, at that point you would have a very high score. So let's look at one of the example vulnerabilities that have been discovered in Docker. So this is the dirty cow privilege escalation vulnerability in the Linux kernel. And this would allow to existing user without privileges to perform an elevation to administration privileges, right? So if somebody logs into your Linux system that is just a standard user, he could gain on his own access to administration privileges and perform actions that he doesn't supposed to do. So cow here refers to change to write, meaning that a standard user can actually modify the read-only objects, and by modifying those objects he can gain a root privileges. So the vulnerability used in the dirty cow is the one that exploits contents of the memory while the kernel is executing system calls and perform actions to the same memory address space. And so here on this page, you can pretty much see all the versions that are vulnerable to the dirty cow exploit. They're hopefully versions that nobody is using anymore, but by checking out this vulnerability, you can see what versions you should avoid. So you can find the dirty cow repository for Docker right here, and this repository pretty much is responsible for simulating that vulnerability on some Linux versions. So that's it, thank you very much for watching, and I will see you in the next video. So we already talked about analyzing the vulnerabilities in Linux and in the Docker containers, but let's have a look at the vulnerabilities in the Docker images. So a standard audit process ensures that all containers are based on updated containers and both hosts and containers are configured securely. So in order to validate this audit process, we should bear in mind that all containers should have as minimum as possible privileges and should be fully isolated. So we should always execute the containers with minimum resources and privileges for their execution. So it's important to limit the memory and the CPU as well as the network functions. We should make sure that we only give the privileges and allocate the memory for a container specifically needed to execute its purpose. And this brings me to the next point, where we should also limit the memory and the CPU. So limiting the amount of memory available to the container will also prevent attackers from consuming all the memory on the host and killing your services. Limiting the use of CPU and the network can really prevent attackers from executing denial of services attacks. So I would always prefer my containers to have a static memory allocated to them, but not pulling as much memory as they need. Because imagine if an attacker attacks just a single container and this container is allocated all the memory of your space, he can easily create a denial of service attacks by simply leaking the memory of the container and of your entire system. And finally, you should also control very good the access controls. So Linux security models such as the Apparmor and the SC Linux should always be used to enforce access controls and limit the system calls. So you should always make sure that you are checking your images and packages and making sure that they are updated with the last version. You should always use file system in read-only mode, and this will make it way easier to find problems. Also, as I said, our images should be taking up as little space as possible, and even bearing this in mind that the larger the memory of the images is, the more hard it will be for us to audit them. And if you are sure that you have the last version of the images, also make sure that all the tools in your Linux machine and also the kernel are updated with the last versions so you avoid compatibility issues. So we already talked a lot about the different vulnerabilities and their classification, so I wanted to give you some examples of high, medium, and low criticality vulnerabilities. For example, some of the most popular high criticality vulnerabilities are the shell shock, and the shell shock is a vulnerability that allows the attacker to remotely connect a malicious executable to a variable that is executed within your bash interpreter. The other one is the heartbeat, and this is a very critical vulnerability in the open SSL cryptographic software and will allow the attacker to find information that is normally sent in encrypted form using the SSL and TLS protocols. Then a mid-range or the mid-criticality vulnerability would be something like the poodle attack, which will allow the attacker to listen to the communication between two services. And finally, a low criticality would be something like a buffer overflow, where the allocated memory can cause buffer overflow when accessing memory areas that have not been assigned. So if, for example, you want to get the latest vulnerabilities using the NVD, you can definitely use this tool. You can see the address here, and you simply need to use Python 2.7, and then you can run this code from GitHub. If you want also, for example, get all the vulnerabilities for the Red Hat Linux, you can also do that on Red Hat /security updates/CVE. Okay, and here you can see different vulnerabilities discovered into the Red Hat in Linux. So if you want to explore more vulnerabilities, I will definitely make sure that I attach to this section links with all pages with known vulnerabilities in Linux and Docker, since those are the two tools that could be critical for exploiting vulnerabilities into your Docker containers or images. That's it. Thank you very much for watching this section, and I will see you in the next one. Hi everyone, and welcome to this section where we will talk about Docker secrets and networking. And both of those terms are related. The secrets are essential for the Docker networking, especially when we want to have communication between different Docker containers. So the secrets management enables the organization to consistently enforce security policies to make sure that only authenticated and authorized people can access their resources, such as applications, platforms, cloud environments, and so on. So effective secrets management enables the organizations to remove those specific secrets and store them into configuration files used by the CI/CD tools, for example, and offer full audit to verify those secrets. So what is a secret actually? Well, secret is a specific piece of information that's required in order to authenticate or authorize user that's using encryption. So with the Docker secrets, you can manage the information that is needed at runtime, but you don't want it actually to be stored in the Docker image or some other source in a repository. So some examples of sensitive information that can be protected by the secrets would be usernames and passwords, TLC certificates and keys, SSH keys, and database name or internal server. Secrets also provide abstraction layer between the container and a set of credentials. So consider a scenario where we have to spare development, test, and production environments in your application. Those environments would have different credentials stored in development, test, and production environments with the same secret name. In that way, the containers only need to know the name of the secret in order to be working in all environments. So the Docker secrets are provided to the containers and are normally transmitted using encryption from and to the node from which they run. Secrets are usually mounted in the file system at run/secrets/secret name. So this path can be normally accessed by a container service, and so the secret will be accessed. And here we're using something that is called creating a service on Swarm. This means having a configuration within an image available on all hosts locally or mounted via network storage. That said, secrets can contain files, so we can use them easily to manage the configuration of the services, since the information would be available to all hosts that execute the service task. It is quite common for an image that we need to use credentials or files with information that we don't want to share. So if we pass those elements to the image using commands, for example, as copy and add, they will be visible in the image and anyone who has access will be able to see them. So for that reason, it is important for the Docker secrets to only be available to Swarm services, but not to standalone containers. This means that the secrets can be pushed to containers only when containers are running as a Swarm service. And now let's see how we can manage the secrets in Docker in practice. So here I have a terminal, and let's first run Docker or activate it. So first let's start Docker. If you're using Linux, you can write Docker, and if you have installed the image in your device, you can simply write Docker, and then the actual image will start, as you can see. So now once we have the Docker started and we have all the environments set up, let's go back to the terminal. Let's write Docker secret, okay, and you can see all the commands with which you can maintain the secrets in your device. So you can either create, inspect, check the list of secrets, or remove them. Pretty straightforward. So let's create a secret. Let's do echo my user. Let's do a pipe. So firstly, we initiate the name of the secret with my user, and after that, let's do docker secret create pg underscore user dash. And you can see that we're having an error, and this is because we first need to start our Swarm service. So simply do docker swarm init, okay, and then you will see that the Swarm service will actually start. So once we have that, you can just repeat the command and your secret will be created. Let's create another one. So let's do echo my secret, then let's do pipe docker secret create my secret, and then dash. Okay, let's hit that, and you see that we have now another secret. And so if you do now docker ls, actually docker secret ls, okay, you will see that we actually created two secrets, and both of them look like this. You can see the time when they were created, when they were updated, and also you can see their name. So once we have the secrets, now you can actually start a service using those secrets. For example, we can create a Redis service and grant access to one of the secrets that we created. So for example, if I do docker service create, then name equals Redis dash dash, and here you can define the secret equals to, okay, let's use here my secret, okay, my secret, and after that, let's write Redis, okay. So what we're simply doing here, we're creating a service with name Redis from the Redis image with a secret, my secret, which is going to be this one. And this is how you can create a secret for your service. Okay, so if I run that, let me actually remove first my previous run of Redis. So if you run that, here I'm getting a warning saying that the service already exists because I already use the same name, but you can see in the back that it is now actually running, okay, and we have the service Redis with the specific key that we added. So this is how, guys, you can create a secret and assign it to a particular service. And the last thing that I just want to share with you is how to actually stop the Swarm service. You can simply do docker swarm leave, okay, and if this doesn't work, as you can see, you can simply do force, okay, and once you do that, you can see that even your container will actually be removed, okay. So your Swarm service will stop executing, including all the containers and the secrets there. And now if I do secrets, docker secrets ls, you will see that we have no secrets since we didn't activate the Swarm service. So always first make sure that you activate the Swarm service with the docker swarm init, then you can create your secrets and finally assign services to those secrets. So that's it. Thank you very much for watching that video, and in the next one we'll talk about container networking in Docker. Thanks for watching. Now let's talk about container networking in Docker. So Docker networking is based on the Linux network namespaces, and so this allows you to create a complete communication stack from images, and that stack will be running on the Docker host. So when we execute a container or a set of containers from distributed service, we can use the --net option to choose between those network modes. And there are a few modes there. You can use the default bridge, a different bridge, or not provide access to network at all. So here you have some of the options that you can use with the net option. So the first one is the net equals to bridge, and this is the default behavior and creates a new network stack from the container in the Docker bridge. The next one is if you choose the option none, which allows you to execute the container without any network connection. Then you can use the host option, which means that container uses the network stack directly from inside the container. And finally, if you choose the my container option, this will inform Docker to start the container with capacity for using the container network stack. So let's have a look at the Docker network options. Now you can assess the Docker network options by writing Docker network, okay? And you can see that you can actually create a network, connect a container to a network, disconnect a container from a network, inspect a network, check for the available networks, or remove either the unused networks or a specific network that you want to remove. So if I do Docker network ls, you can see that we're having a few networks that are currently available. And for example, if you want to remove, of course, you will do Docker network rm and the particular network, or you can do Docker network prune in order to remove all networks that are not used in the latest container. So if I hit yes here and then I rerun Docker network ls, you can see that we removed the Docker GW bridge since it is not used in at least one of the containers. So if you want to initialize a container that doesn't have any communication with any network, you can use the none keyword. So let's try to do that. Let's do Docker run --net equals to none -it for interactive --rm, and let's run the Debian distribution. Okay, so let's hit that, and you can see that now we're into our Debian distribution right here. Okay, so let's exit this network. This is how you can create a network without actually container without any network. So if I run the same container, but here I write, let's say latest, okay, so use latest version, bin bash, okay, you can see that we just activated this Debian network with Debian container with no network assigned. And so if I open another terminal while this container is running, and if I do Docker container ls, and I can use this ID of the container. So let's do Docker inspect, then let's use the container ID, let's do a pipe, and then let's do grep -i addr for address. And you can see that when we create a network or a container without a network assigned, you can see that we actually have no IP addresses assigned to that container whatsoever. And this is a proof that the option actually worked. And even if you try to connect any network to this Debian container, this will actually not work. Okay, so let's exit the container. And the next thing I want to talk about is about bridges. So let's see how we can actually create a bridge or communication between two containers. Now, firstly, we're going to use Alpine image in order to create those. So let's do Docker run dit name alpine1 ash. Okay, and this is denied because I need to also add the actual image, which is Alpine. Okay, so let's run that again, and you can see that now we have another container called Alpine, which is good. Now let's create another one called Alpine2, and I will show you how you can connect those. Okay, so now we have Alpine1 and Alpine2. And if I do Docker container ls, you can see that we're having two Alpine containers currently working. So now let's do Docker network inspect bridge. Okay, and this will give you So here you see what containers are connected to the current bridge that we're using. So you can see that actually the two containers are working together, because if you check the bridge that we already have, which is, I had to say, the default option. So by default, the containers can communicate between each other. So if we check the current bridge and you go down here to containers, you see that you have the Alpine 1 image with the endpoint ID, and you also have IP address of that image. And on the other side, you also have the Alpine 1, which is the other image that is also included in the bridge, and it has IP address as well. Okay, so now let's do docker attach Alpine 1. Okay, and so let's now display, so right now you're in a Alpine 1 container, and let's now display the addresses. So let's do IP addr show, and you can see that there are a few interfaces. So the first one is the loopback device, while the second interface, or actually the third one because we are ignoring the tunnel, has the IP address of 172.17.0.2, which is the exact IP address of Alpine 1. So while you're in Alpine 1, let's make sure that the networks actually work on Alpine 1. So you know, if you're using the none option, you'll not be able to use any network. So since we didn't use it, we should be able to actually ping or connect to any external web page. So let's do ping-c to google.com. Okay, and you can see that from here you can actually ping Google, which means that your network connectivity actually works. Now let's check if we can actually connect to the other container. So if I see this is the IP address of Alpine 2, right? So if the bridge works properly, you should be able to ping this IP address. So let's do ping-c to, and then let's use the other internal IP address. So let's hit enter, and you can see that we're also having network connectivity to the other container, which is this IP address, which means that the two containers can communicate properly. However, if you do not use the IP address of Alpine 2, you can see that you're getting bad address Alpine 2, so you cannot use that. Okay, so our experiment is successful, and you can see that by default the containers are connected successfully together, and they can communicate with each other as well as with the external network. So let's exit this container right here, and I'll close both containers in order to end this in a good state. So let's do docker container stop Alpine 1 and Alpine 2. Okay, and you can see that now Alpine 1 is closed, and soon Alpine 2 will also get closed as well. Okay, and now let's remove both of the containers so you don't have them in the backlog. So let's do container rm Alpine 1 and Alpine 2. So that would be everything for today, guys. Thank you very much for watching, and in the next video we'll talk about how the containers can communicate with each other and port mapping. Hi everyone, and welcome to this lesson where we will talk about how to map ports using Docker. So as we saw in the previous section, Docker actually uses three different types of networks. Bridges is a network type loaded by default to all containers, and this is a network that creates a bridge between the network interface of the container and the virtual network interface. So this Ethernet bridge allows the Docker daemon to communicate with the Docker host network device. So a container that connects to another container with an exposed port can communicate with another exposed port. So what you can do is to assign a container port to a port of the host to make the port accessible from outside the container. So it's important to know that you need to expose and publish the port for it to be accessed from outside the Docker host network. For example, if you expose a port, the service on the computer is only accessible from inside the Docker containers. So this feature provides an inner container communication. So the service in the container is accessible from outside the internal network only if you expose and publish the port. So I will bring you some of the network configurations that can be established when we execute container. And the first one is a DNS server. That is what resolves a domain into the IP address of the service running the domain. So this is a way that we move away from the number solution, but we actually use words. For example, google.com also have some particular IP address. However, for people, it's easier to simply go to google.com instead of specifying the IP address. Then you have the DNS search, which is the setup for the DNS search servers. Then you have the -h option, which establishes the host name that will be added as an entry in the etc host file. Then you have the --link option, which allows a container to communicate with other containers without knowing their IP address. The --expose that exposes the container port without publishing that port to the Docker host. You also have the publish option, which lets you to publish the port of a container into the Docker host with a particular format. And that would be all the options plus the net option that we already looked at. And those options pretty much define the way that you can map ports between different containers. So when we add a container to a network, all of the ports are opened for machines that are within the same network and are closed for external connections by default. For example, we should make sure that we don't expose MySQL container ports as they are on the same network. And since they are on the same network, the application container can connect to the network without a problem. However, we won't be able to access MySQL port from outside the network until we publish it. So in fact, the port forwarding is actually the easiest way to expose the services that are running in the containers. So there are two main ways to start a container within port forwarding. The first one is with the -p option, which is publish all, and this usually makes sure that all the ports using the expose statement will be published into the Docker file. So this option would select random free ports on the host server when we have a request for that. The other option is the -p option, which this time is a lowercase, or the --publish. So this option would allow you to explicitly indicate to the Docker which port should be linked to a port in the container. With this option, we should specify the port where we want to listen. The container will fail if that port is currently in use. So one of the ways to do that is with the docker run -p IP command, where you should specify the host port and the container port. The other option is with the specifying only the container port, and the final option is without using IP but specifying host port and container port. So adding the expose keyword inside the Docker file will allow you to indicate that a specific port must be exposed from the image that it builds. So let's go now to the terminal and find out how we can actually define what ports to expose using the ng-inx image. So here I am in my local terminal, and let's do docker run --name docker -nginx -p, and here you can specify the host port firstly and then the container port that will be it here. Then let's do -d -nginx, and we got an error because I might have this container already created. Yes, I do have it. So if you get similar error, just make sure that you remove all ng-inx containers from your Docker device in order to run this example. So you will see that if I now repeat the command, this is actually created. So let's do now docker ps, and you see that we're actually having one process, which is the ng-inx container, and the host is 0000 8080 going to port 80 with a TCP protocol. And this means that the Docker host that's at port 8080 points to port 80 inside the container. So if I do docker inspect docker ng-inx, okay, you can see here the network configuration, and if I go up, you see that our host port is 8080. So this is how you can perform a manual mapping using the publish option. Now, if you don't want to be specific but you want to use any type of available port, you can do it with the capital P. So let's remove the ng-inx container, okay, and I will repeat the same command with the only difference that right now I will not specify any port, and I will do a capital P, which will allow us to publish any type of port within our container for networking. Okay, so now our container is created. So let's again inspect the configuration of that container, and if I go here, you see that now our host port is 55,000, which is a completely random number, and this was just the first available port that was currently in use. If I also do docker ps, you can see that we're pointing from host 55,000 to 80, and this is because we chose not to specify a specific port. This option is quite good as well, because if the specific port that you specify is busy, then trying to specify it will return error in the container. So with the capital P, you actually get the first available port, and there is higher probability chance of your command to be successful. So let's make sure that you remove this container, and that would be everything for this video, guys. Make sure that you stick to the next lecture, where I will show you how to do Docker networks management. Thanks for watching. Hi guys! In this video, I will show you how you can manage the Docker networks. So Docker also lets you create your own network configurations to use on your Docker containers. So Docker will allow you to create different virtual networks for your needs, or segment different containers in the network. This way, we can create containers in multiple networks or connect their services with each other. So this is a very good way to map the containers in the way that you like, and define networks which would include a specific container configuration and connections there. So let's see how you can create networks on your own. Now, to do that, you can use the option Docker network, okay? And here you will see the options that we already talked about, but have a look at the option create. So we haven't used that option yet, and I will show you how you can use it in order to create a network. Let's do now Docker network create, okay? And let's do -- help. So here you can see the different additions to that option. You can specify the subnet settings, the IP addresses, the driver settings. You have multiple options with which you can experiment. So let's create a bridge network on our own. So we can create our own network for any type of purpose we need. So let's write Docker network create -- subnet, and here we will define the IP. So let's do 10.10.1.0/24, and let's call it DMZ, which comes from demilitarized zone. Okay, let's run that. And you can see now here you're having some code, which means that your network is being created. So if I do now Docker network LS, you'll see that here you have an additional network that is called DMZ. So your network creation was successful. You can also inspect a particular network by Docker network inspect DMZ, and this will give you the subnet mask that we just created. It will give you the name, the type, which is a bridge, the scope, which is local, and a whole bunch of other options that you can control while creating the network. So let's see how you can actually connect a container to that network. In order to connect a container to a network, you should choose the -- network option when you specify which network we want to connect to the container. This should be followed by the name of the network to which we want to add the container to. So let's create a new ng-inx container and put it into our DMZ network. So let's do Docker container run -d -- name Docker ng-inx -- network, and let's specify our network DMZ, the one that we created. Okay, and I just missed the image, so in the end, of course, I need to specify the image. So let's do ng-inx, okay, and you can see that we created our new container. So now let's do Docker network inspect DMZ. Okay, so you will see that when we do this, now we have this container section, and right there is our Docker ng-inx container, which was successfully added to the newly created network by us. So now, when a container node is created, it's important to note that those containers can be connected by IP address or host name. But if the container is actually restarted, new parameters would be generated, such as the ID and the IP address that it uses. So in order to solve this problem within a network, Docker offers functionality of linking one or more containers that allows each time one of the linked containers is restarted, the assigned IP address does not change as it is assigned to the container name. So we will make the IP address in that way static. So I will show you how you can establish links between the containers using the linked system when one container acts as a data source and the other would act as a receiver. So the link will allow the container to communicate with another container without knowing its IP address. So we can do that by specifying the link flag. Now firstly, I will remove the previously created container, and let's write docker run -d -name and then docker ng-inx. Okay, and then let's do ng-inx. So once we have that container, now we can link another one to it. Let's first clear what we've wrote so far, and then let's create a Linux container and link it to our ng-inx container. So let's do docker run -it -name ubuntu, and then let's use the -link option, and then docker ng-inx, which is the name of our ng-inx container, and then let's specify the Ubuntu image with which we want to create the Ubuntu container. So let's do Ubuntu, and let's use version 20.04, and then let's do bash. Okay, so once you hit enter, now you have your Ubuntu container created and it is up and running. And let's now try to verify that the two containers are connected. So within the container, if you do cat etc/hosts, okay, and by inspecting this file, you can see that on IP address 172.17.02, you have the Docker ng-inx container with its specific ID, which verifies that the two containers have been connected successfully. So in addition to modifying the hosts file, Docker also creates some environmental variables with information of the other container. The information that Docker makes available using environmental variables includes things such as IP address of the link container and other information. So if I do now set pipe grep -i ng-inx, you can see that we have multiple entries with the information of the ng-inx, including both the version, the TCP port, the IP address, and so on. So here we can see all the information of the Docker ng-inx container that is available in the Ubuntu container, so we can access and discover the services of the other container using those environmental variables, and this is why we not necessarily need the IP address. So let's try another example. Now if I create a Redis container, so let's do docker run -d -name my Redis, and then let's use the Redis image, okay, and then let's try to connect a Debian distribution to it. So let's do docker run -link my Debian, actually my Redis, and then Debian env. So let's run that, and here, because of the options added, you can see that in this output Docker has configured the environment variables with the Redis port inside, and this is inside specifically into the Debian container that we just created. So Docker also had imported the environmental variables from the linked container into the Redis environment as well. So even though this functionality can be very useful, we should always keep in mind that using environment variables to store secrets such as API tokens or database password can increase the risk of data being exposed. So I hope this was useful for you guys, because now you know in detail how you can connect containers in Docker. Thank you very much for watching, and I will see you in the next section. Now, let's talk about the Docker container monitoring, and in more particular, the matrices and the events that show all the information about a container. And this is because when you work with Docker, especially in production, one of the most important things is how to measure the performance of your containers. It's important to define a comprehensive strategy to monitor your Docker infrastructure with a collection of sources, events, statistics, configuration, records, and many more. So even though there are several ways to monitor the performance and to control the execution of Docker container, we always need to visualize the logs to observe the statistics in the containers. Those statistics have a very big importance, and the most important are the statistics for the CPU monitoring and for the memory usage. So most applications send logs to a standard output, and usually when you're using Linux and other operating systems, you're normally having standard input, standard output, and standard error. So it is normal and it makes sense that the logs are part of the standard output for the system. We can see the logs directly in the console while the container is running, and we enable them. So log management is probably the most important task in the world of security. And this is because it allows you to monitor what is happening inside your containers. And different containers can run simultaneously in the same Docker host, and each of them can generate their own logs. So a centralized management of the containers is quite necessary. So for example, if you want to check the logs for a particular container, of course first you need to run the container. So let's run a Redis container and let's have a look at its logs. So if you do docker container ls, you'll be able to see the ID of that container. And let's do docker log and then just place the ID of your container. And as you can see, you can have the access of the logs immediately. So you will see the version, you will see that the container has been initialized and it is ready to accept connections. You can also see things like the port, basically everything that is happening while the container was created and while we're executing it will appear right here in the log section. So in this case, the Docker engine collects all of the standard outputs of containers in an execution log file. And if you write docker logs -help, you see all the options related to logs, so you can either follow them, for example, follow the output, you can get additional details, and so on. So now on our side, if you want to check the statistics of one or more containers in real time, you can use the stats command. So write docker stats, and here you will be able to see the stats of the container that is currently running. So if you want to check the options and some additional information for the stats, you can do docker stats -help, and you can see that the stats display a live stream of the container resource usage. So when you write the stats command, it will display you all the stats of all the containers that are currently running in your device. So I will create another ng-inx container, or actually let's create a Redis. So let's do my Redis 1. Let's then do my Redis 2. Okay, so now we have 3 containers running, as you can see. And now if I do docker stats, okay, you will basically see how much CPU is used by each container, how much memory is used. You can see that this is a very little, just 2 megabytes. What is the limit of storage that they have? You can see 7 gigabytes, and also the internet that they have. Okay, you can also see, of course, their name and their ID as well. So if you want to monitor quickly your containers and pretty much see how much resources they're using because you suspect some memory leak, then you can definitely use the Docker stats for that. So another metric that we're going to look at are the events into the Docker containers. So every process in every container, normally generates a flow of events in the container lifecycle. So the Docker events command is helping to see the lifecycle of events occurring in real time in absolutely every container that Docker is using. The sequence of events is useful for monitoring scenarios and performing additional actions such as receiving an alert when a specific task ends. So when we're running many containers in the Docker host, it will be useful if we can see the container events in real time in order to monitor or debug them. So let's see how we can use the Docker events. So firstly, let's open a terminal, and there you can type Docker events --help, and there you can see the different options. Mainly you can filter between the different events, so you have different filter options here. So you can normally filter by ID, container, event, image, plugin. So it pretty much depends on how you want to structure your output. You can also use the --since and --until command in order to monitor processes for a particular time frame. And let's actually try that. So let's do Docker events --since, and then let's do 2021-01-01. Okay, so from the beginning of 2021 until 2022-10-10. Okay, so you can see here that since I had containers running within that time period, and actually all of them, they are run on 7th of October 2022, you can see all of those event logs right here. And so from here, they're ready for analyzing. If you want to have a look at the official Docker page for checking out the events and dig into a little more detail into how to collect and filter events, you can definitely use that page on the Docker Hub. So that's it. Thanks for watching, guys. And in the next video, we will talk about performance monitoring. Hi everyone, and welcome back to the course. In this video, we will talk about performance monitoring. So today I will show you a tool which allows you to explore each layer of the content of the Docker images and the sizes and the percentage of the image efficiency. And this is the diff tool. You can find it on github.com in the link provided here. And first I will show you some of the main features of that tool, and then I will show you how you can actually use it. So the diff image shows the Docker image layer by layer and its contents. When selecting a specific layer, the content of that layer will be displayed in combination with all the previous layers. You will also see an indicator of changes for each layer. The file tree will display files that have been changed, updated, removed, or inserted. And finally, in the lower left panel, you'll see a display of the basic information for each layer and metric that tells you whether your image is space efficient in Git. So an image could be not space efficient due to file duplication across the layers and file transfer to other layers. And for that reason, the tool will give you the total wasted file space as well. So let's go to the terminal and let's write docker pull qa.io/Wagoodman, which is the creator of the tool, and then dive. Okay, and this will pretty much get the image and install it. So if you want to run it, you can do docker run --rm -it --v/var run docker.sock var run docker.sock/qa.io/wagoodman/dive latest. So let's pull the image by writing docker pull qa.io/wagoodman-dive. Okay, dive, and you'll see that the image will be downloaded into your device. So after that, if you want to check out how the tool looks like, you can simply do docker run rm it -v. Okay, so we will create a volume, and let's do var run docker sock. Okay, then let's do /var/run docker.sock, then qa.io/wagoodman/dive. Let's get the latest version and let's do --help. Okay, so once you do that, you actually see all the options from that tool, and you will see a brief description that will help you to understand what the tool is doing, and also some options such as the help, the CI, and other type of options that you can explore on your own time. But let's see how we can actually analyze a container or an image actually using that tool. Docker run --rm -it / and then let's do -v var run docker.sock var run docker.sock / and then let's do qa.io wagoodman/dive latest, and then let's write the name of one of our images, so let's do nginx. Okay, and that will run the analysis for that particular image. Okay, so we are ready, and if I extend this to a big screen, we can obtain the metadata and the layers from the image that we are analyzing when executing the dev container with a specific image identifier. So we can see here a layer details and the folder structure of the whole image right here. The different layers are separated with different hashes, so we can keep track on that as well. Right here on this side, you can see all the folders and the complete file system, right? Then you can see the permissions to those files, the size of those files, and also here you have certain options with which you can check certain type of files. So if you press Ctrl A, this will give you all the added files. If you press Ctrl R, you'll get the removed files. If you get the Ctrl M, this will mark the modified files, and Ctrl U, the unmodified. Okay, so obviously you can see when we select modified and unmodified, all files disappear as those two terms are completely reversed. Okay, so this is all I want to share with you guys about the dive tool. You can really make sure that you check all the layers, okay, the different images for each particular layer, and you can really move in and out of them and explore and analyze the image completely. That's it. Thank you very much for watching this video, and I will see you in the next one. Hi everyone, and welcome back to the course. In this video, we will talk about the key Docker administration tools. So every container consists of complete execution environment, and that includes application, dependencies, libraries, binary files, and configuration. This is called containerization and allows you to create a level of abstraction at your platform. However, in order to do that, you need a specific management tools to move the Dockerized applications to production containers and ensure their security, automation, and administration. And for this reason, in our first video of this section, we're going to talk about Portainer, which is a tool that does exactly that. So the organizations and the developers should consider the challenges associated with managing Docker environments and the need for implementing business solutions to support effective management of the Docker containers, which means that they should have a technology that allows them to successfully manage problems of distribution, compliance, and governance of some containers. So there are three main stages into the container life cycles. The first one is development, and this is the first stage. Developers create and deploy Docker containers that include items like application codes and libraries. Then they test the application, correct the errors that might occur, they add functions and improvements, and then create a new Docker image and deploy this image in new containers. And this process normally continues until the required standards are met. In the second stage, managers coordinate the automation of the application environments, which include Docker construction, testing, and deployment drivers. And finally, in the last stage, the containers are deployed in production and remain operational and available until they are out of scope. So this is the stage at which the final challenges are critical, such as the orchestration and governance, security, and container monitoring. So there are 5 major container management challenges that every organization struggles with and should address. The first one is the lack of control. So developers need independence to quickly create, implement, and test application containers. On the other side, the operation teams need control and governance to avoid excessive consumption of resources, such as CPU usage or RAM. The second challenge is the cycle from rise to production. So here it is important to maintain quality and safety while the code development increases. So you should always know that even if your application works properly and you have no issues, once you try to scale it or to make it available for bigger audience, there are a variety of issues that might appear. The cloud infrastructure does not disappear and will continue to coexist with the Docker infrastructure. The implementation of complete applications covering Docker and other infrastructures always require more advanced capabilities to orchestrate the applications and manage the running environments. So as we saw even from the previous video, the Docker containers can also integrate vulnerabilities. And this is simply because they include parts of the operating systems. So the protection of the environment requires security in the host Docker layer containers and in the images. And finally, the Docker environments always require special monitoring capabilities. And those could be API level integrations with Docker or instrumentation built into the Docker image. So here we should make sure that we follow all specific requirements for our Docker containers. So the first tool that we're going to look today is called Portainer, and this is an open source web tool that can execute itself as a container and will allow you to manage the Docker containers easily and intuitively using an easy graphical user interface. So let's open a terminal and run Portainer and see how it works. So I'll first run our Docker daemon, okay? And now here from the terminal, let's write docker run -d to run the container as a background process. Let's now specify the ports 9000 on 9000 --name, and let's call this container Portainer. Then let's do restart always. Okay, let's do -v to define some volumes in which we'll be able to write. So let's do var run docker.sock and then var run docker.sock -v Portainer underscore data. Okay, and then let's do data with a slash. That's it. And then let's do Portainer / Portainer. Okay, and then just go back and do -p before the port. So we define actually that we want to state the ports there. And also I noticed another typo that I did, which is right here before var we need to have a slash. Okay, so run that command. Okay, and you can see that now we are having a new process here. And if you check back in your Docker UI, you can see that you have one container running that is called Portainer on port 9000. If you want to check that from the terminal, you can do docker container ls, okay, and you'll pretty much see the same thing. You will see the ports, the protocol, and the name of the Portainer container. So now you can access Portainer on port 9000, and let's go to our browser and just write http localhost 9000, okay, and now you can see that you're in the Portainer page that is running on your device. And we'll go back to this page here to be able to inspect your container system. But now let's go to the terminal, and so now let's clear and let's inspect our Portainer tool. So do docker volume ls, and you can see that right here you have your Portainer data in your volumes, and let's inspect that volume. So if I do docker volume inspect Portainer data, okay, you'll be able to see the Portainer volume. So you can see the date, the mount point of the volume, the name, and the scope that is local. So now once we made sure that we have the volume and the Portainer is running into our Docker environment, you can go back to your browser and define a username and password. So here you can enter your username and password, and Bear in mind that if you don't have registration, you might see a different page, but just follow the registration instructions to create an account. Then select login, and you can see now that you logged into your account, and you pretty much can see your Docker distribution with all the volumes you have, the containers running, and so on. Now, before to continue, a very important note: if you run into problems, for example, if you forgot your password, you can use this page, Docs Portainer IO Advanced Reset Admin, from where you can follow those 3 steps in order to reset your password if you forgot it for some reason. It is pretty straightforward. First you stop the container, then you pull the Portainer helper for password, and then you run this function here, which will help you to reset your password. So you will get your username and you will get your new resetted password in case you forget it. So let's go back to the Portainer application. And so, as I said, you can see here information for your current containers, which of those are running, how many volumes you have, and how many images you have currently installed in your device. So let's click on the dashboard, and what you can see here is pretty much a summary of your Docker system. The total numbers of containers, images, networks, and volumes, one by one. You can of course click to them and also see that you also can inspect the amount of space that your images take on your device. So then if I click on the containers, the container menu will show you a list of all of the containers you currently have, and you can execute several instructions that you can normally execute through the command line, such as starting, stopping, or removing a container from your device. So let's hit one of the containers, and here you can see the data for the container, the ID, and also, as you can see, you can start it, stop it, kill it, restart it, and so on, or completely remove it. Let's try to start it, and you can see that now the container is successfully started. And if I go to our Docker image, I can see that the other container that I selected is now running as well. Okay, so let's stop that other container, and it normally takes time until that's done. Okay, so the container now is stopped, and if I go back to our Docker image, you can see that it is actually stopped. So from here, in my opinion, you have way more options and better view on your containers comparing to the Docker image. So you can definitely use this page for starting, stopping, duplicating, relocating your containers. It's really helpful to manage them. And this is the main reason why Portainer is a great tool to manage containers. In addition to the menu options here above in the action section, you can also see that there are other buttons such as logs, inspect, status, console, and attached. So for example, if you select the logs, this will allow you to see all the logs that your container has created in real time. So if you run your container, you will see how the logs are changing in front of you. So let's start the container back again and also try the other options as well. So if you select inspect, this will basically give you all the information that you need for your container, and you can extend those tabs so you can see things such as the host configuration, the host paths, mounts, volumes, and so on. Now, a very interesting tab is the status tab, because here you can really see in those graphs the status of your memory usage, CPU, network, and processes, and you can see those over time. So here is your network usage, right? You can see that the CPU doesn't use much because we are not doing active tasks with our container, and it is the same for the memory. Okay, you can select here your refresh rate, so on how much time you want those things to be refreshed, and you can use this information to manage your containers. And if you go back, the final thing that I want to show you is the console, which allows you to pretty much interact with your container from here. So you can see that here we have a bash console with a container that I just ran. So I just ran the Anchore engine. Okay, so you can see that our console works perfectly fine. And of course, before exiting, you can disconnect from the console and then go back. And finally, there is the attach button from where you can attach or detach to the console. Okay, so you can see how many options you have here, and you have really better user interface and can use plenty of options without the need to type a single command into the terminal. So let's see now our images section, and here, of course, as it makes sense, you get access to all the images currently installed in your device. So this would be the same if you would write in the terminal docker images command. It shows you the list of the images. You can see that I have 5 pages of images, so this is about 50 images installed in my device. And if you hit on the image, of course you'll get some information for that image. You'll be able to delete the image, to export the image, you'll see the size of the different image layers, and so on. So this is a very good option if you want to manage your images. You can also select them from here and decide which one you want to remove, or whether you want to build a new image directly from this button here. You can also do the import and the export commands in order to import or export particular image of your desire. Next, if you want to check out your networks, you can select the network button, and you know, in the previous videos we had a section when we were talking and we were learning how to create networks such as bridges between different containers or external ones. So in the same way, you can add and remove networks from here without the need to type a single line of code. So if I want to remove the DMZ bridge, I can simply click it and then select remove, and you can see that the DMZ bridge is completely removed. You can also add network, and if you want to add a network, here you will be sent to this page where you can specify what type of network you want to have, the name of the network, the subnet mask, IP range, and the gateway. So pretty much here you would specify how many possibilities for IP address you would like to have, what is the range of those IP addresses, and what is your gateway. And you are also able to add some advanced configuration. So do you want to restrict external access to your network? Do you want to enable container attachment, for example? And so on. It is really convenient to use the user interface as compared to the terminal. Then in volumes, you can see volumes that are already created into the volume list section. You can also add and remove volumes from there. So you can create a new volume, and here you need to specify the name of the volume and the path to that volume, right? And on the other side, if you want to remove certain volumes, you can simply click on them and select remove. So these are the main options, guys. You can also check out the templates from where you can install different images and distributions from the most famous containers out there. So if you want to get Ubuntu, Node.js, MySQL, you can see that you can have all of those here and even more. So if I select, for example, Node.js, I can easily, by just selecting it and clicking deploy a container, I can deploy a Node.js container. If you don't specify a name here, an automatic name will be allocated to your container. So if I want to deploy Node.js, now it will take some time, and then the container will be deployed, so we will get the image and we will start the container into our Docker distribution. Okay, so you can see that maybe in about 30 seconds the Node.js image have been successfully downloaded and a container from Node.js have been started into our machine. So you can see that it is pretty simple to create new containers from new images using Portainer as well. So I hope you liked this management tool, and this will really help you to manage your Docker containers and have better control on them. Thanks for watching, and in the next video we will talk about another tool, so you'll be able to choose between the two of those, or you might want to choose both. It's entirely up to you, but in the next video we will talk about another tool called Rancher. Thanks for watching. Another tool that you can use to administrate your containers is called Rancher. So let's see how Rancher architecture looks like. Now, as I said, Rancher is a platform that helps you to manage your containers and stacks. To do that, you can simply use a remote server that is connected with Rancher. So with Rancher, you can simply initialize multiple clusters in one single central place and manage them. So in a standard production, Rancher would be typically run on its own, highly available Kubernetes cluster. And if you want to actually learn more about Kubernetes, this is what we are going to start using from our next section, and we will see the key security techniques and vulnerabilities addressed with Kubernetes. So here are some of the main advantages associated with Rancher. So the first one is that Rancher allows you to create as many environments as you need and manage users and roles for the different environments. It also allows you to select a container orchestrator from several options. Those are Kata, Masos, Docker Swarm, and the most popular Kubernetes. There is also a public catalog that is called Rancher Community, where you can contribute with other people on Rancher applications. It is also famous for making a single and multi-clusters that can be deployable quite easily. And finally, this is a very easy to use tool since you have a user interface and simplified cluster operations for security policy enforcement. So you can see that there are many advantages in using Rancher, and you can definitely check out how to install it and run it on your device and explore the options there on rancher.com. I would say it's a little bit less popular than the previous tool that I showed you, but definitely feel free to check it out because it has its own advantages. That's it, thank you very much for watching, and I will see you in the next video. Hi everyone, in this section we'll start using Kubernetes, which is one of the most essential tools that enables the DevOps to unify development and operations. So in general, Kubernetes is an orchestration tool that enables us to take any software solution to a platform as long as Kubernetes cluster is deployed. And we will talk in detail about each and every component of Kubernetes, and we will deploy it in that section. So today, all major cloud computing providers are starting to offer Kubernetes as a service, freeing up the work that goes into maintaining and deploying a cluster. In that way, we can achieve a software solution that avoids vendor lock-in, being able to distribute the solution through the cloud. Vendor lock-in means that a customer is tied to a company or service without the option to move away from them. Kubernetes allows us to run solution within the clusters, so you are not locked to a particular service or a company. In addition to that, Kubernetes performs container monitoring tasks. This way, it allows us to ensure desired number of containers to be up and running, bringing us clusters to high availability. So Kubernetes has clusters that are made up from different nodes, and those nodes are normally made from pods that offer services. So a node corresponds to a real or virtual machine that contains of services that are necessary to run the pods that it contains. And every pod represents a process that is running within the cluster and can be made up of one or more running containers. So the use of Kubernetes is not only oriented to the needs of the large companies, but also to the smaller scale projects for developers who want to create their own content outside the market. So some of the main features of Kubernetes are the secret and the configuration management. And so with secret objects, Kubernetes allows you to store and handle configuration information like password and authentication tokens securely. You can deploy and alter the application without having to rebuild the container images or exposing the stack configuration secrets. Kubernetes also allows us to scale our application because using it you can generate containers within minutes to meet the demand of your application. It also allows you to recover from error or crash in the server instantly by restarting or replacing the damaged containers. It also allows you to do load balancing. So we don't need external tools to generate services and load balancing outside the Kubernetes. So Kubernetes will take care of everything automatically, and it also assigns that to its own IP address and creates a DNS for the entire node. It also allows you to do an automatic deployment. So we can update our application or go back to previous version progressively, while at the same time will give the users continuous availability. So let's look at the main components of the Kubernetes cluster. So the elements that make up the architecture of Kubernetes cluster fall into two main categories: master components and node components. So let's look at those. Firstly, as a master component, you have the Kube controller manager, the cloud controller manager that connects to the Kube API server. Then you have a data storage that is also connected to the API server, and you have a Kube scheduler. So all of those are connected to our node layer, which consists of different kubelets or nodes. and communicates to our master layer using the API server. So the master components are in charge of deciding which node each container runs on, maintaining the state of the cluster and ensuring that the desired number of containers are running at all times. It's also responsible for updating the application in coordinated manner when new versions are deployed. So let's look at each of the components of the master node. So firstly, as I said, the Kube API server verifies the configuration data for API objects like pods, services, controllers, and their cluster-related items. This component exposes the Kubernetes API and serves as a control plane frontend. At this point, the control plane nodes run the Kubernetes API server scheduler and controller manager. Those nodes take care of the runtime tasks to ensure that the cluster maintains the configuration. Then we have the Kube control manager. It processes the control loop that uses the API to monitor the cluster share state and makes modification in order to move cluster from its present state to the desired state. Then you have the Cloud Controller Manager, which is a daemon process that runs on the master node and is in charge of managing the cloud controls. And yes, those controls actually have dependencies with the main providers such as the Amazon AWS, Google Cloud, and Azure. Then you have down here also connected to the API server the Kube scheduler. And this module is in charge of workload distribution as well as maintaining the relation between the pods in order to boost the cluster performance. And then you have the cluster data storage or the etcd, and this is responsible for maintaining all the status information on the cluster and its configuration. In large clusters, it can be distributed among several nodes that do not necessarily have to be master nodes in the cluster itself. So as the Kube Controller Manager is one of the key elements of Kubernetes, it consists of four main controllers. The first one is the node controller, which is responsible for notifying and respond when a node goes down. Then we have the replication controller, which is responsible for maintaining the correct number of pods in the system. Then you have the endpoint controller, which is basically the glue that brings the pods and the Kubernetes services together. And finally, you have the token and the service account controller, which creates default accounts and API access tokens for each namespace. So normally, all the information related to the Kubernetes nodes and containers is stored in the etcd storage, and we have assignment as a key value store. The master components are in charge of making global cluster choices as well as detecting and responding to various events. Those components can operate in any server or cluster, but they are often started at the same machine when deploying Kubernetes cluster, and user containers are rarely executed on the same machine. So let's talk a little bit about the worker nodes right here. Now, firstly, here we have the kubelet, which is nothing more than a principal process that runs for each worker node. And this process is responsible to manage the node connectivity to the cluster as well as keeping the cluster informed about various pods and workloads that are operating in its own node. To every kubelet, you have kube proxy connected. So the proxy module is in charge of managing and balancing various network flows, and it functions as a network proxy. It keeps track on the set of network rules and allows the pods to communicate with one another inside or outside the cluster. In fact, it uses the operating system packet filtering layer if it is available, and its main job is to redirect the traffic. And finally, the container runtime is a software responsible for running the containers, and mainly for that we're using Docker. So these are all the components of the Kubernetes architecture. I hope this lecture was clear for you guys. Thanks for watching, and in the next lecture we'll talk about the Kubernetes object. Okay, let's now talk about the Kubernetes objects. Kubernetes objects are persistent entities on the cluster system that are used to display the cluster state. They are configured using the YAML file and are pretty much determining what applications are using the containers and what is the node that the containers are running on. They also determine the resources available for those applications and the processes and the rules associated with the applications. So Kubernetes verifies that an object exists and functions when it is formed in the cluster. So the specification of a cluster describes the desired state, the features and the configuration that you want to have on the object, while the state, for example, describe the point at which the object is in the current moment. Both of those factors are supplied and updated by Kubernetes to ensure that we have the correct state at all times. So due to the large amount of information that is usually associated with each deployment, it is not convenient to do the configuration directly using commands. For that reason, we're using this YAML file that consists of the data that you can see in front of you. And specifically, this YAML file is taken from nginx web server, and it is specifying two replicas of nginx web server running inside two containers. So here are the key points for running the YAML file, which are the specifications for the applications that are running into the container and the nodes they run on, the resources available for the application, and the policies and the rules, as we mentioned. So there are actually three main fields that I want you to pay attention into the YAML file, and those are the API version, which pretty much specifies which version of Kubernetes API we're using to create an object. Then it is the kind, and the kind means the type of object that we want to create. And finally, it is the metadata, which is a single piece of data that allows an object to be differentiated by including string of characters such as name, ID, and so on. So let's have a look at some of the main components or objects from Kubernetes that you need to know. Now, one of the most important objects that you need to understand are the pods. So this is one of the Kubernetes fundamental unit. This is the smallest and the most basic drop-down object in your model, and so the pod contains a software container, storage resources, and network resources to support that container. Then the next object are the controllers, and those objects create and manage multiple pods. They handle replicas and provide automatic repair capacity. For example, the controller can automatically replace a scheduled pod on the node with an identical replication on a completely different node if the first one fails. There are different types of controllers such as deployment, stateful sets, and daemon sets. Then we have the service object, which is an abstract way of offering network service for an application that is operating on a number of pods. So Kubernetes can assign a set of pods on their own IP address and daemon name and balance the complete load between those services. So the presence of services is normally motivated by the fact that pods in Kubernetes have a finite life cycles. Kubernetes provides name resolution of the services within the cluster in addition to the IP address assignment to them. So we will be able to communicate among the pods using the names of the previously enabled services in this way. Then we have the ingress object that provides externally accessible URLs, load balancing, TOS termination, and name-based virtual hosting to Kubernetes services by exposing the HTTP and HTTPS routes from outside the cluster to the Kubernetes services. So in real life, the ingress is simply used to expose HTTP and HTTP ports to the world so they can access your application. And the other final most important object is the ingress controller, which deploys a container into a pod in a cluster. So there are several load balancing system providers such as HA Proxy or nginx, and both of those defined their own ingress controllers that you can use. So all the objects of Kubernetes normally consist of metadata, a specification, and a state. You must interact with Kubernetes API by providing metadata and the spec in JSON format within the required field in order to create an object. The most typical method is to create a command line client such as kubectl, to which you can supply a file into YAML format and then transform to JSON in order to make an API request. Now, since I mentioned that one of the most important components in Kubernetes are the pods, let's talk a little bit about them. Now, the pods are actually the smallest deployment unit in Kubernetes. You can also specify pods with many containers, which forces those containers to be deployed in the same node at all times. This is quite useful if the containers communicate over the file system. So here you can see the different components of a pod. It has a volume, file pooler, web server, from where we can update it to the customers, and from the content manager. So normally containers are inside the pod and they have access to its network and storage resources. In terms of network, each pod is assigned to a unique IP address, and each container uses the same network, both IP and port. So if you want to define a container within the pod, you can use the name of the pod to identify it within the cluster, the image of the container to be displayed, so you can pretty much define the name of the container using an image key. We can also specify a list of variable names and values that will be injected into the container as environment variables using the standard env form key for Linux, for example. You can also define containers using a list of ports that are used by those containers. Then you can add a pull policy, which is a container unloading policy. For example, we can indicate that it always pulls the container image before deploying it. You can also add reserve and resource limits. We can always define reserves in the resources such as RAM or CPU using the resources key, and in that way we can also define limits. Also, using readiness, you can find out when a container is ready to serve traffic after it's been started and if it is still ready for this task. So in order to specify the structure of a pod, you can use the YAML format, and for example again I will use the ng INX library. So here you can see that we're defining the kind, that is pod. You have the API version, and then you have the metadata for the pod. For example, the name of the metadata is AGINX. You can define namespace and labels. So each existing pod contains of needed application, storage resources, IP address, and other container-specific parameters. In Kubernetes, a pod represents a single instance of application, which might be on one or more shared containers. So we should always remember that all the containers into a pod share absolutely the same IP address and are accessible from the local host address as well. So a pod cannot recover by itself when it dies for some reason. The Kubernetes controller decides whether to create a new one to meet the total number of pods that are desired by user. For storage, each pod can specify a shared storage that all existing containers can access and share the necessary data. The volumes created can be persistent to save the necessary information even if the pod has to be restarted. Also, when a pod is being destroyed, all the information inside that pod also gets destroyed. So for that reason we really have to use volumes in order to be able to create persistent applications. And we really need volumes because the files on a disk related to containers are all running inside various pods that are not recoverable. And of course this creates two main problems. The first one is that the container is restricted when it stops its execution, and the second one is that it's usually necessary for two containers running simultaneously in the same pod to exchange information. So you can see here on the figure in front of you how the clusters are working and how you can define volume for two particular containers. So you can think of the Kubernetes volume as a directory of various containers within a pod that can save the same information. And as you can see, on the right side, There are some different main types of volumes that are normally used, and the first one is the empty dir. This is a basic type of volume, and this is created when a pod is first allocated to a node. So it starts out as an empty directory, and then the containers will fill it with necessary data. This volume will be active as long as the pod that is contained within that volume is also active, and also the data will be finished once the pod is finished as well. The next type of volume is called the NFS volume, and the NFS will let you mount an existing network file system that is shared on the pod. When the pod completes its execution, the volume is dismounted rather than removed, which allows the information that it contains to be accessed by other pods at the same time. The other type of volume is called persistent volume claim, and this is used to mount a persistent volume, which is a way to use stored space in a durable way. And the final type of volume is the secret, which is used to pass confidential information such as passwords, access codes, or tokens to the pods. They are stored in a key value pair format using the TMPFS database that we talked earlier about. Now, another topic that I want to talk about are the deployments. You can find the deployments into this page right here into the Kubernetes website, and they use replica set, which is in charge for controlling the number of pods and their allocation between the different nodes. So you can see a YAML file of ng-inx pods, and here you can see that the kind is the deployment, you can see the API version and so on. Now, there are a few main components of the deployment. Those are the name of the deployment, which is the name with which the deployment will be identified. Then you have the deployment tags, where we will be able to define labels to be able to reference the deployment. Then you have the number of replicas desired, which is obviously the number of replicas needed for the pod that we want to deploy. Version history to control the version, and upgrade strategies, which are some set of specific strategies used during the deployment. Another interesting feature of Kubernetes are the replica sets that ensure that the number of replicas of a given pod is always executed within the cluster. This will ensure that our pods are always available. And here you can see the YAML file of that object. Kubernetes uses kubecontroller and kubescheduler services to do replica sets. So for example, if a deployment specifies that it needs 5 replicas of a pod, a replica set will ensure that there are always 5 active replicas in that cluster. So the services are another important object into Kubernetes, and a service in Kubernetes is an abstraction layer used to route traffic to the corresponding pods. It is not necessary to find IP address for each of them, whether they support TCP or UDP protocols. So labels are commonly used to define which pod should be routed, so the service simply needs that label to match regardless how the pods were formed. So here on the figure in front of you, I will draw you the basic scheme for executing the Kubernetes services, and you can see they have several components such as client, cluster IP, API server, and kube proxy, which is connected to the backend pods. So the cluster IP, which is in this cloud here, is the default service type and exposes the service with an internal IP to the cluster. This means that the service will be accessible only by objects inside it. If you notice here, we have the node port, which exposes the service to each node using the node IP address and a specific port, in that case 9060. This creates automatically cluster IP service to which the node port service is routed. So the service can be accessed from outside the cluster using the node IP and the port IP path for exposing the node. You also normally have load balancer that exposes the service externally, and it uses the node port and the cluster IP to follow the path between the pod and outside world. So we already talked about the replica sets that are intended for pods that have the same state and so can be exposed to the Kubernetes using the same IP address with a load balancer between them. There are also another type of sets that are called stateful sets that have completely different approach. So the question is actually what happens if one of the pods replicates the application deployed and have different status than the rest. So in this case, we cannot go to any of the pods under a single IP address with a balancer. So here the idea is to manage the application where those imperfections occur. So for that we're using the stateful sets that are intended for pods that require unique network identifiers, persistent storage, ordered development, or upgrades within a certain order. So in that case, pods maintain unique identifier that persists even if they are reassigned to other nodes. So since now you know how Kubernetes service works, let's talk about the Kubernetes networking model. So the decoupled microservices-based applications rely heavily on networks to mimic the right coupling that's available. Networks in general are not the easiest to understand, so Kubernetes is really not an exception because it basically needs to address four main networking challenges. The first one is the container-to-container communication within the pods that needs to create an isolated network space for each container that starts with the help of the kernel features of the underlying operating system. On Linux, for example, this isolated network space is called a network namespace, and it is pretty much shared between containers or with the host operating system. So a network namespace is created within the pod when a pod is started, and all containers running within the pod will share that network namespace so that they can communicate via the same local host. The other challenge for the Kubernetes network is the pod-to-pod communication through the cluster nodes. So as you know, pods are assigned to nodes in the Kubernetes cluster in a random way. So they should be able to connect with all other pods in the cluster regardless of their hostname, and all without the use of network address translation or NAT. And this is very important rule for the Kubernetes-based network implementation. In this case, Kubernetes network model aims to reduce the complexity and treats the pods in the same way that it treats the virtual machines that are on the same network. In that case, each virtual machine receives an IP address, so in the same way each pod also receives a separate IP address. So this model will ensure pod-to-pod communication in the same way in which the virtual machines communicate between each other. And the final challenges are the external communication from the pod. So a successful deployed application running on pods within Kubernetes cluster also requires accessibility to and from external network. In this case, the services are processed to encapsulate network rule specification in the cluster nodes and are used by Kubernetes to provide connectivity in this situation. The apps become accessible from outside the cluster using a virtual IP address after using the kube proxy to expose the services to external networks. So this will be the final slide from this video, guys. Thank you very much for watching. We covered quite a lot from the Kubernetes based architecture and object. And in the next video, I will show you how you can deploy Kubernetes in your device and run clusters. Thanks for watching. Now let's talk about some of the main tools for deploying Kubernetes. Yes, there are more than one, and every of them has its own advantages. So every Kubernetes tool really depends on the tasks that we want to perform. And because of that, each of those tools has its own characteristics and advantages. Using those, we can deploy Kubernetes into our system. Now, the first and actually the most popular tool for deploying Kubernetes is the Minikube. You can execute this tool on Linux, Windows, or Mac OS. It relies on virtualization to deploy a cluster, for example, on a Linux virtual machine. Another tool is the KubeBench, and this tool can deploy Kubernetes in a variety of ways, and its main benefit is the ability to launch minimal visible Kubernetes pools anywhere. Another tool is called KOPS or Kubernetes Operations, and this provides a set of tools for installing, operating, and removing Kubernetes clusters on cloud platforms. You can use it on the most popular cloud platforms such as AWS, Google Cloud, and so on. The next tool is called MicroEtis, and this is quite similar to the Minikube, but the main difference here is that this tool is only available for Linux, but not for Windows and macOS. Then we have the K3s, which normally runs on any Linux distribution without any additional or external dependencies. The specific in the K3s is that it replaces Docker and is able to run container runtime on its database. Another advantage of K3s is that it doesn't consume too much RAM or disk space. It consumes actually only 512 megabytes of RAM and 200 megabytes of disk space. Another interesting tool is the kind or Kubernetes in Docker. It actually runs Kubernetes clusters into the Docker containers. It supports multi-node clusters as well as high availability clusters. Kind can also run in all types of operating systems such as Windows, Mac, and Linux. And finally, we have some tool that is a new project, so I don't recommend you to use it. And this is meant to be an extension of the K3s. It is called K3D. So the final choice on which tool to use pretty much depends on the needs you have for each specific project. So there is no better or worse solution. So in this video actually, we will use the simplest way to start Kubernetes cluster, and because of that, we're going to use Minikube. Minikube will configure a single node cluster, so there's some limitation that could make the tool useless if you need to orchestrate application that needs heavy loading or launch a product in production environment, but is very useful in development and if you want to test your software products. So running a tool will pretty much launch a virtual machine with Kubernetes installed, so we will be able to run Minikube directly into the Docker host installed in our computer already. So let's try to do that. So in this web page minikube.science.kubernetes.io docs start, you can see the installation for your operating system. So for example, since I'm using macOS, I will select macOS, and here you can find all the necessary fields that you need to select and the commands that you need to write. So let's try that. I will copy the first line here and let's go to a terminal. So let's paste that command here. So what we're doing here is pretty much we're accessing this web page in order to get the version. Okay, so now we're downloading the version of Minikube, and that's done. Then let's copy the next line, which will basically install Minikube in our device. Just make sure that you write your password. Okay, and then you can simply start Minikube with the command minikube start. Okay, so as you can see, we're now starting our Minikube virtual machine. And I'm getting a message here because my computer actually is with M1 processor, so they advise me to use another version of Minikube, but this one is fine as well. You can see that here it detected that there is no Docker container called Minikube, so now it will recreate it automatically. And now it creates a Docker container for Minikube, and it also tells you how many CPUs it uses and also how much memory from your disk. So now you can see that the process is completely done, it's finished. So if I go to my Docker machine, you can see that now the Minikube is running into your device. So this means that Kubernetes is successfully installed. So let's go to our terminal right here and write Minikube dashboard, and you can see that automatically we are sent to this address, and right now you have all the information for your pods, containers, and also here on the left hand side you can see the different services and the configuration and storages in your environment. So from here you can see your replica sets, your pods, and your deployments. You can see the apps that you have and the pods that you have allocated to them, and you can see here the pods below. For example, for my NG-INX application. So let's go back to the terminal, and actually I'll close this. So you'll be able to see that I'm no longer able to interact with that page, so I'll close it. And then let's write kubectl Okay, and you can see that you also have installed now the kubectl command. And using the kubectl, you can pretty much interact with the cluster that you have installed with Kubernetes. It takes commands written from the command line, and you'll be able to check live versions, apply configurations, update resources, and so on. You have plenty of options, and we'll definitely explore the kubectl. So for example, if I write kubectl get nodes, okay, you can see that I'm currently having one node, which is the minikube, that acts at the same time as a master and a worker. If you want to display cluster status information, you can do kubectl cluster dash info, and here you can get the IP address of that cluster and the core DNS address as well. So you can see if I run the proxy IP address, I can get some metadata such as the API version, the kind, so here we have the status, and so on. So let's create now another deployment from the Docker nginx image, and I will create here another terminal so we can keep track on that. Okay, let me increase the space. And from the other terminal, let's go to minikube dashboard. So it starts here, okay. And then I'll go back to the first one and I'll write kubectl create deployment my app dash dash image equals nginx latest, okay. Okay, and I did a small typo here, so image should be nginx latest, okay. So let's hit that. And the other thing I need to do is actually to change the name of my app because I already created one when I was testing this code. So you can see that now we created my app 1, and if I go here, guys, right here, you can see that we have two replica sets, my app and my app 1, which are pretty much the same. We have two deployments since we deployed this app. We have 4 pods and we have two replica sets. So if I select, for example, my app 1, you can see the ID, the name, the age of my app, and also some metadata to identify it. So now if I write kubectl get deployments, you can see that now I have two apps, my app and my app 1. And let's check the additional information for the my app 1. So you can do kubectl describe deployment my app, actually my app 1. Okay, so you can see here the deployment information such as the age, the conditions for the deployment, the type of the package, labels, and so on. You can also get the information for the running pods by running kubectl get pods dash dash o dash name spaces. Okay, so if I make the window a little bit bigger, you can see that we have information about all the running pods, including the name, whether they're ready, their status, and the number of restarts that they've got. You can see that the my app 1, since we just created it, it has a 0 number of restarts. Okay, and now once that's ready, let's also try to get some information about the services. So you can do kubectl get services. Okay, and you can see that we're having one service right now, which is a cluster IP, if you remember from the graph, that is listening on the port 443 with the TCP protocol. You can also increase the number of replicas. So right now you can see that we're having two replica sets, okay, but you can increase this number so you can make sure how much your set is getting replicated. So you can do kubectl scale deployment, let's say my app 1 dash dash replicas equal to 3, okay, and this scales your application. And you can see that here in my app 1 we're actually getting now 3 pods instead of 2, as we created more replica sets here. If you want, you can do that also by directly editing the deployment file. So you can do kubectl edit deployment my app, okay, and here you can see your file, so you can add and remove, for example, the number of replicas, the revision history limits, the max usage, and so on. This is a very powerful file, and from here you can really control absolutely everything related to your app. So you can see that right now I have max search of 25% and I can increase that from here. Okay, if you press I, this would make you able to edit this file and to insert new variables there. But I will not actually do anything now, so I will just quit. Okay, but I just wanted to let you know that you can definitely use this file to modify your configuration. Now let's see how we can actually create web servers. You can do that by doing kubectl run web server -nginx -image equals nginx. Okay, now of course have to rename that since this service already exists. So I will just add one here, and you can see that now here we would have a new web server called web server nginx1 that is currently running. So how you can check that this is actually running from the command line is by doing kubectl get pods -o wide. Okay, and you can see here all the services that are currently running, and you can see that we have the web server nginx and the web server nginx1, and this runs along with the rest of our nodes here, but adding the -o white option will also show you the web servers. And finally, if you want to see the information for this web server, you can simply do kubectl describe pod web server -nginx1, and let me add some space here. Okay, so in that way you can get all the information for your web server that you just created. So this is how, guys, you can run your Kubernetes cluster, review your applications from the Kubernetes dashboard, and also create new pods, replicas, servers, and applications. I hope this video was useful for you, and now you feel a little more experienced and comfortable with Kubernetes. And in the next sections, we'll start exploring the security enhancements that can be done by applying DevSecOps into Kubernetes. Thanks for watching.
Hi everyone, welcome back to the channel, and in this course we will talk about Kubernetes security. So Kubernetes have become a standard way of implementing applications in containers at scale and help us handle complex container deployments. The more Kubernetes grows and evolves, some people have released their own solutions to many common problems that Kubernetes presents in production. So in this section, we're going to look at those problems and how we can solve them and implement the Kubernetes security. So Kubernetes and Docker are pretty much revolutionizing. So Kubernetes and Docker, both of them, are pretty much a revolution in the world of computing, and that includes application development and specifically DevSecOps. So both technologies combined together offer benefits like scaling and managing the implementation of an application or a service by using containers to the point of becoming a true standard for the organization. So like many other infrastructures, we should always think about procedures while implementing those technologies and try to make them as secure as possible to offer the best final performance. So from the perspective of DevOps, Kubernetes has three main characteristics. So firstly, it operates into the DevOps model. So the DevOps model implies that software developers assume greater responsibility for building and developing their applications. Another characteristic of Kubernetes is the creation of common service sets. So the application requests a service from another application, normally pointing to the IP address and a port number. With Kubernetes, we can build application in containers that provide services that are available for other containers in use using specifically those IP addresses and port numbers. And the final and very important characteristic of Kubernetes is the data center pre-configuration. So Kubernetes aims to create consistent application programming interfaces, APIs, that result a stable environment for running application in containers. So the developers should be able to create applications
that work in any cloud provider that supports APIs. This means that developers should be able to identify the version of Kubernetes along with the services tied to that version. And they shouldn't be worrying about specific configuration of the data center. So while Docker manages services that we refer as images and containers, Kubernetes on the other side wraps all those entities in what is normally referred to pods. So a pod can contain one or more running containers and is the unit that manages Kubernetes. So some of the main advantages of the Kubernetes, mainly coming from the fact that it manages the containers as pods, are the multiple nodes, where instead of simply deploying a container on a single host, Kubernetes can implement a set of pods on multiple nodes. So a node provides an environment when a container is executed. The second advantage is the replication. So the Kubernetes can act as a replication controller of every pod. And what this means is that you can set how many replicas of a specific pod can be running at all times, and we'll look into that in the next videos. This will ensure that your application will constantly be running, and in case something happens with one of the nodes, you can use the replicated ones. So service in the context of Kubernetes implies that you can assign a service name such as ID and a specific IP address and port, and then assign a pod to provide a service. Kubernetes internally tracks the location of what service can be used to redirect a request from another pod to correct IP address and port. So today I will also bring you some of the key concepts which you need to know if you consider configuring Kubernetes. The first one is the Kubernetes controller. So the Kubernetes controller acts as a node from which the pods, the replica controllers, the services, and other components from the Kubernetes environment are implemented and managed. You should normally configure and run some of the commands such as the systemd, kubeAPI server, kubecontroller, kubemanager, and the kubescheduler services in order to create a Kubernetes controller. Then you have the Kubernetes nodes that provide the environment in which the containers run. So to run a machine as a Kubernetes node, this machine should be configured to run Docker, ProxyKube, and kubelet services. So those services should be run in Kubernetes cluster for each node. Then you need to configure the kubectl command. So most of the Kubernetes administration is performed from the command line interface that Kubernetes has, and this is called the kubectl. So with the kubectl, we can create, describe, obtain, or eliminate any of the resources that Kubernetes manages. So this is quite an important tool in order to manage your Kubernetes distribution. And finally, of course, you should have resource files. The kubectl command expects the information needed to create a resource to be in either YAML or JSON file from which you can create a pod, replica controller, services, or another resource for Kubernetes. So the standard way on how Kubernetes works is to configure the Kubernetes cluster that has master controller node and has at least two nodes, each operating a separate system. In the latest updates, you can even split the master component into multiple nodes in order to have a better control. So the Kubernetes API that is managed by the kubelet should be protected to ensure that it is not accessed from unauthorized developers that want to perform malicious actions. So if unauthorized access was made to one of the containers in a pod of a Kubernetes environment, the API can be attacked with very simple commands to enable to visualize information that is running on the entire environment. So for that reason, security in Kubernetes should be focused on preventing image manipulation and unauthorized access to the entire environment. It is also essential not to deploy pods with root privileges, and also checking the pods have defined security policies and that Kubernetes is using secrets for credentials and password management. And I will show you how to do each of those services in this and some of the next sections. So that's it. Thank you very much for watching, guys, and in the next video I will show you some of the best Kubernetes security practices. Thanks for watching. Now, here we're going to start talking about security practices or the best security practices in Kubernetes. It is always advisable to follow some of the best practices at security level because in the case of Kubernetes, if some of the applications or containers are compromised, you can have issues, security issues in the whole organization. And one of the easiest ways to protect the Kubernetes security is using secrets. So this is one of the best practices, especially if you don't want to store sensitive data such as passwords, SSH keys, or tokens in a place that's accessible. So the use of secrets allows you to control how the sensitive data is used, and it significantly reduces the risk of exposure of sensitive data to unauthorized users. Another way to make sure that your security is on spot is to use firewall ports. And the firewall ports are security practice that is very frequently used since it is not advisable to expose a port that doesn't need to be exposed. So for that reason, it is the best to define the port's exposure policies to prevent that from happening. The first thing you should do is to check for the existence of some interface or to define an IP to link the service. For example, the localhost interface. Some processes are opening so many ports on all interfaces that it is better for them to have a public access firewall. This is because they allow purely confidential information and direct access to a set of computers. For that reason, a public firewall, which is the most secure, should be implemented in that cases. Another very good option is to restrict the Docker pull image command. So Docker is a resource that sometimes could be a little uncontrolled just because it is so simple to use. So everyone who accesses the Kubernetes API or the Docker container can obtain an image from them if they want. That access could generate traffic from infected images and cause serious security problems to your Kubernetes distribution. And trust me, this is quite a common practice because recently many clusters have also become a network for Bitcoin miners. So there is actually a plugin called Image Privacy plugin that can, if not solve completely, can significantly reduce and restrict the image access, and it connects directly with the Docker API. This plugin adds series of strict security rules that reflect a black and white list of images that can be exposed. Another way is to use an image privacy webhook with admission controller. This would intercept all images that are extracted and take care of the security, just like the plugin that I already mentioned. You should always note the authentication and the authorization mode that your system is using. This can be done by verifying the parameters, where you can also check if the authentication is configured anonymously. It's important to know that this configuration will not affect the kubelet authorization mode since it exposes an API to its own from where it executes commands that kubelet can completely ignore. So when we talk about giving permissions in a Kubernetes cluster, we'll have to talk about the role-based access control, which manages the security policies for users, groups, or pods. It is implemented in a stable way in the latest version of Kubernetes, and you can actually define those specific rules by using the following code. So you need to simply add the API version of the authentication, the kind, which is the cluster role, and then the metadata and the rules, the security rules that you would like to apply to your project. And finally, it is important to have a good management of your resources and limits. It is important to manage the resources and limits that you are going to assign to your applications when creating container in Kubernetes infrastructure, especially in production. This is quite important at a security level because a single container can generate a denial of service when sharing a host with other containers. So in the generation of the pod, we can easily control it through the requests and the limits section in the deployment execution file, a file that is quite similar to this one. So let's look at some of the specific security feature components that are built in Kubernetes. This is because Kubernetes already offers native security features to protect against some of the threats that I already described and mitigate the potential impact of those risks. So some of the main safety features include the role-based access control, because Kubernetes allows administrators to define the roles and the cluster roles that specify which users can access which resources and in which namespace or entire cluster. In this way, the role-based access control provides a way to regulate the access to the resources. Another quite good safety feature is the pod security policies and the network policies. So administrators can configure pod security policies and network policies, which will pretty much place restriction on how containers and pods can behave. For example, pod security policies can be used very well to prevent containers from running as root users. On the other side, the network policies, for example, can easily restrict the communication between the different pods. And finally, another very nice built-in feature is the network encryption. So the standard encryption that is used in Kubernetes is the TLS encryption, and this is set by default and provides additional protection for encrypting the network traffic. So all those three security features of Kubernetes provide a very good defense against certain types of attacks, but of course they do not cover all threats. And so I also provide you a list with threats from which Kubernetes doesn't offer native protection. And the first one is the malicious code or incorrect settings inside containers or container images. For example, a third-party container scanning tool should be used in order to scan the container because Kubernetes doesn't have built-in feature for that. Another one is security vulnerabilities in the host operating system. And because Kubernetes pretty much doesn't control the operating system in which it runs, you should make sure that you have other tools to control that. Some Kubernetes distributions like OpenShift integrate security solutions like SE Linux in order to protect the Linux kernel, but this is not a root feature of Kubernetes itself. Kubernetes also doesn't offer support for container runtime vulnerabilities finding because Kubernetes has no way of alerting if a vulnerability exists in the runtime or if an attacker is trying to exploit vulnerability at the time of execution. Another risk is the Kubernetes API abuse because Kubernetes pretty much doesn't do anything to detect or respond to API abuse beyond the security policy settings that you can define. And finally, it doesn't have management tools for finding vulnerabilities or configuration errors. This is because Kubernetes cannot guarantee that management tools such as the kubectl are free from security issues. So normally a secret is everything that nobody else in the cluster should know, neither the rest of the application nor the users that access the cluster. For example, a password from certificate store, an API key, and so on. So let's say that someone discharges those resources along with certain permissions. From there, it is the application that requests those secrets from Kubernetes by presenting the information that authorizes them to consume those resources. So authorization management is done through what is also known as role-based access control. This means that the application can access certain types of resources only if you have certain role. So you can see that using secrets will pretty much allow you to control how sensitive data is used and significantly reduce the risk of exposure of sensitive data to unauthorized users. This information is often posted in the pod specification or in the container images, and so a secret can be generated both by the user or by the application. So here you can see the basic model for how you can store secrets in the cluster. You can see that the pod and the secret are into two separate places, and once you have both of those, you can go to the node and from there to the database. Other interesting facts about the secrets are that the secrets are pretty much objects with namespaces, and so they exist in the context of a namespace. You can normally access them through a volume or environmental variable from the container that is running the pod. So I would say let's see some examples on how you can create a secret with username and password for a Postgres database. So let's open a terminal and make sure that Kubernetes is running in the background. Okay, and now let's create some files. Okay, so let's do echo -n user. Okay, and we're gonna save that into the user.txt. Okay, now let's create a password. So let's do echo -n password, and then we will save that into a new file called password.txt. Okay, so let's now create a Kubernetes secret from both of those files. Now let's do kubectl. Okay, and actually before executing the command, make sure that you also run Kubernetes. So let's create a new terminal, and you can do that with Minikube that you already installed. So let's do Minikube start --wait equals to false. Okay, so you can see that now your Minikube distribution is starting, and so now you can see that Minikube is running. So let's go back to the terminal and let's do Minikube or kubectl create secret, and then this will be generic secret. Okay, db -user -password -form -file equals user.txt -- let's do here from instead of form, and let's now use the other file. So from file equals password.txt. Okay, so let's hit enter now, and you can see that here this already exists for me, but I guess for you this was a successful creation. I will just edit the name a little bit, so I actually create another secret file since I already have this one. Let's do password s. Okay, and you can see that the secret has been successfully created into my device. So if I do now kubectl get secrets, you can see that I have that secret that I just created right here, that was created 15 seconds ago, as you can see. And on data, you can see too, since we use two files. So if you want to see the definition of that file, you can do kubectl describe secret db -user -password -s in my case. Okay, so you can see that here this secret has two files. One is 8 bytes and the other one is 4 bytes, and both of those are text files, the password and the user that we just used. So once the secret is created, there are pretty much two ways to consume the secret. You can mount them as a volume, or we can access them from the pod. So we're going to the second one, and in order to do that, we will need to create a YAML file with all the creation parameters. So here is the deployment pod YAML file, and it has a pretty known structure. So what we're doing here is we're defining the kind, we're defining the API version, which is version 1, the name, the app that we want to use, okay, and also we're defining, of course, the specs, the path within the image, and also we're defining, as you can see, the files that we want to use. So we use username txt and the password txt files. Okay, so you can take that file from here and just type the information that you can see, or I will also provide this file, of course, as a source code in this section, so you can use it and see how it works. What you simply need to do is to go to the directory where you have this file. Okay, so for example, I have it right here. Here it is, deployment pod YAML. Okay, and then you just need to run the command kubectl apply -f deployment pod.yaml. Okay, so let's hit that, and you can see that now we have the deployment app that has been deployed into Kubernetes. So the app is being created. So if you go to another terminal and write minikube dashboard, you actually be able to open the Kubernetes dashboard and you will see your Postgres deployment app right here. And you can see that you're using the image Postgres, and also your app is using the label Postgres. Okay, so let's go back, and here you can see the deployments, the jobs, basically everything you need to see from your Kubernetes. So I will keep that dashboard, and I will go again to the terminal, and I will actually run another file that will be called secretpod.yaml. Let me show it to you. Okay, so this is another file which will pretty much run Alpine image and will make sure that our secrets are within a secret volume, which will help them not to get accidentally leaked. Okay, so again, I'll provide you this file into our source, and let's actually run it. So let's do kubectl create -f secret pod.yaml. Okay, so let's hit enter right here, and you can see that now we created a new pod, right? So before we were creating distribution, but now we create a new pod and we applied our secrets there. Now if I go here and I go up, you'll see that we have our pod up and running. You can see that the light is in green, so it is properly running into our Kubernetes cluster. So once this pod is available, you can actually list all secrets available if they are a regular data. So if I do kubectl exec-it secret vol pod, and you can do here ls etc secret volume, okay, you'll be able to see the passwords from which and the files from which you're creating the password and the user. So this is how, guys, you can create secrets, but let's see some additional strategies that we can follow in order to manage the risks of putting your application in Kubernetes in danger when you want to run it into production. So you should always try to integrate the security from the early stages of the development. With Kubernetes, it is necessary to integrate the security at each stage of the software development process. It is a mistake to leave the security settings for the last step, where it might be pretty much too late. You should also consider the commercial platform of Kubernetes. So when you participate into the Kubernetes trading platform, the most important benefit you get is the rapid structural responses from the Kubernetes development team for any threat or problem that you face. You will be updated quickly for any vulnerability, and also you will have the most latest security policies implemented. Even though this version might be paid, if you're running a business on long term, this might save you more than it would actually take from you. And finally, don't trust to old security tools or practices. This is because, just like you, the attackers update faster than the software. So some of the technologies that are outdated might not work with the new attacker techniques. You should not assume that your conventional security tools will always protect you. Many open source tools evaluate Kubernetes clusters or perform penetration tests on the clusters and the nodes. It is always necessary to keep your software updated and patched. So some of the most common security risks are normally appearing, for example, in the containers, because they can contain malicious code that was included in your container image. They can also be subject of misconfiguration and allow attackers to gain unauthorized access under certain conditions. Also keep an eye on your host operating systems, because it is quite common to find vulnerabilities and malicious code within the operating system installed on the Kubernetes node. Kubernetes also supports a variety of container runtimes. All of them can contain vulnerabilities that allow attackers to control individual containers, escalate attacks from container to container, and even gain control on the Kubernetes environment. And finally, you should also know that Kubernetes always relies on internal networks to facilitate communication between nodes, pods, and containers. It also quite often exposes applications to public networks so that they can be accessed over the internet. Both network layers, internal and external, can always allow attackers to gain access to the cluster or escalate attacks from one part of the cluster to another. That said, thank you very much for watching this video, guys. It was a long one, but I'm sure that you learned quite a lot about the most common Kubernetes vulnerabilities and how to manage and create Kubernetes secrets. Thanks for watching, and I will see you in the next video. Hello everyone. Today we're going to talk about how you can analyze the Kubernetes component security. And those components are pods, containers, and other elements of the Kubernetes architecture. So, as you already know, pods are actually the main component of Kubernetes and represent one or more components that share network. For that reason, their security is very important and it needs to be implemented in one of the first steps of the cluster design using security policies. So if you want to actually check out some examples on how you can apply the Kubernetes security policies, you can check out on Kubernetes IO pods security policy. You can see that now, even today, we're actually use pod security administration and also third-party security plugins. So definitely feel free to check out specifically pod security administration and the pod security policy, since those are the core for understanding the security for pods. So according to official documentation, a pod security policy is a cluster level resource that pretty much controls some aspects from the pod security. So those security policies are normally defined with a pod security object, and using that object we can actually define conditions that the pod should meet in order to be accepted by the system. It also allows you to define the default values in fields that are not specifically assigned. So as you can see, to define pod security policy, you're using the manifest YAML file that would normally have the type of your object, the metadata, the specifications, and the supplemental groups, such as users, groups, and host ports. So even though the privacy policy is depreciated, it's actually important for you to see how a policy file or a policy YAML file looks like and how are the different fields defined. So the pod security policy will normally allow the administrators to control the containers in privileged mode, and to do that there are 4 fields that allow us to define the behavior of a container with respect to the access to certain parts of the host. And those fields are the host bit, which controls whether the pod containers share the same process space and the host. Then you have the host IPC, which controls whether the containers in the pod share the same IPC space, the host network that defines whether a pod can use the same host network space. It also implies that the pod would have access to a loopback device and the process running in the host. And finally you have the field host ports that defines the range of ports that are allowed in the host network space. So this range of ports is given by the host port range, that is a field that has a min and max attributes that can pretty much define the range of the ports. The other key value is the volumes and the file systems, and this has volumes, which provides the list of permitted volumes that will not be read-only and will be able to write files there. Then you have the FS group that allows you to indicate the groups where to apply certain volumes. Then you have the field allow host paths, which specifies a list of paths that is allowed to be used by the volumes. And for example here, if you paste an empty list, that would imply that there are no restrictions. And finally you have the read-only root file system, which pretty much requires the containers to run with root file system in read-only mode. Then you have the users and the groups. And so the user groups can have the following parameters. You have run as a user that will specify which container will run inside the pod, and also run as a group which specifies which group ID of containers will run inside the pod. So here pretty much the difference is that if you run as a user, you just specify one container to run in the pod, while at the same time you can actually group certain containers, add an ID to them, and once you specify this ID, they can run in the same pod by a single reference. And finally, we have the privilege and the capabilities. So for example, the privilege escalation will prevent from changing the user effective ID and will also prevent enabling extra capabilities, so your system will be more secured. On another side, the capabilities are pretty much series of super user privileges that can be enabled or disabled independently. So let's look at the fields for privilege and capabilities. So for example, the privilege escalation is defined by the allow privilege escalation field, and this specifies whether or not to set the security context of the container. By default, this parameter is actually equal to true to avoid any compatibility problems. Then you have the default allow privilege escalation, which allows you to set the default option of the allow privilege escalation. So those two parameters are pretty much dependent. So in the capabilities section, you have the allowed capabilities function, which is pretty much a list of capabilities that can be added to the container. So as you know, all the capabilities are actually added by default. So if this field is empty, this implies that you cannot add capabilities beyond the one that are already there by default. And then you have the request drop capabilities parameter, which is the list of capabilities that must be removed from the container. They will be removed from the default capacity group, and these capabilities should not be included in the allowed capabilities list. So for example, two very useful types of controls are the liveness and the readiness probes. So health checks are very important in Kubernetes, and for that reason it is a very good practice to perform liveness and readiness probes. For example, the liveness probes is used to check if the application is still running or has stopped. Kubernetes normally doesn't do anything if your application runs successfully, but it will actually launch a new pod and run the application if your application has been stopped. The readiness probe on the other side is used to verify that the application is ready to start to send traffic. So Kubernetes will stop sending traffic to the pod until it has health checks fails. That said, thank you very much for watching, guys, and I will see you in the next section. Hi everyone, and welcome to this section where we will talk about auditing and analyzing the Kubernetes vulnerabilities. So in this first video from that section, we will talk about a tool called KubeBench Security, and I will show you how it works and how you can use it in your Kubernetes installation. So let's get started. So here in this video, we will talk how you can apply the CIS benchmark standards with the KubeBench. So the CIS benchmark standards are security standards for different systems that are carried out from the center of the internet security. This center aims to make our operating systems way stronger by identifying vulnerabilities. So compliance with those standards is quite common, especially for environments that are for government use. So if you are concerned about security, it will always be the right thing to do to make sure that we're meeting the CIS benchmarks. So we can actually use a tool called KubeBench to verify that we're meeting the CIS benchmarks. And this is a tool that will pretty much automate the entire process of validating the CIS benchmarks for Kubernetes. So we can normally install this tool by using the container from the Docker Hub, and I will show you in this video how you can install it. So this tool pretty much supports tests for multiple versions of Kubernetes that are defined in the CIS guidelines. So the easiest way to do that is by launching a Kubernetes cluster. And let's see how this is done. So what I want you to do is to simply go to the KubeBench repository in GitHub and download it as a zip file. And I will show you how you can navigate to this zip file and very easily launch KubeBench for your device. So as you can see here, I have the KubeBench now installed in my device. I extracted the zip file, and now this is the folder where I have it. Now make sure that you have Docker and Kubernetes running, so you can run Docker by clicking on the icon, and you can run Kubernetes from Minikube, as we did before with that command here. So once you have that up and running, then go to the terminal and try to navigate to the folder of the KubeBench installation. So since mine is on the desktop, I will do cd desktop and then KubeBench main2. Okay, then let's run the following Kubernetes command. Let's do kubectl apply -f job.yaml, and the job.yaml is a file that is already into the KubeBench main folder, and this file is used in order to run KubeBench. Let me show you how it looks. So this file is pretty much a component, and this is a job component, and here you have everything that you need for installing KubeBench. Okay, so let's run that command, and now you can see that a KubeBench job has been created, and you can easily see it by clicking the Minikube dashboard. So let me show you how this is done. You open a new terminal and let's do Minikube dashboard, and now a new tab will be opened with the dashboard, and you can see that we have one job that is scheduled with the KubeBench. So you can see that now KubeBench is actually up and running in your device, and you can use it. So once you ensure that this is up and running, let's go back to our terminal and let's write kubectl get pods. Okay, and you can see that here I have a couple of pods running, and one of them is the KubeBench pod, right? So you can verify that this is completed. Okay, so since here our status is completed, then we can do kubectl logs and then KubeBench, and then actually this ID here. So you can even copy and paste that. You can simply do Ctrl+C and then Ctrl+V. Okay, so let's run that. And then you can see that we've got some output. You can see that the KubeBench performed 61 checks, that 61 were passed, 12 were failed, and we got 52 warnings. And if you go up, you can see actually all the information that the KubeBench will provide to you. So you can see that there are many points, and those are the different vulnerabilities that could be found in Kubernetes. And what you simply need to do is to go over them and make sure that you follow them. So they will really give you a straightforward instructions for commands and for ways that you can improve your security. You can see they start from 1 until 5, I think. And after every section, you see how many checks have been passed. For example, from section 2, we have 7 tests passed. From section 1, we have 38 passed, but 11 failed. So this would mean that there are 11 checks on which we could work in our system. And you can pretty much see the pass and the fail result in most cases on the left hand side. And then on the right hand side, you can see the configuration related with those passes and fails. So if you want to use KubeBench in order to improve your Kubernetes, you can definitely run it and go over the instructions, specifically over the ones that have been failing. So this is how, guys, you can install and use KubeBench to see how your system performs currently, and to get a very good instructions on how you can apply the CIS guidelines into your Kubernetes with a very direct instructions. So that's it. Thank you very much for watching that video, and in the next one I will mention some very useful Kubernetes security projects that you can use in your system. Thanks for watching. Now let's see some of the other security projects that are used for analyzing vulnerabilities in Kubernetes. So in this lesson, we'll review some different security projects that can help us both to secure Kubernetes cluster and that will also offer the best possible performance for our infrastructure. And the first one is called KubeHunter. You can find the complete code on github.com, KubeHunter, and it basically represents a security framework that is taking into account that Kubernetes clusters are mounted on a set of nodes or services in which at least one has to take role as a master, and the rest of those nodes are workers and they have visibility of each other in order to communicate. So the Kube Hunter is a Python script that is developed to analyze the potential vulnerabilities in the Kubernetes cluster. As most of the other tools, this tool relies on known attack vectors and information about the attack surface, so it allows you to perform security vulnerability analysis of your Kubernetes installation. It also allows both remote, internal, or CIDR scanning over Kubernetes cluster, and it can be run locally or through the deployment of a container that is already prepared. So in order to install Kube Hunter in your device, you can simply do pipe install Kube Hunter. Okay, so hit that, and you can see that for me the requirements are already satisfied, but for you, you will get some sort of installation since you don't have Kube Hunter already installed. So this is how you can install it, and then you can simply follow the instructions on the Git repository. Now, another quite useful tool is called KubeSec, and KubeSec allows you to analyze the security risks for Kubernetes resources. It will help you to quantify the risk for the Kubernetes resources. It always runs against your active Kubernetes application for all the deployments and pods, and also you have a specific plugin if you want to run it from the command line with the kubectl. So some of the main kubectl tools that you can use actually directly from the command line is firstly the kubectl trace that you can find it in this link here, and this tool will create control points in order to detect problems and make in-depth analysis of your Kubernetes infrastructure. Another quite popular tool is the kubectl debug, which is a plugin that actually can be perfectly combined with the kubectl trace, and it's used for debugging tasks. It allows you to execute a container within a pod that is running. It normally shares the namespace of the processes, network, user, and pretty much everything related to the container, and that information can all be analyzed and debugged. Another quite an interesting tool, which you can also find and download from GitHub, is the ksniff tool. This lets you to analyze all the network traffic of Kubernetes pod using the TCP dump from Wireshark. If you haven't worked with Wireshark, this is a tool that allows you to explore the traffic of any type of application and showing you the TCP, SMTP protocols, pretty much everything on your network, and you can apply that to Kubernetes too. So the ksniff uses the data collected from the TCP dump associated with a pod and then sends it to Wireshark to perform analysis. This plugin is essential if you're working with microservices, since it is very useful for identifying errors and problems between them and their dependencies. Then you have the kubectl dig, which is another plugin for the kubectl, and sometimes getting information from Kubernetes cluster requires the use of several commands, which in turn returns all kinds of information. So this plugin has quite nice user-friendly interface from where you can easily see the information related with the Kubernetes cluster. So let's actually look on one of the most used security tools for Kubernetes, and this is the KubeStriker. So this tool is created to tackle the key Kubernetes security issues due to misconfigurations, and really helps you to straighten the overall IT infrastructure of any organization. So it performs in-depth check on a range of services and can be used on either self-hosted Kubernetes on Amazon, Azure, or Google Cloud. It will pretty much identify any miscellaneous attacks and make it easy for the organization to identify them. So it would really help you to straighten over potential attacks, whether you're using Google Cloud, AWS, or Azure, and it will provide you with very nice visualizations and prevent the hackers to advance their attacks. So let's see how you can actually install and use this tool in your device. So let's open a few terminals, and I want you to run Kubernetes cluster and Docker as well. So let's run minikube start, and actually before that let's run Docker. Okay, so once you have the Docker up and running, in your device. Let's wait a couple of minutes. Okay, and then run the Minikube. Then I'll open another window. And so once this is installed, let's run the Minikube dashboard. So write Minikube dashboard, that's it. Okay, so once you make sure that you have all that, then you can install the Kube Striker. So in order to install it, you need to run this command. I'll provide this for you. The only difference from my installation will be that you actually need to specify your path here to your username. Okay, this will pretty much show where you want to save your installation, and it creates a volume. You don't need to use specifically the directory that has your name on it. You can use any, but please make sure that you keep the lines that are after that. Okay, so let's hit enter here. Okay, and you can see that immediately you started the Kube Striker right here. And if I check in Docker, you have Kube Striker installed container that is up and running. So then run python -m Kube Striker, and this will actually start the Kube Striker engine, as you can see. So from here you can choose different options. So you can choose URL, IP, config file, or IP range. So let's choose IP, and so the tool will ask you to provide an IP here. You can do that by opening another terminal and simply writing kubectl get pod-o white. Okay, and this will show all the pods that are currently running, and you can see their IPs from here. Okay, so I'll copy one IP and I'll paste it here. Okay, and now you can see that our vulnerability checks will start. So we're performing service discovery, we're scanning the Kubernetes cluster and the services, and you can see we're scanning the etcd clients, the kube proxy, and so on. So this tool will pretty much automatically perform a good check of your Kubernetes services, and then it will send all of your results in a target file. So this file will normally be saved in the same directory in which you open the application. So in my case, this will be saved on the desktop. So now from the other terminal, if I go to the desktop and do ls, you see that we're actually having a file that is with the same IP address and it's txt. Okay, so you can go to your desktop and just open that file, and from there you can check if you found any endpoints into this IP. Since this IP that I used doesn't have any endpoints, your file will simply show the scanning, and below you will see nothing because you don't currently have endpoints to this IP. Okay, so make sure that you explore also the rest of the options of this tool, because it's really amazing. And if you need an IP, you already saw how you can get one, and explore the different commands. So that will be everything for that video, guys. Thank you very much for watching, and in the next one we will talk about how you can analyze the Kubernetes vulnerabilities. So let's see how you can actually analyze the vulnerabilities that you already found in Kubernetes. So in this video, we'll review some vulnerabilities that we can find in Kubernetes and show you how those security vulnerabilities were solved. So in the same way as we did for Docker, you can actually see all vulnerabilities related to Kubernetes into the cvdetails.com website, where you can simply go to the Kubernetes page and see all the vulnerabilities found throughout the years. So for example, you can see in 2022, there were still about 11 vulnerabilities found in Kubernetes. While the worst year probably was 2019, when you had 16 vulnerabilities exposed. And of course here you can see a very good graph by year, so you can get a good understanding on how Kubernetes was performing throughout the years. So maybe one of the most critical vulnerability for Kubernetes is the CVE 100.2105 found in 2018, and it was identified in the Kubernetes API server. So this vulnerability would allow any authenticated Kubernetes user to obtain administrative access to the cluster using standard security strings, and allows the escalation of Kubernetes privileges through specifically designed proxy request. If you want to see the affected Kubernetes versions from this vulnerability, you can, for example, go to the Red Hat website, and let's say for the Red Hat, you can see this vulnerability And if you scroll down, you see all the versions in which this was fixed, and also versions, if you go back, that this vulnerability was existing. So sometimes it is a good idea to check the website of your operating system, so you can check if a vulnerability is still present in that system. And if you know that your company can be in risk because of a certain vulnerability, you can make sure that from those websites of your operating system, you can find whether you have or you don't have this vulnerability present. So this vulnerability has already been solved by the Kubernetes development team, and it is recommended to update your Kubernetes versions to the last one so you have it fixed. And you can find the information for fixing this vulnerability on github.com, where the Kubernetes team have explained very well on what the fix is and how it might affect the operating systems that people are using. So another critical vulnerability was actually found in 2020, and this vulnerability enables an attack called man-in-the-middle attacks. During that attacks, the attacker can interpret the network traffic and intercept it to a pod in the Kubernetes cluster, and in that way he can find quite valuable information for clients. The vulnerability was found in all versions of Kubernetes up to until version 0.8.6. This would allow malicious containers in Kubernetes cluster to be used to perform these attacks. So to do that, the malicious container can send a flow of IPv6 router advancements to the host or other containers and redirect the traffic to the malicious container, from where he can exploit all the information the attacker needs. And the last vulnerability that I want to discuss with you guys, it is the vulnerability with the pod security privacy. This vulnerability allows you to bypass the pod security privacy on any Kubernetes cluster. So in Kubernetes, the pod security privacy is one of the resources that allow the administration controller to decide whether a pod can be created by a service account depending on the configuration. For example, if privileged mode pods are not allowed in the pod security policy, any pod that tries to create privileged mode from that service will fail. This usually works, but some security audits have found cases in which the monitoring of the host path volumes is done instead of using a persistent volume. So this restriction is not taken into account if you are working with present volume claim or PVC. The result is that any user could mount a directory of the host machine from the container and have access to the file system, managing to escape from the container. So the solution of this vulnerability was to enable the pod security privacy, not to limit the types of persistent volumes, and this should only give allowed user access to the cluster resources. So this was everything from this video and that section actually. I hope now you're aware for some of the key vulnerabilities and also how you can audit and analyze your Kubernetes vulnerabilities from the terminal. That's it, thank you very much for watching, and I'll see you in the next video. Hi everyone, and welcome to this section where we are going to talk about how you can monitor Kubernetes using the Kubernetes dashboard and cluster. Observing and monitoring is one of the most important parts of the maintenance of the applications, because it is very important to get metrics of the application behavior. And monitoring is an essential part of the infrastructure. Thanks to monitoring, we can actually obtain information in order to take scaling measures, and this will help us understand what is happening in our cluster behavior. So by definition, monitoring is a real-time process that includes the collection, processing, and analyzing of any data in the system. It saves money and it involves many aspects, from knowing the status of the infrastructure to having a complex system that can be anticipating any type of events depending on what your company needs. So monitoring is something purely technical and has become a very good way for obtaining valuable information and improving the conditions for the customers and reducing cost. It helps us to evolve our products, and even creating new ones. So when constructing a new monitoring system, it is important to take into account the objective that we have for the users and for the information that we want to build. Once this is identified, we can define the matrices and the tools to help us collect the data from each part of the application. So currently the development or the architecture of microservices is one of the strongest and the most relevant technologies to monitoring. So microservices architecture can grow rapidly, so we need to know that everything is working correctly. It is also important to determine if our system is degrading or if, for example, we are not capable of completing service level agreement. So the monitoring of our system will constantly provide us with metrics and values to analyze the correct operation. In recent years, many platforms have emerged to be able to know if all of our development is working as it should. At this point, observability is considered as the new form of monitoring. So observability is all about when and why an error occurs, and it has four fundamental components. First one is the open instrumentation that collects vendor-specific or open source data from a service, host, application, container, or any other entity in the produced data. This enables full-phase visibility for critical infrastructure and applications. It also prepares teams for the future as you introduce new products and data types to the system. Then we have the correction and context, because the collection of data must be analyzed so that all data sources can be connected. You also need to incorporate metadata to allow correlation between various parts of the system and your data. Together with those actions, you also need to create a context to shape the monitoring. Then we have the programmability, because the organizations need the flexibility to create their own context with custom applications based on their goals. For example, an application can help teams to calculate and visualize the impact of errors on the end user. And finally, something that's a bit separated from the first three is the artificial intelligence and IT operations. So unlike the traditional incident management tools, the AI solutions use machine learning models to automate the IT operation process. We can automatically correlate, add, or prioritize incident data into the AI. So the Kubernetes cluster already itself exposes cluster matrix, and Kubernetes has matrix server that is an aggregator of data on the use of resources. So for example, the kube state matrices exposes data obtained from the Kubernetes API. So other tools like Prometheus that we will talk about in this section can collect this data and can consume the API. And here's how it looks. The cluster has the matrix server, and the matrix server is connected to the command line interface, and then we have the API server, which is going to send our data to external devices. And then the API server would communicate and exchange information with, let's say, Prometheus. So monitoring the containers allows us to know the status of each container individually. But the problem of having multiple containers arises when creating a cluster. So reviewing all of them can be quite difficult, and sometimes you could be exposed to quite a few errors. Within the Kubernetes cluster, multiple objects can be running consistently. So a single namespace with a service included can be monitored. In addition, the containers might disappear from the moment that the error occurs until the moment for debugging. So for that reason, creating log files is quite important for you to keep track on what was going on with your system. Despite this, Kubernetes has a great capacity of automatically recovering from failures, such as restarting a pod or balancing the load between the different nodes. However, sometimes it is not enough, so this process should be performed manually. For those cases, it is necessary to monitor the execution of the cluster using different tools. So there are two main factors to decide how you can monitor. First of all is what can be monitored, and the second one is how to do it. So Kubernetes itself already offers the capability to know what to monitor. The first one is the CPU usage, and even in Kubernetes you can see the CPU usage when you're deploying a container or a cluster. Then also the memory usage is quite important because it shows the amount of memory available and the one used by both the free memory and the one that is cached. Kubernetes also indicates the disk usage, so the lack of disk space can cause a failure in the execution of the program, so we should always keep an eye on it. Then it also gives us information about the network bandwidth. Although it seems impossible to consume all the bandwidth, it is important to monitor if there is a suspicious behavior, because sometimes you can get an attack that is trying to fill your network bandwidth completely. And finally, it shows the pod's resources, so you can assess the different resources that a specific pod is using, the information being used by the scheduler and the placer of the pods, and where you have available resources. So the easiest way to monitor those things is to actually use the Kubernetes control panel or the dashboard, and let's see how we can actually assess it and use it. So since we are already using Minikube, you can actually see that if I go to the terminal, we already launched the dashboard in the previous section, so you can simply do Minikube dashboard, and this will open an HTML file with the dashboard of all the services that you are currently using. Now, if you completed the previous sections, you already have information in your dashboard because we are creating quite a few applications so far. So from the dashboard, it is quite nice that you can perform certain actions without the need to interact with the command line. So if I click, for example, those three dots here, you can pretty much restart, edit, scale, or delete your deployments, your jobs, your pods, and your replica sets. Okay, for example, if I want to delete this replica set, I can hit delete, and after a certain period of time, this will be completely removed from our device. Another interesting thing that you can see is, for example, if you click, let's say, the delete command, you can see the exact action that is relevant to that command. So it would be the same if you would write this from Minikube. Okay, so this is pretty much performing exactly the same action as the one that you would perform from the command line. So let's see if our dashboard is actually showing the correct information. So if I open a terminal, let's say right here, let's check, for example, the number of nodes. So you can do kubectl get nodes. So you can see that we're having one node, which is the Minikube, and let's do get pods. Okay, so here are the pods. We have about 7 pods, and if you go here, you can see that we have exactly the same number. So there are 5 running, 1 is scheduled, and 1 failed. So if you go into the deployments, let's for example go to our my app function right here, and when you hit it, you can see when it was created, how many days ago, what is the ID, the status of the pods, and some additional information. If I go back, I can also see the image, which is ng-inx. I can see how the app is called, when it was created, and if I hit here on the options, you'll be able to see the same options right here. So if, for example, you hit on the edit button right here, you'll be able to see the YAML file, okay, which is the file that actually creates that deployment, okay, and you can actually edit it. You can edit your application directly from the file. This is of course a bit dangerous because you don't have to do any typos in order to be able to edit this file. And as you can see, you can also see this file in JSON version. If you are more familiar with JSON, you can also do that from there. So this is how you can edit your deployment. After the update, your app will be restarted and you'll be able to add the new features from that file. So you can also check, if you click here, all of your deployments, jobs, pods, replica sets separately on a dedicated tab. You can also click, for example, if you go on cluster, you can click on namespaces and you can see all the namespaces that currently exist in your device. You can see the nodes, which as we saw, we have Minikube as a node, and so on. I really advise you to really try to explore the dashboard yourself too, so you can spot some tools that might be suitable for you, your job, or your company. So that's it. Thank you very much for watching, guys, and I will see you in the next video. So once you already got familiar with the dashboard, now let's talk about the Prometheus tools. Now Prometheus is an open source monitoring and alert toolkit that was developed in 2012 by a company called SoundCloud. Now it is an open source tool since 2016. Prometheus is constantly reading the required data from your Kubernetes installation by corresponding with the API. So the software can send alerts according to some pre-configured rules to a manager called Alert Manager. So the Prometheus Manager is in charge of managing the alarms, receiving them and sending them to another application in change of transmitting the message. It is also possible to use another software that allows you to view the data that comes from Kubernetes. Not only Prometheus can manage alarms, but also it can group alarms and also can send alarms to other applications. So if you want to check out Prometheus webpage, you can go to github.com Prometheus, and from there you can get that tool. So Prometheus allows two types of possible rules to configure and evaluate your application in predefined times. Those are the recording rules and the alert rules. So the recording rules will allow you to execute actions that are required repeatedly or are computationally expensive to save the complete result, while the alert rules allow you to define conditions under which the program will send you notification. These alerts have to be written in the Prometheus language for Prometheus to be able to understand and execute the alerts. So the software contains a local database on the disk to store corresponding data, but it can also be used on the remote systems. There are several functionalities to make a Prometheus, and the first one is the Alert Manager, which manages the alerts sent to the application or the Prometheus server itself, and the second one is the Prometheus Operator, which provides monitoring definitions to the Kubernetes services and the Prometheus deployment, making the configuration with a cluster native by managing the necessary instances. So one of the outstanding advantages of Prometheus is its query language, which is quite flexible. It also has a pull model for metric collections and a discovery service for the objectives that really helps for facilitating the integration with the tools such as Kubernetes and others. So let's have a look at the Prometheus architecture. Now Prometheus works well to record numerical time series, for example those based on time series data, both machine monitoring and microservice based architecture monitoring. So one of the first main features is that it provides multidimensional data and a very powerful query language which is called PromQL. It also collects information from more than 5,000 metrics automatically with zero configuration, zero dependencies, and zero maintenance. It also offers 4 types of matrices: counter, gauge, histogram, and summary. So Prometheus is made up of multiple components, which includes the Prometheus server, which is the core, and the main component in charge of collecting and storing application metrics in the time series database. Then you have the service discovery, so it can auto-discover applications automatically in real time. It's essential when working with containers that were consistently changing their IP addresses. It also has client libraries, and those libraries are pretty much in charge of exposing individual matrices of the applications to be monitored to Prometheus format, so that they can be collected and run by the Prometheus server. And finally, you have the Alert Manager, which manages the alerts that have been sent to Prometheus. Now you also have a connection for data visualization tools, from where you can have better visualization of the Prometheus data using external tools like Grafana. So in order to download Prometheus for your device, what you need to do is to go to prometheus.com and actually .io, and then download the version for your device. For example, since I'm using Mac, I will download the Darwin zip file from here, okay, and it downloads almost instantly. So if you unzip the file, then you will have this folder here. So once you have Prometheus downloaded, let's create the Prometheus namespace. So let's do kubectl create namespace Prometheus -system. Okay, so now the namespace is created, and you can see that here you have a new namespace called Prometheus system. Then let's navigate to our Prometheus installation. Okay, so to the folder that the file is unzipped. Let's double click the Prometheus file right here, okay, in order to enable it. It will take just a few seconds, that's it. And make sure that you copy and paste the Prometheus file into your root directory right here. Okay, so I will do that. So let's copy this file and just paste it in the root directory. Okay, so you can see that if I go to do ls here, I will have the Prometheus YAML file that I copied and pasted in my root directory. So once the file is in the correct folder, then hit the Prometheus right here 2 times. And now the Prometheus should start in your device. Okay, as you can see here. So if I go back to the dashboard, you'll see that the Prometheus system is still active and up and running. Or alternatively, you can simply run it from the installation folder by writing prometheus --config.file equals to prometheus.yaml. Okay, that should have exactly the same result. So now, once this is done, if you write curl localhost 9090 matrix, you will be able to see all the matrices that Prometheus is using. You can also access that from the browser as well. So if I do localhost 9090, okay, I will be able to access Prometheus, and you can see the dashboard quite easily. Or if you do matrix, okay, you'll be able to see all the matrices and analysis that Prometheus is monitoring on your Kubernetes installation. So you can see that from here you can check for graphs, alerts, once you connect Prometheus to your application. So right now Prometheus is running locally, and so you're able to find information such as the runtime and the build information, TSDB information, configurations. You can define the different rules and then look at them, targets, and so on. So for example, in order to create a queue, you can go to the main Prometheus page, and here in this search you can pretty much select this icon here, and this will give you the ability to enter queues about collected matrices. So for example, if I use this metric go namespaces freeze total, you can find that there is one endpoint here that's on the localhost 9090, and this is the Prometheus endpoint. You can also explore graphs, as you can see, for the particular endpoints, and you can see how the particular queue evolves over time and how it changes. So this is a very good way, guys, for you to explore and monitor your application by doing queues and connecting Kubernetes to Prometheus. That's it. Thank you very much for watching that video, and I will see you in our next challenges. Now, in today's video, we're going to talk how you can collect and explore matrices using a Grafana as a supplementary tool to Prometheus. So Grafana is an open source tool that lets you display graphs and data collected from Prometheus, InfluxDB, and many others. Those metrics can really help you to set reasonable performance targets, while the log analysis can uncover issues affected by your workloads. So there are two main types of matrix in the Grafana dashboard. The system matrix include the CPU, memory, disk for both master and Kubernetes workers, and also at the same time the cluster matrix includes data at cluster level for Kubernetes C-advisor endpoints. The matrix, for example, can be exploited in a dashboard, which will help us understand the performance and behavior of our infrastructure and at low levels. Those metrics will help us determine if the system or performance is degrading and can cause the system to fail. It's important to use low-level data to help us prevent failures before they occur. So Grafana will also make it easy to obtain data from different data sources, which can be mixed with the same dashboard. You can also define alert rules visually for the most important matrices. You can see stuff such as CPU usage per node, RAM usage per node, and file usage per node. So let's see what Grafana is and how you can actually use it. So let's go to grafana.com, select my account, and you can see that I already have an account here. So if you don't have it, create one and then access your dashboard. Then go down here and launch Grafana. So then you get that page where Grafana is launching and now it's loading from your browser. And then from there you can select collect data, and from here you can select hosted Prometheus matrix. From here you can set up your Prometheus. You can install Grafana to your operating system and set a configuration. And in that way, the Grafana will get all the information from Prometheus and will actually use it to give you a very good insight into it and give you some amazing graphs. So if you go back to collect data sets, you can also select the data source here and just make sure that Prometheus is also your data source. Right, so hit on that and you can see that already I have this installed, but you can create a new Prometheus data source and define the port. So here we have the localhost 9090, which is exactly the one we use. Okay, then you can select a timeout, a name of your application, a method that you want to use, and so on. So this is how, guys, you can use Grafana with Prometheus. It is really easy to set up and install. Even for Grafana, you don't actually need to have any installation in your device. And finally, I want to just explore some other tools that you can use instead of Grafana for analyzing your data. So the first one is the Datadog on datadoghq.com, which is also a tool that can be used to obtain performance matrix in applications and event monitoring. Also, there is the New Relic tool, which also allows you to measure the performance of applications beyond the cloud and allows you to analyze and visualize different metrics in the software development environment. Then you have the InfluxDB, that is considered as a database that stores time series. These databases allow you to store and evaluate data from sensors and protocols with timestamps for a certain period of time. The main advantage of these databases is that they are much faster than the standard databases for storing and processing data with timestamps. And the final one is called Splunk, and this is actually a really popular tool. I've been using it myself. This is a big data software that can capture, index, and correlate log data. It is also capable of monitoring data in the log files and generating charts, reports, alerts, and so on. So this was all the visualization tools that I wanted to discuss with you today. Thanks for watching this video, and this is actually the end of the course. I hope you really gain a very valuable experience, and now you know how to add security capabilities to your DevOps applications. Thanks for watching, and I will see you in the rest of our courses.